Hello, everyone, and welcome to Flutter Vikings February 2022. Hi, Sarah.
Hi, Majid. Hello, everyone. Oh, it's so good to be here.
I am very excited. Like I have right now, my heart rate is, I think, above 160. I don't know, maybe. Very excited. So we've been preparing a lot for today's conference, and I hope everyone will enjoy. Right,
I
Sarah?
think they will. Absolutely. How can you not? We've got such a great lineup.
All right, great. Then let's get to a little bit of introduction to our conference for the next 2 days together with Sarah. And then we will start our talks. So let's get it started. Sarah.
All right. So before we dive into everything, we should just remember that this is a safe place for everyone. We want to welcome all programmers of different genders and backgrounds, and let's just all be nice and respectful to each other. So we have a code of conduct where we just ask that you are kind, be good people. We know you are. Just, we have a platform where you can chat and interact. So just be nice to your fellow Flutterers there, please. Thank you. So now that that's out of the way, let's talk about the program. We have 7 hours of content of just fantastic speakers for today and tomorrow. And in between, there are some activities. And also, you are probably on the platform right now. I hope you are. You got an email with a link to it. And there are just rooms you can go into where you can do all kinds of fun things. So we'll talk more about that later. But there's a lot of great things lined up today. So hope you'll stick around. Majid?
Yes, and while no online conference is actually exciting, well, if there is no swags, activities, entertainment and stuff like that, we tried again in this edition, an online edition of Flutter Vikings, to provide so many activities. So you can go to our website, fluttervikings.com/activities, or if you are already on our platform, so you can actually go to Valhalla and you can find activities, and then you can actually read over there, right in our platform. You don't need to leave our platform at all. But all of these activities are exciting because they have so many prizes. So we're going to give away Dash for sure. Those dashes sitting there, they will fly to you, hopefully by end of this conference. So we're going to give away free Flutter in Action book. We're going to give away Flutter Vikings t-shirt, Flutter t-shirt, stickers. We have book readers for you. You can check out our activity page. We have cash up to 4,000 USD. Just check out our activity page. We have noise cancellation and many more prizes that you can win. Stick with us whenever we have activity session and join us over there and win something. Or you can already go to activity page and start your activities. And one more thing that is very important that Sarah will tell you about the booking reference.
Okay, so you've hopefully all gotten your Tito ticket, and from there you should have gotten a confirmation email, and that includes a booking reference. And you can see it handily highlighted on this slide here. And in order to participate in a number of the activities, you use the booking reference. So just keep that handy so you can jump into those activities. So let's talk about this platform a little bit because it is super fun. I can't believe Majid put this all together because he was so sad that we couldn't do it in person right now because of Omicron. But, we've made the best of it, and we've got this great online platform where you have these different rooms and you can go and hang out with Odin and go into the woods and walk around, and there's really cute things you can do there. You can put on little hats and take selfies with other people, and I don't know, you just got to go and explore it. when you have time. And also, when you go to the main stage, I should mention that there are like reactions that you can do while the person is talking. And I think I can tell you it will be very encouraging to the speaker if they're getting some kind of feedback, because it's nice to know that people are listening and pay attention. So if you love what you're doing, give it a little heart, and just enjoy the platform in general. So that's it.
Perfect.
And please, if you're on Twitter or LinkedIn someplace and you want to just tell people about watching Flutter Vikings, then do it with the hashtag Flutter Vikings and at us, and just say hi, and we'll have a Twitter wall of all of the cute Viking selfies that people post. So go at it.
Great. And well, we need to thank all of our sponsors: Google, Invertase, Stream, CodeMagic, Superlist, Rebel Studio, the AdSign Company, Very Good Venture, Software, Devangel, Bouvet, and Microsoft, and Manning Publishing. So all of these sponsors were very generous to help us to manage and bring you the best conference ever. So thank you all of these sponsors. Please go to the sponsors area. We have a sponsors area in Valhalla. You can meet all of our sponsors over there. They are already over there. You can talk to them and ask your questions if you have any. And with that said, so I think we should say, enjoy the conference. There are a few things that I want to quickly mention. Is that tomorrow we all know that Flutter team has a big announcement. We will broadcast the same announcement in our platform. So if you don't want to leave our platform, you still can watch that announcement. So no problem whatsoever if you stay for tomorrow. We're going to have some live session today. Make sure you join. Those are very fun live sessions. You can actually play some games at the end of the day if you have time. And also, make sure you, as Sarah said, take your picture with us, post it on social media. We are actually looking our social media. We are checking whatever is happening in our platform right now. And we try to hopefully find the best out of these pictures, right? And then give away some swags and, some gifts to you. So be interactive and do something with our platform. We also have a photo booth in our platform. You can go to Valhalla again and you will find a photo booth over there. You can take a picture and share your pictures, so you can have a lot of Vikings props that you can add to your picture. And with that said, I think, Sarah, we should say everyone should enjoy the conference. And there is a lot going on. This platform will stay on until tomorrow. So you can come back, check out our, different virtual spaces. Please be respectful and let us know if you find any problem. If you're watching us right now on just YouTube, make sure if you want to check out our virtual spaces, you need to grab a ticket, and you will receive an email that is providing you the private access to the platform. So then you can log in automatically to our platform. One last thing. In our platform, we have these icons that you can show some, maybe excitement. We have reactions buttons. So you can actually, on the main stage, you can actually press those, reaction buttons. Those are very cool. You show us some love, some likes, and, whatever we deserve it. Anything else, Sarah?
I think you've covered it. Let's get started. Thank you.
All right. Very nice. Enjoy the conference. So I'll be
Bye.
back on the screen. I'll be your MC, and I'll be back in a minute, and we will start our talks. Thank you, Sarah.
Thank you.
All right, I am back. So the first speaker, which I'm proud to announce his name, Andrea from Microsoft. He is a passionate mobile engineer for sure, and of course, working on Flutter. And one of those cool features that you have seen, like the fold layout, he is kind of also behind that. So, does your layout fold? Well, we'll figure it out. Let's welcome Andrea on the stage.
Hello everyone, my name is Andrei Diaconu. I am part of the developer experience team for the Microsoft Surface Duo. Today I am exploring what Flutter can do on foldable devices and what kind of magical experiences you can craft for your users. Everything you are about to learn today applies to all foldable devices. Most of the examples I show are Surface Duo examples, but everything works the same on all foldable devices out there. Throughout this talk, you might have questions. There is a Q&A section at the end, but until then, please use the chat as much as possible. I or someone from my team will always reply. Let's have a pleasant time and let's make this a conversation. All right, you may have noticed that mobile devices gained extra flexibility. The main advantage for users is the larger screen, but there are some other interesting considerations. There are new use cases that take place on foldable and dual screen devices. The Surface Duo, for example, has two separate screens. Using two apps side by side comes naturally. Dragging content between apps becomes easy, and users might expect that to happen with certain apps. The display is no longer one flat plane. It can bend and fold, resulting in different shapes that the device can take. One interesting consequence of this is the logical separation that happens inside your app. In this example, the top and bottom parts serve different purposes. The top part acts more like a monitor, and the bottom part acts more like an input device. This is true for devices without a visible hinge as well. From this angle, the Galaxy Z Flip looks like a tiny laptop. Even if the screen is continuous, you can delight your users by doing something special with that posture. Look at what happens when I go from flat to half opened while watching a video on YouTube. My hope is that this talk helps someone in the audience create this sort of special experience. Let's see how these display features translate into code for us developers. First, I want to introduce a new term. The highlighted areas are called display features. These are areas of the display that your app needs to know about. These features sometimes prevent pixels from being visible or just curve the display. This is why you might not want to draw anything where the display features are on the screen. Your layout can avoid them or use them as a logical separator for your UI. So let's look at the Surface Duo again. Even though the device has two physical displays, your app sees one continuous screen. Judging by the size of it, your app might think it is rendering on a small tablet. Display features are pieces of data that come from Media Query. On this device, Media Query reports this area as being a hinge. I can hear you asking, Andre, how many types of display features are there? I'm glad you asked. Displays can currently have three types of features: hinge, fold, and cutout. Let's start with the cutout. It has been around for a long time. Your code already takes it into account by using safe area. The one in the middle is a fold display feature. In such cases, the device has one single display which is flexible enough to fold. The area where this happens is a display feature, and it also provides information about the shape that the display makes. The one on the left is a hinge. It joins two displays to form one continuous screen area. Your application can render on this larger area, with the hinge acting as a natural division for your layout. The shape the display makes is called the posture. If the device is sitting flat on a table, the posture is flat. When you are using it as a mini laptop or as a book, the posture is half opened. The code I'm showing you soon will make more sense now that you know what display features and what postures are. I will also show you a few new widgets that help your UI adapt to these new capabilities, but first, let's have a closer look at how this new data is structured. Media Query gets a new property, display features. The properties exposed by this class are bounds, type, and state. The bounds is a rectangle marking the area on the screen where the display feature is located. The type is an enum and can have the values hinge, fold, or cutout. The state is the posture. It is also an enum and can be flat or half opened. Note that a device can have multiple display features at the same time. Samsung devices usually have a fold and a cutout at the same time, for example. This is why Media Query exposes a list of display features and not just one display feature property. Let's go back to the Surface Duo. You might wonder what your app looks like on this device. By default, apps open in single screen mode. Your app looks and behaves just as expected. There's no difference from a single screen phone. Apps can open side by side, and you can use both at the same time. You can even define app groups, a shortcut that opens two apps together. For example, imagine calendar and email opening together when you want to plan your week. This means that your app might not be the only one visible when it's open. Your app can also be spanned across both screens. Using this gesture, you can span any app. If an app does not look good or behaves poorly when spanned, users can of course go back to one screen. We call apps that take advantage of this form factor enhanced. Please don't worry about your app not being enhanced yet. Users always have the option to unspan. When spanned, your app sees one single screen. This whole area is theoretically available for rendering. You do, however, know where the display features are. Your app knows there's something there. By using the Display Features API, you can offer users an enhanced experience. Here are some examples of enhanced apps. Outlook shows you a list of emails on one screen and the opened email on the other. Jira uses the whole available space to show you the sprint board. You can even drag and drop across displays. You don't need to do anything for that to work, by the way. The device drivers take care of everything. Touch gestures are seamlessly transferred from one screen to the other, and your app sees them as the same pointer. YouTube uses the posture property to make the video expand to the hinge. This way, the hinge becomes a logical separation point for the layout. So, what will your Flutter app do with the extra screen? Here are a few things that Flutter does for you already. Dialogues use the first screen to render. This way, your dialogues don't end up overlapping the hinge. First screen means different things in different cultures, so directionality is used to pick the screen. The example I'm showing is in English, so the left screen is chosen. You can, of course, specify where you want the dialogue to go. You can specify an anchor point, which you can view more like a target. Imagine you tap a button on one screen and you want the dialogue to show on the same screen. You can use the anchor point for that. Pop-ups, like context menus, also work out of the box. For example, in this case, the menu would have been rendered on the hinge area. Okay, I want to dive into building enhanced layouts with you, but before we do so, it's important to understand what these layouts look like. By this point, I think it's clear that enhancing your app requires thinking a bit differently about layout. I expect most people watching this are developers, so let me give you something to take back to your designer and product manager. This is our Figma design kit. It contains everything designers need to make their ideas come to life on foldables. This is our way of helping not just you, but your whole team. Oh, by the way, our help can extend even beyond this talk. If your team is considering enhancing your app for foldable and dual screen, we are open to collaborating directly with you. Please reach out to me after the talk if you're interested. Our research has surfaced 5 main design patterns you could use to enhance your app. Really, this part of the talk is for anyone on your team, not just the developers. I'll go through these design patterns one by one, starting with the one that your app is already using today. These design patterns are useful for scaling up your design, not just for adapting to dual screen. And this is why I'm going to show you how they work on a large screen as well, such as a desktop or tablet screen. Extended canvas is useful for cases where the user can move the content and avoid the hinge area. Part of the content is hidden under the hinge. This is done so that the image is continuous. But the user can always zoom and move the content. This design pattern works best with maps, but can also be considered for image editing, painting, or other artistic apps, since the canvas can typically be moved around and zoomed into. The reason this is the design pattern that already works in your app today is that this is how maps behave out of the box. One thing you should keep in mind is that highlighting pins on the map and opening bottom sheets should avoid the hinge. The best experience for users is to center the pins on one screen instead of using the center of the map. And bottom sheets open on the same screen as the selected pin, as opposed to opening it on the other screen. This can be achieved with the anchor point mentioned earlier if your bottom sheets are model routes. The large screen version of the extended canvas does not need any further explanation, but your bottom sheet implementation might need better logic so that it does not take over the whole width of the screen. List detail is, in my opinion, the most useful design pattern from this list. I have seen it deployed with great ease and success in many apps. One screen shows a list of items, the other renders the selected item in higher detail. A practical example of this would be an email client. You have the list of emails on one screen and the selected email opened on the other screen. Users already have a mental model for this type of layout, since desktop email clients typically use it already. One thing to consider when implementing this is, again, the placement of dialogues. If the dialog or bottom sheet is related to the list or the details screen, it should appear on the same screen. Another consideration is that your list also needs to be able to render a selection, something that until this point was not necessary. Most of what I'm showing you is part of our samples project, which I will link at the end of this talk. All these design patterns have concrete examples there that you can look at. When looking at this pattern on a large screen, the proportions between the two panes might make sense to be something other than 50-50. By this point, you might wonder how this complicates your app, but I have some good news. There is a new widget called 2pane that does all these things for you already. It's just a matter of how you configure it. Before I show you the new widget, let's go through the rest of the design patterns. 2page is very simple to understand. At first glance, it simulates a book. Both screens show the same type of content. This design pattern can be used with any continuous stream of content. For example, you can view a photo album this way, or multiple security cameras at the same time. Foldables have a lot more screen real estate, and the 2page pattern simply shows more of the same thing on the second screen. When we look at the large screen version of this, we see that it remains exactly the same. Even the 50-50 split continues to make sense. Of course, if the space is not large enough, showing only one page is more appropriate. I mentioned the 2pane widget earlier. It helps with this type of logic as well. Dual view is all about different perspectives. You look at the same information on both screens, but represented in two different ways. Here we are looking at restaurants. One screen shows a list while the other shows a map. Both screens show restaurants. They could just as well be hotels or anything else that has a physical location. The analogy I like to use here is 3D editing software. It's hard to navigate 3D environments on a screen. So what they typically do is show you the same scene viewed from different perspectives, top down, front, lateral, so that you can successfully align your items in the scene. Such a 3D editing software would benefit a lot from this layout and the extra space foldables offer. Here is another example. Both screens show markdown text. The left screen shows an editor while the right screen shows the final render. If your app had to switch between editing and rendering something, this design pattern might be the easiest for you to pick up. When we look at this on a large screen, the only thing that might change is again the proportion between the two panes. Companion pane makes a lot of sense for supporting content, smart suggestions, or as with this example, previewing and modifying content at the same time. With image editing apps, users can preview their work on one screen and use the other screen for making changes. This gives your app a lot more space to work with. In this design pattern, you have the main screen where the user focuses their attention and the secondary screen which offers support. This becomes particularly interesting when the device is used in the half-open posture, making the bottom screen act more like a custom input device. You can recognize this as the design pattern that YouTube uses on the Galaxy Flip when the posture is half opened. In another example, the secondary screen could just offer extra information. You can even use it to offer tips or help. This is what the onboarding experience looks like on the Duo. You can see that the secondary screen is mostly used to support the main screen. This design pattern also makes a lot of sense on large screens, although again, the split between panes might make sense to be different. We're now moving away from design and more into Flutter code. I will link the design kit at the end of the talk, along with some other cool things. I already mentioned the 2pane widget. This is a new widget that helps with scaling up your layout. All three images below are rendered using the same piece of code. There are a few other cases not shown here that happen when you rotate the device, but all of them are handled by 2pane. So the parameters used by it are pane 1 and pane 2, which are the two children, pane priority, which can be both for showing both panes, or pane 1 or pane 2 if we want to render only one pane and not both, and pane proportion, which is a double from 0 to 1 and represents how much space each pane takes. 2pane takes a few other parameters like direction or alignment, but I want to focus on just the priority and proportion for this talk. All these parameters are overridden when the device has a display feature like the hinge. So the parameters you give this widget are mostly for large screens. This way you can focus on what the app looks like on tablets and desktops, and you don't have to worry about the dual screen devices in particular. All the images I've shown you are built with 2pane. Let's look at the code I used. You will notice that most simply make sure the screen is large enough, and some specify a custom proportion. Here is list detail, 2page, dual view, and companion pane. On this last one, I also want to show you that rotating the device simply works without the hassle. 2pane is not a complex widget. You can easily replace it with a column or row, but because it also snaps into place on dual screen devices, it introduces spacing to avoid the hinge, and it adapts to device rotation. We hope you will consider it useful and give it a try. Another widget I want to quickly mention is Display Feature Subscreen. You will need this widget if you have custom modal routes in your app. When you use Show Dialog, the framework automatically wraps your layout with this widget. If your dialogues are shown using other techniques, you might need to do the same manually. A simple way of looking at this is by comparing it to Safe Area. Safe Area makes sure you don't overlap any media query padding. Display Features Subscreen makes sure you render using only one subscreen. Our plan is for everything that I've shown you in this talk to be part of the Flutter framework. We have opened a number of PRs, some of them are already merged, and some of them are still in review. If you are eager to use these features early, there is a custom Flutter fork that you can find in the link at the end of this talk. It's very easy to set up, it just takes a few git commands and we walk you through every step. On the other hand, media query, for example, is already part of Flutter Master, so you do have access to display features if you want to experiment with this today. All you have to do is use the master channel. Alright, since we have enough time, let's quickly enhance a Notepad application that I have here ready. The code is organized in multiple steps, so we can quickly go through them. This is how the app looks like. It's a list of notes. You can open each note, you can edit the title and the description, and you can navigate through the application. Alright, let's look at the code. So the building blocks are a note list that takes a onNoteSelected parameter and a note editor widget which takes a note index parameter. I won't go into much detail on how these are built. You can imagine, and I'm sure you can build them yourself as well. They are very typical Flutter code. Alright, so what happens when we span the app? The app is not enhanced in any way, it doesn't know about the display features, and frankly, if you look at it, it's not a good UI to have on such a large screen anyway. A good enhancement for this would be to implement the list detail pattern, so I'm just gonna use 2pane and give it a pane1 as a note list and pane2 as a note editor. This should make the list and the editor sit side by side, and it looks really good. But now if I unspan the app, 2pane still puts the list and the editor side by side. I don't really want this because this doesn't make any sense. So let's see what we can do about that. Perhaps we can use one of the parameters that 2pane has. So in the next step, we first want to make sure that the display has a hinge. We look at media query display features for this. And then we use that information to decide if we show both panes or just pane number 1. Let's have a look and see how this looks. So it looks okay on one screen. And it looks okay when we span it across both screens. Let's try to open a note. As you can see, this doesn't look so good. The note spans across both screens. when in fact I just wanted to change the selection on the second screen here. In this step, we make our main widget be stateful and we make it retain the selected index. We change the index when a node is selected and we give that index to the editor. So in other words, when we're using both screens, we no longer use the navigator. So let's see how that looks again. As you can see, the selection on the right-hand side changes. And if we unspan the app and select a node, this continues to function properly. Let's span the app again. The next step is purely optional and it's something that I just simply want to do. I want to have an empty state on the right-hand side rather than just showing the first item as being selected by default. To achieve this, I make selected index nullable so that if it's null, it just means nothing is selected. I don't know, it looks good. Let's move on to the next step. Now, the list doesn't show you what's selected. There's a ripple when I click on stuff, but I want it to stay selected. To achieve this, I need to let the list know what's selected. And for this, I give it a selected index parameter, and this gets drilled down all the way to the item that's rendered on the list. If it's selected, then there's a blue tint. If it's not selected, then there's no background. Let's see how this looks. Okay, this starts to look more like an enhanced app. But there's one last thing that still doesn't work properly. If I navigate from the editor when I'm in single screen and then I span, I actually reach this weird state, which normally I shouldn't be able to reach, but I was able to do it because I can span and unspan the app. To fix this, I need to remove invalid navigation states, and this is a bit of a hack, I'll admit. I'm sure you can find better ways to deal with this in your architecture, but for this very simple app, I made a route that simply pops itself if it detects that it is on two screens. I call it single screen exclusive route. Let's have a look at the emulator one last time to validate that everything works correctly. And it seems to do. We have successfully enhanced our Notepad application. I'm reaching the end of this talk and I want to summarize what you should take home with you. First, please take the design ideas to your designer and PM. You can offer them the Figma design kit and see if they find it interesting. Second, all the emulator screenshots from this talk are from the Surface Duo emulator. It's free and we do our very best to make sure the experience is one-to-one with the real device. Where this emulator differs from the foldable emulators you find in Android Studio is that this one simulates the hinge area differently. The Android Studio emulators have continuous screens, like the Samsung Galaxy Fold and Flip, and the Surface Duo emulator has two separate screens, like the real device. Normally the emulator is enough for your team to be effective, but if for some reason your app needs to be tested on real devices, please contact me and I will see what can be done to help you test. This is the link and QR code to everything I just mentioned. By the way, our team offers the same level of support for all other frameworks as well, including native Android, web, Xamarin, React Native, Unity, even Jetpack Compose. Our team is friendly on the internet and, among other things, hosts a Twitch show and also writes blog articles. If you want to be in the loop with our team, please follow us on Twitter. My call to action for you is to install the emulator today, give your app a run, and then let us know how it went. Thank you very much for paying attention. See you at the Q&A and on Twitter.
All right. Thank you very much, Andrea. This was amazing, for sure. So actually, the next talk will be by Alexander. He is a good friend of me for sure, and he's a Google developer expert for Flutter and Dart. And he's going to talk about Flutter for TV platforms. It's going to be very interesting to see if we can get Flutter on TV platforms too, right? So let me give a little bit of introduction to this talk for those who doesn't know. Introduction to Alexander. So apart from his being a GDE, he's of course experienced developers. He's been working with mobile development for a couple of years, more than 15 years. And he's also very active in the Flutter community, and especially the Russian communities. If you are a Russian speaker, maybe you want to reach him out and, talk to him. So with that said, I think we are pretty much ready for going live with Alexander. Just keep in mind two things. You have Valhalla room in our platform. Join there, and you can also experience some of our virtual spaces. If there is any problem, reach out in the chat, and hopefully we will answer you. And with that said, let's welcome Alexander.
Hello, everyone. I'm very glad that despite the difficult situation with the coronavirus, the Flutter Vikings is still taking place, even if only online. And I really hope that everything will work out and we will meet in person at the end of August at the venue in Oslo. So let me introduce myself. I'm Alexander Denisov, a Flutter and Dart GDE from Moscow, Russia. I work for EPAM Systems, where I'm development lead of one of Flutter projects and technical co-head of EPAM Flutter competency. It means that I'm responsible for Flutter development in the company from a technical point of view. The project I'm currently leading is very, very cool. And our team has got a lot of interesting experience working on it. Today, I want to share with you some part of this experience in an area that is not very much covered in the documentation. I'm going to talk with you about Flutter for TV platforms. So, let's get started. 1 year ago, in March, Flutter got a version 2.0 and gave an opportunity to develop not mobile applications only, but web and desktop applications as well. And what about TV platforms? There are a lot of different smart TV platforms for which we also can develop native applications. But there's a question. Is it possible to develop applications for smart TV using Flutter or not? If you try to search in Google or in Stack Overflow for information on the topic of Flutter for TV, you will find something like this. Since no official support is there yet, presumably you will be on your own if you try. But if you try to search in the Flutter repository on GitHub, you can find a lot of issues associated with the development for smart TVs. And not even only Android TV and Apple TV, but many more platforms. We can conclude that despite the fact that there is no official support, developers continue trying to create applications for smart TVs. Why? There are some reasons. Firstly, it's just very cool when you can take an already written Flutter application and just run it on the TV. Secondly, if you need an application that will work both on mobile phones and on TVs, Flutter development allows you to save resources. What I mean is, the more platforms using a single code base there are, the more resources you save. It is not necessary to have separate development teams for TV applications. Everything can be done by the same team. And this is great. Actually, we are not an exception. Our task was to create an application for several platforms at once. Guess how many? 6 platforms at once. Wow. Not so wow, though. Starting from version 2.0, it seems to be nothing surprising. Now Flutter officially supports 6 platforms. But let's see which platform exactly I am talking about. Android, iOS, Web, Android TV, Apple TV, Fire TV, and Tizen. Sorry, I've miscalculated. 7 platforms. Now it's time for wow. So we are just some of those developers who have created an application not only for mobile and web, but also for TV platforms, despite the fact that this type of targets is not officially supported. That's why I'm here and want to share the experience that we've gained during development. What difficulties we've encountered, what bumps we have got. Let's start with which platforms there are for smart TVs. Apple TV, and Android TV, of course. Tizen, an operating system by Samsung, is quite often found on Samsung TVs. It can also work on smartwatches and phones. WebOS is an operating system with a long history. It was created by Palm, then bought by Hewlett-Packard, where it was open sourced, and now belongs to LG, and is most often found on LG TVs. Roku TV is another platform developed for smart TVs. The operating system is called Roku OS. And finally, Fire TV, platform by Amazon. Actually, there are probably more platforms for smart TVs, but I only know about these ones. Of course, it's always better not just to say words, but also to show examples on a real application. Unfortunately, I can't show the application we are working on since this contradicts the NDA. So I've prepared an example of a simple application with responsive UI that can work everywhere, mobile phones and smart TVs. It's just a gallery of movies and TV series. If you tap on any of the movies, a page with detailed description will open. But this is just an example. I apologize, playback is not implemented there yet. Screenshots on the previous slide show us the result of running these applications on iPhone and on Android tablet. Let's now try to just run it on a TV device. For the very first launch, let's take Android TV. I experimented with Xiaomi Mi Box, but the kind of device doesn't matter. You can take any Android TV device. Actually, the launch of a Flutter application on Android TV is extremely simple because Android TV is the same Android OS. You can just open the Android TV emulator, connect the real device via ADB, and press the run button. And voila, the application just starts without any additional actions. Everything is exactly the same as with regular development for Android. Ta-da! We have launched the Android TV application. Well, now let's try to do the same with Apple TV. Moreover, an Apple TV simulator can also be selected as a target device in Android Studio. But no, the miracle didn't happen. There is an exception. This app is not made for this device. This app was not built to support this device family. Error launching application on Apple TV. Okay, let's try to understand why we weren't successful and what is the difference between Android TV and Apple TV. If you look at the structure of the Flutter project, you can see different folders for iOS and Android applications. So there is an Android project in the Android folder, and there is a prepared Xcode project for iOS application in the iOS folder. And of course, it's quite obvious that the iOS project will not run on Apple TV. There is tvOS operating system, which is actually not iOS. And as you can see, there is no tvOS folder in the project. Actually, we can open this project in Xcode and edit it. I mean, change the deployment target to tvOS, change our storyboard, and so on, in order to make it a tvOS project. But even if you do this, the Flutter application will still not start anyway. The question is why? So I've mentioned before, tvOS is not iOS. It's a different operating system, quite close to iOS in its structure and having the same basis, Darwin. But there are differences, at least in API. A part of the iOS API is simply absent in tvOS. So the Flutter engine will fall when building a tvOS application, trying to find a non-existent method. But here you can remember that Flutter is an open source framework, and if something doesn't suit us, we can go into the source code and just change it. If you look into the Flutter repository, you can find a step-by-step manual or how to contribute to the framework. Here, points 3 and 4 will be especially useful for our purposes, since there is a description or how to build the Flutter engine locally and set up the environment to use it. You can make some changes, then build the engine itself, and then build the Flutter application using your own custom version of the engine. You just need to know C++ and Objective-C, just a little bit. And then feel free to cut out calls of methods that are absent from tvOS, or edit calls of methods whose signatures are different. You can go this way, but you don't have to. There are enthusiasts who have already done it for you and open sourced it. So you can just follow the link and download the prepared Flutter engine fork. Then you still have to compile the engine locally. We also use this fork. And of course, we contribute to its development. You can even find my name in the description. Unfortunately, the engine is prepared for Flutter version 2.0.4, which is quite old, given that the current stable version is 2.8.1. But I'm sure it will be updated soon. This is open source, right? Actually, in order to try to build your first Apple TV application, 2.0.4 is quite a good option. Well, actually, I can say that the Flutter applications can work on Apple TV. It's just necessary to build a custom Flutter engine and make some changes in the Flutter project. That's it. Let's check. Voila, my simple application's launched. Hooray! You can also do the same. In order to simplify the process, I prepared the script, which will do almost everything for you. You just need to set up your environment using the custom engine, compile it, assign the path to the compiled engine to environment variable Flutter custom engine, and execute the script run Apple TV sh. Xcode with the Apple TV project will be opened in the result. You just have to press the start button and enjoy. Okay, let's move on. Tizen. Actually, the way to launch Tizen on Flutter on Tizen application is the same as for Apple TV. It's just necessary to prepare a custom engine. Only you need to edit the source code to the engine, not for iOS, but for Linux. And like previously, you don't have to do it yourself. The developers from Samsung have published the Flutter Tizen project on open source. Thank you for this. This project gives you an opportunity to build applications for smartwatches, IoT devices, and smart TVs on Tizen. But only the latest platform version are supported. Moreover, they forked not only the engine, but also the framework itself, and added their own command line interface, which allows you not to build a custom engine manually, but does everything automatically. You just need to use the Flutter Tizen command instead of Flutter command, like Flutter Tizen create to create a project, Flutter Tizen run to run, and so on. More details you can find in the manual in the repository. To check how it works, you need to have a Tizen device or install a Tizen emulator. I don't have a real Tizen device, so I checked the functionality on an emulator, but I'm sure there are no difficulties with the real device as well. My example project is also prepared for Tizen, but you need to use Flutter Tizen to run it. The next platform I was going to focus on is Fire TV. But with Fire TV, everything turned out to be very simple. Fire TV is made on the basis on Android TV with minimal changes. It doesn't even have its own emulator. You need an Android TV emulator for debugging. And for Flutter applications, everything is the same as with Android TV. I've checked on Fire TV stick and everything was fine. So let's move on. Regarding WebOS and Roku TV, unfortunately, I have nothing to say so far. We don't have to support them and at our current project, and I haven't done any research in this direction yet. Actually, I'm sure that Flutter applications can also be launched there. So if somebody from the audience has conducted such experiments, please write to me. It will be really helpful. So we've looked at several different smart TV platforms and figured out how to run Flutter applications there. But just launching the application is not quite enough. There are many different questions. For example, how do you organize the interaction with a user? You can't tap the TV screen with your finger, and you don't even do a mouse click like in a browser. You have to interact with the TV using remote control unit. Therefore, I have identified the first 3 questions that arise when working on applications for smart TVs using Flutter, and I'm going to try to answer them. The first one is how to check the platform. It's obvious that the layouts should be different for mobile and TV applications, but how to understand which platform is current if TV is not supported and not unlisted in platform class? The second question I've already mentioned in the previous slide is how to interact with users. if you don't have usual ways like gestures, and you should support a remote control unit. And the third one is about plugins. Since TV platforms are not officially supported, how do you understand which plugins can be used and which can't? Let's figure this out. So now let's consider the first question. How to understand which platform is current? There is a platform class in Flutter which allows to determine where the application is launched. So we have the issues here. Platform is Android will be true both in case of a mobile phone and in case of a TV, because Android TV is also Android. In the Apple ecosystem, the situation is absolutely similar. Platform is iOS will be true on both iPhone and Apple TV. What should we do with this? Actually, we just need to add additional information about the platform during the build. This can be done in several ways. Making different entry points, for example, like main point Dart and main TV point Dart. But it seems to me that the easiest way is to use Flutter environment variables. Take a look at this example. First, I created a TV mode variable. I provided different values for build: on in case of TV and off in case of mobile. Then I created the my platform class and used it instead of the platform. This way we can be sure which platform is current. So that's it. The first question is answered. Let's move on to the second question. It looks a bit more complicated. How to organize user interaction? Let's start again with Android TV, because there are fewer difficulties. Actually, a remote control unit is connected to the Flutter as a raw keyboard, and events of pressing the buttons on the remote are processed as pressing the buttons of the keyboard. Up, down, left, and right buttons are the same as cursor buttons at keyboard. In fact, Flutter has already got the mechanism that handles these events. This is the focus widget. The widget manages a focus node to allow keyboard focus to be given to the widget and its children. Usually, it's used to navigate between widgets using a keyboard, for example, in the browser. Starting with Flutter 2.0, you don't need to do anything to make the focus move with the cursor arrows. Focus will be moved. You just need to implement highlighting of focused widgets, of course. But if you want to handle remote control unit events in your own way, there are special classes in Flutter that allow you to do this. Row key up event and row key down event are the classes used to describe specific row key event. Row keyboard listener is a widget for listening to these events. System channels key event is a low-level channel for getting events from a system. You can add your custom listeners and handle everything you want. Take a look at this example. I've added a listener to the keyboard, which, when the cursor button is pressed, will call the corresponding method. By the way, we also need to deal with Apple TV. And there is a difference. The standard Apple TV remote control unit has no arrow buttons at all, touchpad only. And it's necessary to support not only taps and clicks, but swipes as well. If you remember, For Apple TV support, we need to use a custom engine, which means we can make changes there. So for receiving touchpad events on the Flutter side, it's just necessary to add some code to the engine that provides information about taps, clicks, and swipes to the Flutter app through platform channels. Actually, in the open source custom Flutter engine that we use, taps on left, right, up, and down sides are transformed to row keyboard cursor events automatically. And click is transformed to press enter event. So we don't need to do anything additional to support taps and clicks. The only thing left for you to do is to handle swipes in your Flutter application. It's necessary to create a platform channel instance and add a message handler to it. There you need to check the type of swipe event, and if the type is move, check the length of the swipe. If the swipe is longer than 250 pixels, the method for moving the focus will be called. 250 pixels is the most appropriate value that was chosen by the trial and error method. So this is a very simple example of management swipe behavior, but it's just code. And if you need a more complicated handler, you can write it yourself. Let's take a look how it's working. We can move focus by the remote control, and when you click select on Android TV remote or click on the touchpad on an Apple TV remote, the detail screen of the selected movie will be opened. You can also download my example and run it on the platform you prefer and check. That's it. Now we can implement user interaction. And again, with Apple TV, it's a bit different than with other platforms. Finally, the last but not least unanswered questions remains: which plugins are supported when we develop applications for smart TVs? The first is Android TV as usual, together with Fire TV, because as you can remember, they are almost the same. Everything is fine here. If plugin works with Android, it will work with Android TV, because you know Android TV is Android OS as well. Of course, I'm not talking about plugins for native functionality that are absent from Android TV, like camera. Flutter for Tizen has a page, special page with information about supported plugins. Actually, there is a list of extensions for standard plugins like battery or image picker, because Tizen is not supported officially yet. And also there are some Tizen only plugins like Tizen App Control. There are 25 plugins in total, but half year ago there were only 13. This is very good progress, I think. There is also information about device limitation. For example, the plugin for battery doesn't work on the TV because TV doesn't have a battery. An interesting moment. There is a plugin for the camera that doesn't work on any of the supported devices, because the camera is not on the TV and not on the watch, but the plugin is there. The page is very informative. Let's wait for more plugins in the future. Regarding Apple TV, the situation with plugins is almost the same as on Android TV, but there is a little difference. Some plugins work out of the box, and some don't. It depends on whether the iOS API, which is used in the plugins, is supported by Apple TV or not. But if we add an unsupported plugin on Android, the application will start. But plugin just won't work properly. On Apple TV, the application will crash during the build when trying to install a pod with this plugin. In this case, you have to fork a plugin and add the implementation for Apple TV separately. Well, now it's time for the final slide. And what are conclusions? Yes, it's possible to create Flutter applications for TV platforms. Sometimes it's a little bit tricky. For example, take a look at how many different remote controls I have had to check. Fortunately, a big part of the issues have already been solved before you. And you don't have to start from scratch. But nevertheless, there are still many issues yet. And perhaps it's your pull request that is needed for another unresolved problem. Thank you for your attention. There is my Twitter handle if you want to ask something directly, and of course the link to the GitHub where the sample application can be found. Feel free to ask any questions.
All right. Thank you very much, Alexander. This was great. So it's nice to see we can get sometimes Flutter on TV platforms. That was amazing for sure. Some people are asking like if the talks will be available on like YouTube or maybe the same platform that you are here as an on-demand videos. They will be available. Don't worry about it. So we will publish them later. So we will notify you when they are published on both YouTube. Make sure that you're following or subscribing Flutter community channel, YouTube channel, and we will publish it over there. But next talk, I'm not going to keep you waited because this is a very exciting topic. We're going to talk about micro apps, micro frontend. It's interesting topic for sure. And Wilson Blanco, he is a passionate software developer coming from Brazil with us, and he's going to talk about this concept. Let's welcome him very soon. And we will have Wilson soon on the stage. Let's welcome Wilson.
Today I will talk about micro frontends or micro apps. Hello, my name is Wilson and I'm also known as Beowulf by Brazilian community. I'm one of the Flutter community founders, which is our largest Flutter community in Brazil, where I've been a co-organizer since 2018. I work as a software engineer at F-Team and also as an accelerator mentor at Google for Startups Brazil since 2018. In the beginning, everything was a monolith, and a large part of the systems still remain in that way. If you have all your code in the same place in an organized and separate way, it will work very well in most of cases. But if you work or if you own a big company, the code base might become too messy quickly since there will be a lot of people messing around in the same place. So you probably have something like that. You have one website, you have one service that provides all your website needs, and this service consumes a database, and it works fine. But one day you need to upgrade the card feature of your service. At this time, your entire system will shut down until you upgrade that specific feature. Okay, I've been working this way since the beginning. So how can I improve this approach? We can use microservices. So microservice will help you with this problem, because now we have not just one, but as many services as we need. So probably in our sample, we will have a microservice just for a cart, and once we need to upgrade this feature, it will shut down independently from other services. Therefore, other parts of the website or system will keep working well. Okay, but what does that have to do with building Flutter apps? You know, nothing for now. But let's go a little further here. As our server evolved to microservice, this spreads was also embedded to the front-end environment. So now we have micro front-ends. And now our web service is totally separated. Each part of our web service can be a micro front-end that respond to a microservice, and it works totally decoupled from the rest of website. And this is awesome because now we can have parts of a website with different technology having reusable parts on different contexts of our website or even on different websites. And what does Flutter have with all of this? Other application can be considered a front end. Applications can be considered a front end as what the user will see. We need to adapt apps structure to use it. Once we are in the mobile environment, we can come across both names, micro front ends and micro apps. But for now, I will only refer to micro apps on this lecture because the concept fits better on what we are proposing. And this is one app that I'm working more than 3 months to have a good sample to show you. Let's go see how we can provide this with Flutter. Before we get into micro apps, let's think a little bit about how most project works today. In most projects that I've been working, that I've been seeing, MVP or simple apps, the monolith approach remains as the most applied, not being an initial problem and not a bad approach. But if you well structured and having correct divisions, but if everything gets too mixed up, it can complicate in future maintenance and also become tricky to scale the application. In this approach, the code is versioned using a single repository on GitHub, GitLab, wherever. And we see many conflicts in each PR because developers can change a class that directly impacts another developer task. And this problem can be avoided with well-made architecture, but let's ignore that for now. The mono repo aims to separate your project in several parts. In the Flutter, these parts are named packages, but they are still being versioned in the single repository. In small and medium projects, that's a great approach because the code will still in the same repository, but more organized, making the entry of new devs, the long-term maintenance, and the possible migration to a multi-repo with easy. The amount of conflicts between PR will be smaller because each developer will work in a separate package. And that's my favorite approach because it was organized as a multi-repo and had the advantage of having everything with him rich. And when we talk about multi-repo, in this approach we have better separation and detailed views of each part of our app, as each of package is placed in its own repository. Another advantage of having separated repository is that we can have teams, squads, separate, specialized in a single model. The only problem with this model, this approach, is that we have to be very careful with packages version used, because it can cause a lot of conflict, since one micro app maybe use a version 1.0 and other can use 2.0. So we can prevent this using a package just to control all dependencies using this project. We will see this when I show the project. Optimum test coverage is essential to prevent that the updated of a module doesn't impact another module directly. So this approach needs management and develops seniority to avoid future problems. I've seen projects migrate to multi-repo, but due to disorganization and versioning program, they had to back to a mono-repo approach until the teams become more experienced to go to a multi-repo again. Let's talk about and what advantage we have with micro apps. We have more than 6 advantages, but this is my disadvantage that I like to talk. The code database, as we are going to have as code very separated, this will avoid a lot of conflict because each developer will work on a well-defined feature separated from the others. Less conflicts, true. Shorter adaptation curve for a new develops. Everything will be well organized. It will facilitate to entry a new develops, and they will not need to know the whole app, just the part they are going to work on. Be technology agnostic. As well, we have separated micro apps. Each micro apps can have its own state management. We have his own dependency injection, its own way to organizing things. I prefer that the entire app use the same approach, but using micro apps, it's very simple to change. For example, you can change state management of one module, and if it was not a good idea, you can go back to that micro app and change the state management. You won't need to change the entire app to see it was not a good one. Oh, okay, best performance. One development idea. When we work with separated micro apps, we will work in one feature, we work in one module without having to run entire app. We can have a sample and run this sample to work with just one module. You don't need to start all the app to see some changes. So we have this incredible gain in the development place, being able to execute and test exactly what we are working on and how we are using micro app. First, here we have a movie app monolith, and we have how I say we have a design system separated. Here we have our widgets, and we have a core that we have analytics, Crashlytics, errors, and Firebase. And we separated this because we can reuse this in many modules. And here we have our modules that we have about, movie, TV show, splash, and inside these guys we have separated using clean architecture. We have domain, external that will access the external data, and we have an infra that communicate in our domain and external. And here we have our presenter that we have our pages and we have our widgets. So why we have widgets here? Why these widgets was not in the design system? Because you say design system is have all widgets of our application, but why here? because here we have the widgets that represent of this module, because these widgets will working just here in this module, not share with other modules. And so in design system we will put all widgets that we will need to share with all the application. And because of this we have our widgets that refer this module, in this case movie module. And now we need to turn it monorepo, and this is easy. How I separated design system and core. When I start my app, I separated and design system and core for to be easiest to move to a monorepo after. Okay, so we need, first of all, we will create a library folder that we will put our packages. Library. Now we need to navigate to this page. CD library. And now, first of all, we will create our yeah, we don't have a dependency here for now, because all our dependencies in the pub spec, we separated here, all the dependencies are here. But when we are using monorepo, we will have other packages, and don't set all these dependencies in all packages, we need to create dependency packages to have just the dependencies. So first of all, well, let's create this module, this package, and here we create Flutter, create template packaging, no, and dependencies. Oh, it's not T, it's template. And here they create a package, a simple package. We don't need to have a test folder. We don't need to have this guy. We can remove this lib2, because this package will not have any code, just dependencies. And now we can copy these dependencies here and put all here. Why do you create this? Okay, our project was on SDK 2.12 here, so we need to keep it to all packages. And now we have this, and now we will go here and we can remove all these guys. Now we will import our packages that the name is dependencies. Let's copy here. And how this is in our package is in our project and in a local folder, and we can use path and dependencies dot dependencies. But how this is in the same level of our project, we don't need dot just dependencies. But doesn't work. Why? Oh, I forgot. We need to put library because it's in folder library. I forgot that. Sorry. Yeah, here it's working. Now we can use a Flutter. Let's back to the main project. and Flutter for to get our dependencies. And it is still working, I guess. Yeah, it's working because we just remove the dependencies here and put in just one package. So for now, we can create our other packages. Now we will create a core, and here cd library, and let's use the same command, but not depends, just core. Core is a simple word, so let's create a good name. Let's put we are talking about micro apps. Let's use micro app core. Okay, now we have our core. We can have tests, but now I will remove this. First dependency we will need here. Dependency. I guess. Let's copy this dependencies. And we are not library, we are in the same folder. Here they are saying that we create a package, and when we will not publish this package, we need to use this word. Yeah, publish to no, because we are not post this in the BDD. You just put it in our GitHub. They are saying this doesn't exist. Why? Because I know this exists. I need to use this. Okay. And this is work. So now we have all the dependencies here, and now we can copy this guy. We'll copy all of this to our core. To be organized, we create a folder called source2 and paste all of here. And navigate to this guy, Flutter Object to get dependencies, and yeah, it's work. But we remove this, so now we need to import the core here too. So we can come here and use micro app core, and here the same name. And now we will have too much problem because we changed the name of micro app. We changed the name of core to micro app, and this will broke everything. And how I don't have time to fix all of this, I will open the project that I migrate that, and I will show you how it's will be in the end. So here I have the all project. We separated we removed the design system and core. We have just the module dashboard, settings, and splash. Splash we need to be here because we can preload all things that we need. We need to start Crashlytics before the app is running. We need to configure our remote config, and we need a splash for loading all of we need. And yeah, now we have here our dependencies. So we have a module TV show, and we have a movie, about, discover, and we have our core, dependencies, and design system. And we have the package, the folder library, and I separated here COF design system and core and dependencies, the three common packages that all modules will use. We separate here, and here I separated in modules that is a module of our app. So we have TV show, movie, discover, booking, and about. And here we have like a package. We don't have anything different. We have our movie that we export all the widgets we will use in other parts of an app, and we export all pages that we can navigate. And in source we have our principal module of represent this folder. So in this module we have our bindings. So we need here to register all the injections that we will need to this module. And here we have our routes, our named routes that we will use in this module. So in the main app, here we have a main module that we register the dependencies that will be global, and all modules can consume this. And here we have our HTTP client that we are using Dio, and configurations and analytics, an interface of shared preference and the shared preference. And here we have our global navigation, global routes, that refers to our modules that we create here. We have a dashboard here, and we have a discover that here, and about and settings just here. And this we have our mono repo, because we have just one repo for many modules or many packages. And this is easy to work, because if I want to know where the dashboard is using, I can here and look for, and this is easy to know all the app is using, how all the app is using. But if our company is growing up and we have many people working in the same project, so this can be a little messy, and it's good to separate some modules, some parts of our app to another repo. And I create a sample too, and this is a little more complicated, but not so complicated. We just need to pick this, to take this package and put in another repo. And I will show my GitHub for now. No. Yeah. No, I don't will show my GitHub. Now, so we just need to put our modules in one repo. But to separate it repo, first of all, we need to separate our common dependencies, that is a design system, core, and dependencies, because all modules will depend on this, and this the module can't depend the main app. And so this is the first dependency that we need to extract of here. Now I will show a separated I will show this project, but how I will work with this using multi-repo. So here you can see we have a main app that have just the main, and our modules is the same that we are using in the mono repo, but here we separated dependence in a package, in a repo, design system, another repo, core, another repo, and each module we create a module TV show, and I put movie app to be more easy to find in my GitHub when I search for this. And here we have just copy and paste the module here, and we have too much projects to maintain. And now I will show you my GitHub. Here in this repo, I have the mono repo that we have our libraries that I show first. This is the monolith that we have all in the same place. And in this repo, Coffee Movie App, we have a mono repo that we separated libraries here. And here in the GitHub, I put movie app the first in front, the name. So we can show you here. I have a movie app movie that is a module, a new module, other module, and we have dependence core. We have one repo for each model, and that is it. Let's back to the presentation. In the end, after and why not micro apps? In the end, everything is not perfect. We always have to analyze the benefits, and also the harm that an approach can offer us. And this is the why we don't need to use to migrate our project to micro apps, because we can add unnecessary complexity because our project is too small and we don't need this complexity. We will have more time setting up. We will manage the data is a nightmare. We need to see our takeaways. DevOps is more complicated because we need to have DevOps for each modules that we have or each repos that we have. And work with micro apps work best for bigger teams. So you are working alone in a project or two, you and your friend, you will not need this. And last of all, I will show some tips. We will need to learn named routes. Navigation will help you too much. You need to understand DI or dependency injection. It's good to know solid. Is a good thing to know. You will need to know clean architecture is a good one, and you need to learn how to use workspace in VS Code, and you need to learn microservices because this all micro apps will be based on microservices. So you need to know this too to improve your app. And how can I learn it? I need to look for too much reference, and I have very help on the community, and I need to learn microservice because many problems that we have today with micro apps was solved in microservices, and then we need to look there. And this is helpful links, and I have two helpful YouTube channels that I'm used to base my solutions. And that's it. This is the QR code. The first QR code will show my social medias, and the second one will show the community That's Flutterando is our community. I'm starting with this, and I'm here because of this community.
All right. I'm going to speak a little bit lower. If you have your volume too high, please lower them. So I don't want to hurt your ears. Okay. So let's continue then. Thank you so much. I'm very sorry for a little bit of bad quality of the video. We will make sure that we have a better quality and publish it on our YouTube channel, Flutter Community YouTube channel. Let's continue with the next talk. And I don't want to keep you waited. Morgan is a die-hard Flutter developer. He said so. And he's going to talk about creating your own code generating package. This is actually very exciting, especially with the future of, features that is coming to Dart. So let's take a look at the talk and see what Morgan is offering to us. So let's welcome Morgan.
Hey everyone, my name is Morgan Hunt. I'm a senior Flutter engineer and I've been coding in Flutter for over 2 years now. Today we're going to be talking about the build runner, what it is, how it works, and we'll be creating our own build runner package. So let's go ahead and get started. So what is the build runner? The build runner is basically a code generator that takes an input from our code and gives us a generated output that we'll be able to use within our code. So how does it work? The build runner will look for files that are indicated usually by an annotation saying that it needs code generation, for example, JSON serializable. When this file is found, it will take all of the information like the file name, the annotation, and the element that's annotated, like this class here, and give it to the package that is using the build runner. This package will then take all of that information and make some generated code for us and put it inside of a generated file that we'll be able to use inside of our project. This can all be done by running a simple command in our terminal. This is the build runner build command. There are two variations of this command. There is the build and the watch commands. Build will run the build runner once, while watch will listen to our files, and if we make any changes, it'll update the generated code accordingly. This flag, the delete conflicting outputs, basically tells build runner to ignore any old generated code and replace it with the new generated code without asking any questions. So when we run this command, what happens is the build runner will analyze our project. It'll start at the very top, A through Z, go through all of our files, analyze each and every one looking for specific annotations. It will run through our files for every single builder that we depend on. So if we have a big project, it could take a while to go through all of those files. So it's a good idea to isolate all of the files that require code generation into one location. Then the build runner only will check those files and it'll speed up so that way it doesn't have to check through all of our files and all of the folders. That can be achieved by configuring our build.yaml file. So for example, if we just wanted to access only these files or wanted the build runner to only check these files, we can go inside of our build.yaml file and under the generate for key and provide a pattern. This pattern is called a glob pattern, and you can look up the syntax and play with it to get exactly what you want. But basically this will tell the build runner to only look for files within the lib folder. And by doing so, it'll ignore all of these other folders. It won't even touch them. Next, if we wanted to fine tune our included folders a little bit more, we can actually exclude them if we want to. So for example, if we wanted to ignore all of our main files, these ones right here, we could add an exclude key with another pattern saying like these are the files that we want to exclude, and it won't touch those. It'll only read these 4 files. Cool. So, but why should you use build runner in your projects? Well, let's look at an example. This is a basic serialization to convert to and from JSON. JSON serializable makes it so that it will automate this whole process. So instead of writing code like this, you would write something like this. So it reduces the amount of code, and it also will do all of the checks for you. When I say do all these checks, let's look at the previous code again and look at what things I'm referring to. There are a lot of things that could go wrong inside of this, or things that you have to serialize your class properly. For example, you have to make sure that the keys are correct, that you're casting it to the right type, making it nullable when necessary, calling to JSON if the object requires. And don't forget to add that new property that you added to the class to both methods. It can get kind of hairy if you're not careful. JSON serializable will automate this whole thing for you and do all of these checks and keep your serialization up to date as long as you run the build runner. Cool, so I've got your attention. What are some packages that you could use? Well, we've already talked about JSON serializable. A package that I've created is called enum assist, and this will help you with extending your enums and make them more usable within your projects. Another one is freeze. This one's pretty popular. Makes it easier to create unions. Very, very useful stuff. There's another package that I'm creating called ice. It's a freezed alternative. It is very similar to freezed. It just opens up a little bit of the syntax and features. Cool. So can you create your own? Let's go ahead and get started. The first thing that you need to do when building your own build runner package is you need to find a problem or find something that you need to automate. In this case, what we're going to be fixing is field keys for maps and serialization. I want a central location for all of my keys, and so that's what we're going to do here. So let's first start off by creating a class and giving it a field, and then annotating it with some sort of annotation. And the generated code should look something like this, where we get the key, which is the name of the field, and we can access this generated code possibly through a static variable within our class. And then we would be able to use this in our code like so. But what if this value here needs to be in a different format, like a snake case, for example? Well, we could change this, and in order to get this expected value, we would need to update this value to be snake case. And that value is dependent on the name of the field. So I guess we could change that to snake case too, but that's not Dart convention, and that doesn't work very well. So let's change that back. And I guess one possible solution is that we create a new annotation specifically for the fields to give that field a specific key. So it could look something like that. Yeah, I think that'll work pretty good. So now we have our concept. Now we can start creating our code generation package. So using very good CLI, I've created this package. And now we got to add our dependencies. So inside of our pubspec.yaml, we're going to add our dependency, and the only one that we're going to add is meta. So let's jump over into our annotations file to start creating our annotations. This is what's here right now, so let's go ahead and remove that and create our annotation, which just is a regular class. Notice here that we have a constant constructor. It's necessary that our annotations are always constant. We're going to use an annotation from the meta dependency so that we can say what exactly this annotation is going to be used for. We're expecting this field's annotation or this field's class to only be used on class elements. And so we're going to specify that within this target annotation. So let's add the class for our target and make sure that we import that. Notice that we don't have any parameters here. So instantiating this class is kind of redundant. We could probably do it by just creating a global variable and instantiating it like this. Next, we need to create this annotation for our field, for the property, to give it a specific key. So we've created our annotations. Now we just need to export those in this project. We want to export our fields annotation and our field annotation, but we don't want to export this. So we are just going to name them with our export right here, and our annotations package is done. One thing to note, it's important that we have our annotations and our generator packages separated. Reason being is because our annotations package, as you can see, has very little dependencies. It has almost nothing. It's specific only to our generator package, which will have a lot more dependencies that may conflict with other dependencies, such as Flutter. You can't use build runner packages, or you can't depend on build runner packages within Flutter. They have to be used as a dev dependency. Let's go ahead and jump over into our generator package. First thing to start off is this package name right now currently is class fields generator. It's not written, but by convention, you can omit the generator name and just leave this as class fields, because it's implied that it is the generator. That is the purpose of this. So you can leave that off. All right, so let's go ahead and add our dependencies. Our first one is going to be the analyzer package. This is a package that helps us know the elements and their properties and their values, etc. We get all of the details of the code that is our input. Next, we have our build package, and this is like the core for build runner. And then we have our annotations package that we just created. Next, we have meta, and this is to help the analyzer. And sourcegen. This is a utilities package that will help us generate the code. All right, so let's start configuring our build runner. And we can do that by creating the build.yaml file. Inside of this, we're going to start by creating a key builders and providing an object of class fields. Now, this class fields is the name of the build runner, and typically that's also the name of the package. Next, we need to provide an import. This is going to be the entry point for the build runner. This is how the build runner is going to access our code to be able to generate code. Next, we need to provide the factory or the function that the build runner is going to use to access our code. And then the build extension. This is going to take the .dart extension and replace it with classfields.g.part. Now, we are configuring our build runner to be a shared part builder, which just means that our project, along with any other project that uses shared part builder, is going to be generated into one file instead of creating multiple different files. I'll show you how we can configure a part builder in a little bit. Next is auto apply dependence. If somebody depends on this project, then it will automatically be added to the list of build runners that they are running. So that way they don't have to go into the build.yaml and enable it manually. Next is build to cache. Instead of saving the generated file directly inside of your library, it's going to save it within our Dart tool folder and be cached there. Next, we're going to be adding the applies builder, and we're going to be adding the sourcegen combining builder, which will take all of our cached files and build them into the .g.dart file. If we were configuring a part builder, there are a few differences. The first one is this extension. This is going to replace the .dart extension. And here's an example of what that could look like. Next is build to source. This just means that it's going to be saved within your library or within your project directly, rather than the Dart tool folder. And because we're not depending on any other builders, we can omit this applies builder. All right, so we've configured our builder. Now we just need to make sure that we have the right path for our import. So here we've said that it's located at the classfields.dart file, and currently it is not named that. So we are going to just rename this file. Jumping into the classfields.dart file, this is where our factory or our function for the entry point of the build runner is going to live. So let's go ahead and get rid of this, and let's create our build runner entry point. And it has a return type of builder, and this comes from the build dependency. We are going to be returning a shared part builder, and this comes from the sourcegen package. Shared part builder accepts two arguments, or requires two arguments. One is the generator, which we'll create here in a second. And the second one is the ID for the builder that we're creating. This should be the name of our builder that we've configured within our build.yaml file. This will also be appended onto the extension of the file that gets generated right here. If we were creating a part builder, so if we wanted to create a different file other than the .g.dart file, this is how we would configure it, with the main difference being this fields.dart extension. This should match the same extension that we have inside of our build.yaml file. One thing to point out is this builder options. These are the configurations that anybody who depends on this project can configure within the build.yaml file. So that's where these values come from. The options has the key value and it's string. The keys are strings and the values are dynamic. And you can access those within the builder options. So that way you can configure your builder based on those configurations within the build.yaml file. So let's go ahead and create our generator. And we're going to start that by creating this class that extends generate for annotation. Generate for annotation comes from the source gen package. This class will be called upon for every element that is annotated with the field annotation, which comes from our package that we just created. We're going to override one method, which is the generate for annotated element. And it provides us with 3 parameters. These parameters come from the build package. Referencing our concept, first we have the element, and that is, for this, our class that is annotated. It'll give us all of the constructors, the name of the class, the fields, etc. Next, we have the annotation. And this, the constant reader, is a way that we can get the fields data. So if we had any fields or any arguments that were accepted inside the fields class, we could read those with this annotation. Next, we have the build step. Build step is the way that our builder can communicate with anything outside of the generator. So this means that we can look into the file that is being generated for. We can also create the generated file using build step. It's important to note that our generator should be very independent. It should not depend on anything that we don't already know the value to. All right, so moving on. Our element, we have specified that we only want to be using it for a class, but it's not stopping anybody from using it incorrectly. So we're just going to make sure that we do a check to make sure that the element is actually a class element. We're going to throw this error. This error is specific to generators. You should be using this throughout your generator to throw exceptions. It will print directly to the console and have everything formatted correctly. It accepts the reason as well as the element that is causing the problem. Our next achievement is to parse our element. So we're going to create a class, create a factory to parse this element. So we created the file, now we're creating the class. And the properties that we need for the class in order to successfully generate our code is namely the name of the class and the fields. We don't have the fields class yet, so let's go ahead and create a file and then create that class. The field class, we really need to just know the name of the field as well as the key, which could be the name of the field, but it also could be the annotation. So here we have the name, now we have the key. The annotation is not required for the field, so we should not be expecting that. So I'm going to change that to a nullable string and then just declare or assign the key value for our field class with the key that is provided in the constructor. If not, we're going to use the name. Moving back to our class, we're going to finish up parsing it. So we're going to create our factory and we're going to import the analyzer because that's where the class element comes from. And now we're going to get the name from the element, and that's element.ogs. That is a lot of data points, a lot of properties. I don't know what exactly we should use. I mean, we could probably guess as to what we need to use, but like I said, there's a lot of different there's a lot of data in here. And so I'm not quite sure which one it is, or sometimes there's multiples of the same thing. Like we have name and display name. Which one should we be using? We don't know. So what we can do is we can print out the element, but that is not always the right way to do things. Just because, again, there's so much information, and imagine running the build runner every time just to figure out a new data point. There's got to be an easier way to do this. Thankfully, there is. I've had to create one because I've done this many times. So what we're going to do is we're going to jump over into our pubspec.yaml and add a new dependency. We're going to add the generator test dependency. We're going to be leveraging our tests to be able to debug our project to find out what the elements properties are and what we need to use in order to successfully parse our class. All right, so let's go ahead and create our class, or create our file for our test. Let's create our test. And now we're going to use our generator test, or our success generator. And we're going to pull that in from the generator test dependency. The from builder accepts two arguments. The first one is the name of the file that we are going to be referencing within our project to generate code for. And then the next is the entry point for the builder. So let's just make sure to import that. This next part is the compare with fixture, which basically is saying that we don't have any output code that we want to compare against. So we are just going to test to see if this is generated completely. We're not ready to test any outputs. We just want to figure out what is in our element. Our final piece is that we just need to write a sync and await for our tests. So that way we can add a breakpoint and debug our project. Before we debug our project, we just have to create our example file, add an example class, annotate it with our fields annotation, and we should be good. So we have our test now. Let's go ahead and add our breakpoint, and let's debug our project. It'll run, and there, we've hit the breakpoint, and now we can look at all of the data that we have. Now, this is only a fraction of what the actual data is because it's so long I couldn't fit it on the screen. So we can see here that we have name, which is what we're looking for. And we have the fields, and here we can see all of the fields values. So now we know exactly what we need, where we can get it, and then we can parse our elements. So let's go ahead and resume our parsing. So let's go ahead and get rid of that. And now we can get the name from the element.name. And now we're going to get the fields. Quick note, it's really beneficial to use synchronous generators within your generator packages, because synchronous generators are going to create a lazy iterable, which means that we are going to be able to create this field. We're going to be able to create a list of fields, but they're only going to be created or instantiated when we call on them. So let's go ahead and loop through all of the fields, and we're going to parse it from the fields class. Now, we also need to do a couple of conditional checks. We need to make sure that the field is actually a field. And we can do that by checking to make sure that it's not a synthetic field. If it's synthetic, that just means that we have written a getter inside of our class or inside of our object. And then the next one that we need to check for is if it's static. If it's a static variable, static field, we want to ignore that too. Cool. Lastly, we need to return the class with the name and fields, and we have successfully parsed our class. Let's jump over to our field really quick, so that way we can parse this. Let's create our factory, import our analyzer, and get the name of the element. And then we're going to get the annotation from the field. We can do that by leveraging sourcegen and creating a type checker. This accepts our annotation as an argument. So we're going to write in our annotation, make sure to import that. In this case, our class that we are creating happens to be the same name as our annotation. So we're just going to name our import so that way they don't get confused. Now that we have the type checker, we can now look for any annotations of the element that are of the type field. So we're going to do the field annotation checker dot first annotation of the element, which will return the annotation if it exists. We're gonna do a quick check to make sure that it's not null, and we're going to provide it into a constant reader. The constant reader makes it so that we can read the data from the annotation. So we know that in the field class, we have a property named key, and that is a type string. So in order to get the key to parse, we need to use the reader.read, providing the property's name, which is key, and casting it as a type string to read that value. Lastly, we just need to return the field with its name and its key. And now we have successfully parsed our elements. Now we can move on to writing our generator and the code. We'll do that by creating a template and providing the subject or the class and calling generate. So creating our generator file or our template file, we're going to create a class for the template, which accepts a class as the argument, and write one function that will generate our code for us. Now there is a helpful package. This happens to be pretty verbose, and it's nothing that you can achieve on your own, but I prefer to write things on my own. And so just know that this is available. So for now, we're going to be using a string buffer. A string buffer is just very efficient at concatenating strings, just plugging them all together. And yeah, so use it, it's efficient. So let's go ahead and check out our generated code. So going back to our concept, this is the generated code that we are trying to generate. We just need to configure this. It's not quite configured to be generated yet. So first off is this class, the class name. If it can be private for generated code, if it can be private, then make it private. Try to make it private for as long as possible until you can't anymore, where it needs to be used outside of your generated code or outside of the part file. Another convention is the $sign. We'd use the $sign in front of the class name to indicate that this is generated code and it should only be consumed by the generator. If it's supposed to be consumed by a developer or a human, leave the $sign off. So because this is going to only be used within the part file, we're going to add the $sign in private. Now, what if there are multiple classes that are annotated within a single file? We have to have some way to indicate that this generated code is for a specific class. So what we're going to do is we're going to prepend the class's name to our generated code. So let's take this and use it as reference while we are generating or while we're writing our template. First thing that we're going to do is write our class name. So we're just going to create a variable. And next we need to create our fields. And we're going to map through all of the fields and write them like so. Make sure to write all the syntax, the quotation marks, the semicolon, because you're writing Dart code within a string. Don't worry, if you miss something, the builder is very, very good at its job at telling you when something's wrong, because your code is either not going to run or it's not going to be formatted correctly and it's just going to look terrible. And so it's really good at providing feedback if you missed something. All right, so now we can start on our actual template. So let's start by writing out the class. And now we need to add the brackets. And now let's write the constructor. And you might be tempted to add this space at the beginning because it is indented, but it's not necessary because the build runner will actually format your code for you. So you can leave that off and you'll be totally fine. Next, we need to write our fields. And we can do that with separating by a line break. And that's it. Like, we've created our generated code. However, this is kind of hard to read. And because it is so simple, we could probably get away with refactoring it into a multi-string. And this is a lot easier to read. It looks really nice, and it's still efficient. Congratulations. You've created your first project. You've created your first build runner. So now the next steps to this are you still have to write tests. You still need to make sure that everything is working properly. Add new features if you want to. There's a lot more that you can do. Unfortunately, I don't have enough time to go over testing, but that will be something that I release in the future. So just stay pendant. I'm on Twitter, and that's probably where I'll post it. So just be on the lookout. And thank you for your time.
All right, I'm back, and I have a special guest. My guest is actually very well known in the Flutter community. You may have seen his courses as well as his amazing videos on YouTube. He's going to run a quiz with me. Let me actually bring him up to the stage. Hello, Robert.
Yeah, hello.
How are
everyone
you?
doing? I'm doing fine. How about you?
I'm very good, very good.
Sweet.
So actually, I'm still very excited. We almost passed 2 hours and 30 minutes, and I'm still excited. That's a good sign. So
That's good.
And I
that's
want to
good.
actually remind everyone on the main stage. So you have the reaction button. Make sure you use it. Just show some love, like, thumbs up, or, those reaction buttons that you have. But with no further hesitation, Robert, let's get started. What do you have
Sweet.
for us?
So I have kind of prepared a quiz for everyone, and you can join it through this link here. Make sure that when you enter, you will be prompted to give a name. So in that case, just make sure you have the booking reference. Don't have anything else on it. Just keep the booking reference as a name. It makes it a lot easier for us to kind of make sure that you're actually winning and can get a prize. Otherwise, you won't be able to get the prize. But yeah.
Okay. Can you, Robert, go back to the previous? Yes. Perfect.
You can always find the link at the top as well. So go to menti.com and you can use the code up here. I think that will be kind of available on all the slides as well.
Okay. So you have either that link on the top, or I think it's better to scan this QR code right now.
Yeah.
Let's give maybe 30 more seconds. And I
Sounds
see
good.
people are also using the reaction buttons. It's actually very nice.
Yeah, I added
please,
some more buttons here. So not just one button.
Yeah.
Sweet.
Okay. So let's wait a bit more. And maybe you can check in another tab if people are joining, Robert.
I can
while
already
we still have this open.
Yeah, I can. I'm not sure how I can see how many has been joining. I guess the emojis kind of represent it a bit.
Yeah, sure. But I think now we waited about 1 minute. I believe people are joining.
Yeah, and you can always
Let's
find
maybe
the
give a
link at the
little bit
top as
more
well.
time.
Just make sure to use your booking reference number as well as the in the name. And then you can find you can always find the URL at the top and the code at the top. I think that will be available on all the slides. So you will have some.
Have you shared the slides somewhere in the chat?
Or maybe I can send it here.
You send this link to the chat so everyone will see that.
Now everyone can see.
There you go. So now you have it in the chat, and that's good. Okay, maybe we should move on right now.
Yeah. You shouldn't enter your name, just enter your booking reference.
Make sure you are entering your ticket booking reference, because that's the only way we can find out who you are, what's your email, and we can contact you later. Please do that. And you can maybe show the next slide one more time.
Can't enter.
So when you received an email from us, when you register a ticket, you have this booking reference in your ticket. Just make sure you are entering that right now. And I think this is This is fantastic. Let's move on to the platform, see if people are joining.
Yeah. Let's see. So
you have some gifts for us.
I have some gifts. Hopefully people say that they can't enter their name. Maybe it comes a bit later when the quiz actually kind of starts. Right now you will just kind of see that you have entered, and then when the quiz starts you will be prompted for the name. Hopefully, at least that's what, when I tested at least, you could enter that. So just make sure when you see that kind of name field, you just enter the booking reference. I have some prizes for the winners after the quiz. So the top 2 winners will get the Ultimate Flutter course that I released, I guess it's the end of last year. And then for all of the other top 20 people in the quiz, we'll also get 45% off. But kind of end with that, and let's see if we can actually make sure that everyone is... Oh, we have people here.
Yeah, so we have 75 avatars, which means this is working. Or
Yeah, we
even
have
more.
We
Wow,
have 300.
300. Wow, that is amazing. And by the way, Robert, no pressure. You know that we have around 900 people, right now watching us.
Yeah,
No
it was
pressure
a long
at
time
all.
I was in a stream now, so all the pressure.
Okay. So let's
Awesome.
wait maybe 10 more seconds.
Yeah, make sure
and-
to use the booking reference in the name field.
Yes.
It would be a shame to win if you don't have that, because then you can't win.
Yes. Shall we start?
Yeah, sounds good.
Let's go for it.
Yeah, starting countdown.
Good luck,
Let's
everyone.
see. Okay, here's the first question. What are the 3 main ways there is to test a Flutter application? So you have 25 seconds to answer. Just give your best
Okay,
guess if
I
you
see
don't
actually
know.
people are answering very fast. Look at that number. Look at that
Sweet.
number.
Hopefully I didn't make the quiz too easy. It's really hard to find questions that not everybody has already made.
Of course. Come on, everyone. 3, 2, 1. And time's up. And see, 195 people answered correctly.
Nice.
Great. Let's see who is the leader. Okay, let's go maybe to the next question.
Yeah, I think I will have a leaderboard on the fifth note or the 5th question.
Okay,
so
okay.
hopefully we can see a small leaderboard there as well. Starting
Let's
the next
continue.
one as well. So is it possible to create a monorepo, which means a single repository with the Flutter project or GitHub,
Of
and then have multiple
course.
projects inside it?
Look
So
at
is it
that
yes or
number,
no?
Robert. Look at that number. It's
That's
just
nice.
counting very fast. So amazing. Well, actually, we had a monorepo discussion a few weeks ago in my
Oh,
Twitter
sweet.
space. Let's see if people are answering this question correctly. Time's up.
Oh,
And
sweet.
yes.
Nice.
Perfect.
Let's move on to the next question.
Yes. As fast as you
Melos is a
can.
guess. What is the most state management solutions built upon originally? So maybe not many people know about this.
Oh,
Let's see how many
okay.
actually know.
That is interesting. State management is controversial, and you put it
Yeah,
on
for
the
sure.
screen. Great. So you have some 5 seconds. 289, 292, time's up.
Sweet.
It's inherited widget. So rest of you, now you learn it's inherited widget.
Nice. So moving to the leaderboard, let's see who's actually leading right now.
Wow.
Oh, sweet. Oh, that's close one as well.
This is nice.
Awesome.
You are the fastest GTFE.
Nice.
Good. Let's move
Okay,
on.
let's move on for sure. Question 4.
When was Flutter 1 released? Okay.
kind of a
I think
hard
everyone
question.
should know this.
Kind of hard thinking just about the difference in months in this time.
Of course. But I'm pretty sure many people will know the answer, and we will figure it out in 10 seconds. Let's see. So some people are thinking, I see, because the number is now getting slower to count. 3, 2, 1. There you go.
Oh,
And that
nice.
was incorrect. Actually, December 20, I think, actually, this was the time I joined as a developer for like using Flutter.
Oh, sweet.
Great.
That's awesome. Let's see the next question. So what exception do we usually refer to regarding when you have no internet connection? It's a very typical kind of issue you need to handle in most applications. As soon as you turn off your internet connection, or like whenever you have a very slow internet connection, it's a very good way to kind of handle this, or the usual way of handling this.
I guess this time 290 people will answer correctly. Let's see. 1, time's up. And whoa.
I kind of did a trick question there by adding the HTTP.
That was actually very tricky. That was a good one. Let's move on. As fast as you can.
So what is asynchronous computation? That's a kind of tricky one, but also maybe not that tricky for some of you. Or maybe not tricky at all, because people answer it super fast anyway. So
it's going very fast. I see that. Well, let's see if this time it doesn't times up and everyone answers. Let's see. Now, come on, everyone. 3, 2, 1, and time's up. Let's see what was the correct answer.
Nice.
And that is correct. Good job, everyone. So 19 of you now learned something new.
So what is feature-based folder structure? Not anything specific to Flutter and Dart, but maybe something that you will kind of see in different projects around any kind of technology. And especially something that's very talked around in the Flutter community as well.
Sure. Let's see. This is going to be exciting. So let's look at that right now. 270. Okay, come on, everyone. 1, time's up. And
sweet.
Whoa,
nice.
Perfect. 253 people answered correctly. Let's move on.
I feel like the questions are too easy now.
Maybe, or maybe not.
Can you import a package through Git without the need of pub.dev?
So this is
when you add
one.
packages in pub/spec YAML, you usually refer to pub.dev references or just write the name, but you can also maybe do it through other ways. And is Git one of those in this case?
This one actually was very good. I think many people will learn something right now. Let's look at this. Is just a prediction. 3, 2, 1. Time's up. And
nice.
Great job, everyone.
People.
Great job, everyone.
Nice. Moving on to the last question.
Let's be ready for drum roll. Okay, this is the last one.
What class is not part of animations in Flutter? So this is kind of a trick question as well. Maybe see how many can actually spot it.
Well, the number is counting very fast. I see the number of people are answering quickly. This is amazing. Right. I think, Robert, people are like looking forward to get your free courses. That's the reason they answer fast. Time's up.
Sweet.
And
that's
good job, everyone. So for the rest of you, now you learned something new.
To actually make a actual double twin, you make just a twin and then you set the type to double instead.
Exactly. All right. So ready for leaderboard. Drum roll. And number 1 is.
I wish I could actually say the name, but this is the winner.
This is the winner. Congratulations to the winner. We're gonna actually check your email. Robert will contact you directly via email, and he will send you whatever he needs to send you.
Yeah, the 2 first people will get the free course, and the rest of the 20 other people will get a big discount, probably the biggest discount I will ever give.
All right.
Sweet.
Very nice, Robert. This was very exciting while
it was
my
super
heart
fun.
was bumping very fast. So this is very nice. Thank you, Robert, for doing
thanks.
this quiz with us, and have a good day and enjoy the conference.
Yeah, thank you for having me on, and hope everyone have an awesome day as well. And just enjoy the content, and yeah.
Bye.
Bye-bye.
All right, everyone. So now be ready for the next speaker. Bernus, I don't want to keep you waited because we are a little bit over time, like 3 minutes. So let me introduce him very quickly. His topic, first of all, is very interesting. If you have worked with OpenAPI and you know some backend stuff, this is going to be very interesting to you for sure. He is a passionate Flutter developer, and well, he has done quite a lot with Flutter. So let's see what he has for us. Let him be on the stage and tell us about the package, the talk, sorry.
My name is Guillaume, and today I'm going to explain how I'm sharing data models between the front and the back of my app using OpenAPI, and more specifically OpenAPI generator. So sharing a data model is something like really common. Every app has to do it sometime. But adding OpenAPI to a project can be really frightening at first if you have never done it, and it seems like it can be a lot of steps. So the objective of this talk is to show you that it can be really easy, and that you can get started with OpenAPI generator and add models quickly to your Flutter app. So as I said, my name is Guillaume, which is often hard to pronounce for non-French people, so you can call me William, which is like the English equivalent of Guillaume. I've been doing Flutter for like a really long time. I was publishing my first Medium articles in 2017, but I guess no one should read them. It is like you don't write Flutter like that anymore. I've created the location plugin, which helps you get the position of your user easily, which is now like a Flutter favorite package, so really happy about that. And I've been now doing Flutter professionally for 1 year at bam.tech, where I'm a tech lead. And I'm really happy to be part of Flutter Vikings, even though if it's remote, so yeah, let's get started. Here a small overview of what I'll be covering in today's presentation. So at first I'm going to talk about what is the OpenAPI and the OpenAPI generator project. Then I will show you how to install and use OpenAPI generator. And finally, I will show you how to import the generated package in your Flutter app so you never have to write one JSON serializable class ever again. So yeah. First, what is the OpenAPI project? So the objective of the OpenAPI project is to standardize the way we describe our API. It means that the OpenAPI specification is meant to be used on all platforms. But even though this is the objective, most platforms don't have a way of easily parsing the OpenAPI format. This is the case for Flutter, for instance. We don't have a way of importing an OpenAPI file into Flutter. But it is the case for most languages actually. So if it's not directly supported, why should we use this format? Well, it can be advantageous for different reasons. They are all like really important. So for instance, if you have a backend and a frontend in a different language, you can't directly share your data models. So for instance, at the moment, writing a backend in Dart isn't the most popular thing to do. We still have most of our backend that are written in Node.js or even PHP. So using OpenAPI is a good way to make sure that even though you are using different languages, you will be able to agree on the specification easily. The second reason is OpenAPI makes you able to create mocks really easily. So I will not cover this part in this presentation, but there is actually a lot of ways to easily create a mock server from your API model. from your OpenAPI model. It means that even though nothing has been implemented, you can start developing with the true endpoints, and your front-end development doesn't have to wait for the back-end development to have been finished, which can be like super useful to gain a lot of time in short project. OpenAPI can also be like really useful if you have like a public API and you need to document it automatically. So maybe you have used like public API and you have already seen generated document. I will show you one later. But if you are trying to sell an API, I guess you already know OpenAPI, but yeah, it can be like really useful to have like a high level of quality and consistency between your developments and your documentation. So yeah, for those kind of project, OpenAPI is almost mandatory. Finally, the last reason, the one we are going to be interested into today, is how to automatize part of your workflow. So even though I've already mentioned JSON serializable previously, you can always write them by hand, and at first it can be like really easy. You only have like strings, ints, bool, and booleans, and yeah, you can go. But once you start to add enums, once you start to add like specific data format that you need to parse, OpenAPI can make you gain a lot of time and ensure that you always are sync with what your backend is sending you. So yeah, so we've been talking about OpenAPI for a long time. What does it actually look like? So it looks like this. So you can find OpenAPI documents in JSON or YAML format. This one is in YAML. It's part of the Swagger demo OpenAPI file. So I've taken this one. So this is like a pet store where you can like have information about pet and update the information about the pet in the store. So here we have like two endpoints. The first one is the get pet, which is at the pet/pet ID. You can see that you can add tags, you can add summary, a description, an ID, and you can and then you can start to describe the parameters of the route. So you add here a pet ID, which is like a simple integer, and you can see that the response is can be of several types. So 200, which is successful, 400, which is invalid ID, and 404, pet not found. And you can see that the response is a schema, which is defined like later in the file. So this is already useful to have like consistency in your schemes between different endpoints. So that's yeah, really nice. And same thing for post. So you can see that there is like a lot of parameters, so still the pet ID, but now there is like the name and the status, which are in form data, which is a way of sending data to your server. And there is like same thing, different response, like 405 invalid input. So yeah, that's like a common OpenAPI file. And so later in the OpenAPI documentation of this particular file, we have like the pet definition. So you can see that this is an object which have two fields that are required, name and photo URLs. And you have like all the information. So by photo URLs is like a type array, and each item is like a string. So you can give like a lot of information. Some of them are not required for XML. If you don't send your data in XML format, you can just ignore that. And same thing like for the status, you can see that you have a tip string, but it is actually an enum available, pending, sold, which we'll see in the generated code in Flutter. It will be like properly generated, and you don't have to pass the enum to ensure that you are safe within your code. So the OpenAPI generator is a project written in Java, but this project allows you to create and generate clients for all the languages. So let's see quickly all the things that are available. So if we go in the generator.md, we can see all the clients. So you can see there is Dart, Dart.io next, which are the 3 clients for Dart and Flutter. But you have like a lot of languages, so and same thing for the server generator that allow you to create the OpenAPI. So we are going to use Dart.io next, since this is the best one for using null safety. Yeah, so that's really nice. So you have all the config options, the ability, for instance, to change the pub name, pub version, pub library, and all the things that you might need, and all the reserved words that you shouldn't be using, like in your class and in your OpenAPI document. So yeah, so that's the OpenAPI generator, and now we're going to see how we can use it. So here it is, like the small project we're going to use for the demo. So I've downloaded the pet store server. So this is like the thing I have the OpenAPI file I've shown you. So there is like pet find by status, and there is like our get pet/id. And if we go way at the bottom, we have like our object. And the object, yeah, here, the object pet with name, photo URLs, as required, and everything. So the first step is to download the OpenAPI generator. So there are like several ways you can like use directly the Java file, or you can also use Brew to install directly the OpenAPI generator. I will just use, since we are like Flutter developers, we already have Java, so I'll use like the jar file. So I will use like this simple command, which is only occur that we download the latest version of OpenAPI generator. So here it is. I have it right here. And then I will launch the command java.jar OpenAPI generator to see if everything is running properly. So yeah, you can see that everything is launching properly. So I have Java that is working, and my jar is not like corrupted or anything. And now I will properly generate my API client. So you can see here that the command is quite simple. You just generate, which is documented right here. You say -i for the input file, so api.yaml that I've downloaded. You generate with the generator .io next that we've talked about previously, and then you select your output folder. Be sure to select an output folder, otherwise it will like mess up with your original Flutter project files. So yeah, and once we start to hit enter, we can see that there is like a small folder API that is generated. VS Code already took care of Flutter pub-get in this folder, but we can see that we have still errors because we have not generated the data. So as we can see in the perspec.yaml, we have dependency on build runner, which means that we need to launch the build runner to generate all the files. So if I go into the API folder and I run flutter pub run build runner delete conflicting inputs just in case, and I run that, it should like properly generate everything that we need for the API to run. So it should take a little bit of time. Yeah, you can see that there is like something that are not properly configured as per my Flutter version and the version of the API, but it still succeeds. And then you can see that yeah, we don't have red anymore, and we have everything that is properly generated. So that's a good sign. So now that we have generated the API, let's see how we are supposed to use it in our Flutter project. So now that we have our proper API generated, we now need to import it into our main project, which is Flutter Vikings. As you can see, so the first step is to go to the prospect.yaml of our Flutter Viking project and import the project generated right alongside. So we can see that the name is OpenApi. This is something that you can change in the build setting of OpenApi generator, but I just left it like a standard way. So we are going to write OpenApi and import from path. So that's it. And we will need something else. This is Dio. Since we are using Dio next at the Dio next as the generator, we need to install Dio. So we can see that everything was successfully added, and we can now add dependence to our main file, which is the pet API. This .pet API. So preferably you will not have something like that injected just as a requirement and instanted like this, but more provided by provider for something, for example, of our river pod or something like that. But for the sake of the demo, we are going just to add it this way. So pet API, thanks GitHub Copilot for the nice suggestions. And here we are going to create like a default Dio instance, and the second argument is serializer, and we can import standard serializer from the OpenAPI. So if we go to check this file, so we can see that we are in the API folder, and we can see that this is like something that has been generated to be able to parse all the data that we are going to have. So we can see that there is like different factories that have been added for pet, for user, which are part of our API.yaml object. So yeah, that's it. So we have our pet API, so that's nice. So now the next step is to actually use our API. So we have imported pet API, we have defined Dio, and now we're going to load data. So this is like the simple counter app that for now I just like hooked into a new load data function, and I'm going to use like final pet widget.petAPI dots, and there you can see that we have all the functions that are defined in our API that are properly generated and available to be used. So I will just first like do a get pet by API, and if I'm not sure what is a pet ID, I just can read like the documentation, and I see that this is an int, so I will just put in here, save. I will run the app on my device just to be sure, and I will add like print pet, so we can see like in the debug console what is running. So this should be built anytime now. Okay, great. And when I'm clicking, oh, I have an error, and this is quite simple. We say like not specified in URI. This is because OpenAPI is made like to be reused depending on your environment. For instance, you have like a prod environment for your prod, and dev environment, and staging environment, and you might want to check which environment you are, and based on which environment you are in, be sure to have like different calls. So you have like in Dio you can add base URL. So I will just go right here, copy paste swagger.io, and add HTTPS. So yeah, we should be good. I'll just add like trailing commas just by habitude. And when I click here and I scroll, so I have to await my instance. And now that I'm properly awaiting, I can see that right here I have a pet with ID 1, that's good, with its status and everything. So if I go pet data.status, I can see that right here about a pet status enum. So we should always check if data isn't null before calling to that. And if I go here, so this is what I was talking about at the beginning of the talk. Swagger doesn't have like a proper server behind this. It's just a mock, so it sometimes returns a 404, even though the ID hasn't changed. So here I just wrapped everything into a simple try catch, and if I check once again, so we have like a 404, 404, and yeah, finally not a 404, thanks. And we can see that this pet is available. So you have properly fetched data, and you are properly, you have like everything, like you can check like pet status egal, and there you have like pet status enum, and you are available pending sold. So you have everything, and you've got a lot of time. So something else you might want to do like quite often for API is sending data to the API. So one of your solution, for instance, we're going to update a pet. We can see like in the responsive valid, so we'll not need to check that. And there is like a required body, body pet. And pet, we can see we don't have like all the parameters of pet right inside of it, but we can see that there is like a pet builder. So this is what we are going to use. So builder, and we can do like builder.id equal 1, for instance, and then we can do like builder.name equal Flutter, for instance. So this is like a really good name for a pet, I think. So we will have like properly created a pet, build with those settings, and we will be able like to put, and if I click again on load data, again print properly updated. Yeah, if we click there, yeah, so we have like properly updated. So we have sent the update, and everything was properly updated on the part of the server. So that's really nice, and you can like create. So I've created right here, but you can also use like pet builder and add it right here, or everything, your ID, your name, your status. So yeah, so you're able to receive data and send data, and everything is like totally safe to be used by, since you have like the same model between your front and your back. So that's it for my presentation. By now you should be able to add OpenAPI and OpenAPI generator to your project, and never need to write a JSON serializable class by hand ever again. So that should be like a huge time saver. If you have any question or want to drop me a message, you have my Twitter account there, and you have also my site. If you want to check, I will post like the small samples project I have written there, and a small script to generate your OpenAPI file folder inside on the website. So don't forget to check, and most of all, stay safe, guys. Thanks.
All right. This was so useful. I'm pretty sure many of you have faced similar situation that you want to use the similar things that Bruno's mentioned. Now we are moving to another talk, but we have around 2-3 minutes. I'm going to give you a challenge right now. First of all, it's so amazing to see so many of you are like tweeting and sharing on LinkedIn and different social media. This is amazing. We're going to look at all of them. Make sure that you're using Flutter Vikings hashtag as well as the handler @FlutterVikings. So we're going to look at all of those and we pick random, like the best pictures that we've seen or tweets and give away swags. We're going to give away Dash and we're going to give away, as I said, Flutter t-shirt, Flutter Vikings t-shirt, and so on and so forth. And make sure you're also checking Valhalla. It's just right below the main stage. There is a button that says Valhalla in the platform. If you're watching on YouTube, unfortunately, you don't have this option. You need to come to our platform. Grab a ticket. You will receive an email with a private access to the platform, and you can enjoy virtual spaces. So please do a favor and go to the sponsors area. There are 2 rooms over there, and talk to our sponsors. They are waiting there. They're impatiently waiting to talk to you. So go there, talk to them, because they have done a tremendous job supporting Flutter Vikings. Otherwise, it was not possible to do this conference in this format. And maybe another thing that you can do here is that you can talk to, Flutter friends in the chat, or go to different virtual spaces, find Flutter Vikings hat. You can also find a virtual camera where you can actually sit in front of it and take a selfie, maybe a couple of you. In some of the virtual areas, you have these type of cameras that you can take a selfie, or you can take a picture of a couple of friends yourself. There are cameras over there and you can share. You can also play billiard, pool, or different things that you can do in the virtual spaces. If you want to play volleyball, just go to the Woods Mellow or to the tropical island. You can play volleyball with your friends as well. All right. So while you are enjoying the talks and giving us some reaction on the main stage, this is amazing. You can also send your questions or your concern in the chat. We are watching the chat. Now it's time to introduce our next speaker, which is Kubra. Kubra is from Turkey, and he's working as a R&D engineer and a Flutter developer. So he has done a lot of work with 3D objects in Flutter, and she is going to bring a very nice talk about 3D object in Flutter. The talk is very short, about maybe 15 minutes. It's a lightning talk. So enjoy this talk. And then after this talk, we're going to have a live session with Simon Lightfoot. So without any hesitation, let's welcome her, Kubra from Turkey.
Hello everyone, I am Kubra from Turkey. I hope everyone is fine. Today I'm talking about 3D objects in Flutter. So let's begin. I will introduce myself first. I'm a freelance mobile application developer. I am an entrepreneur, a WTN ambassador and GDG organizer. I worked before as an R&D engineering and a Flutter developer. So what will we see on this presentation? You will see 2 packages to implement 3D objects in Flutter, Flutter Cube and 3D Model Viewer for Flutter. We have for these packages an introduction, features, parameters, implementation, differences between the 2 packages, and sources. 3D objects are those objects which have 3 dimensions, length, width, and height, depth. These objects provide a great user experience when used for various purposes. And adding such type of visualization which in turn your app to grow, and maybe you can reach out to many users. I will be showing building a Flutter-based app to demonstrate how we can add 3D objects to your project. We are going to use Flutter Cube package first. First of all, we have to install Flutter Cube package. Don't forget to get it. Next step is to download a 3D object. I have downloaded a cube object. In our Flutter object, we have to create first an asset folder and pass the folder that we download it. In the folder, there should be object, MTL, and PNG files. An object file format stores information about 3D models. The file can encode the surface geometry of a 3D model and also store color and textures, texture information actually. And MTL file, so a material settings file used by 3D objects for editing application. It is stored with an object file and describes how textures are applied to the object. It contains the name of the texture bitmap files and the 3D positioning of the texture. Once we pass the package, we should give the asset a path in PubSpec. You can use the / for all the files that are in the folder that you downloaded. After we import the object, we go to the main.dart. You can use the material app and set a title here. Create also a homepage Dart for putting the objects. We have here an app bar and a body. The body called cube. For the cube, we have to use onScene created. The object type will be scene. We have to use this scene to add the 3D object inside the scene. And to code for the zoom in and out, you can give a value for the zoom. We have to also identify the object and initialize it. We have to put the file name, the file path from the assets, and don't forget to import the library to homepage. So I have a video for the results, what we see after we run it. You can move around, rotate around, you can zoom in and zoom out, but on your mobile device, not on a web. For the mobile device, you have to use at least API 28. So this is the rotation of the cube. You can see the X, Y, Z coordinates. For mobile devices, you have to use at least API 28. If you want to add more objects, add a scene, use expanded and give rotation, and download another objects and pass it to the asset folder. Again, import the folder that you download it to PubSpec. So that was the first package. The second package for 3D objects is the Model Viewer package. We will implement a Model Viewer package and show 3D models in the GLTV and the GLB formats using Flutter application, using your Flutter applications. The Model Viewer package shows 3D models in the GLTF and GLB formats and rotates 360 degrees by mouse, hand touch, and auto rotate. It will be shown on your device. So what are the GLTF and the GLB files? GLTF, GL transmission format, is an open format specification for efficient delivery and loading of 3D content. And the GLB files can be used to save and share digital assets between different 3D modeling tools. So we have parameters for the 3D model viewer for Flutter. The CRC, this parameter is used to the URL of the path to the 3D model. This parameter is required. Only GLTF, GLB models are supported. Alt, this parameter is utilized to design a model with custom content that utilized will portray the model to watchers who utilize a screen reader or, in any case, really open an extra semantic setting to comprehend what they are seeing. And at least we have auto-rotate delay. This parameter is utilized to set the deferral before auto-revelation starts. The configuration of the verb is number of milliseconds. The default is 3000. So the implementation of the model viewer. This is the implementation of the model viewer. Add the package to PubSpec, add the assets. For the use of the GLTF and the GLB format assets on Android 9 Plus devices, you should go to Android Manifest XML and put the uses clear text traffic true. In order to view remote documents from an HTTP URL, clear text network traffic support is required on Android 9 API level 28 or higher. Clear text support is disabled by default, and apps targeting Android 9 or higher will need to add to Android uses clear text traffic true. If you're only working on the HTTPS files, this is not required. The model viewer doesn't support mule safety, so you have to change the SDK to 2.7.0. We have also the Dart files. Create a Dart file called model viewer.dart. In the body, we will have to add model viewer. Inside, we will add a background color for the model viewer. CRC means the user adds URL and SS only GLTB, GLTF, GLB models are supported. We will add alt min configures for the model with custom text that will describe the model to viewers. We use a screen reader. Autoplay means if this is true, a model has animations. And animation will automatically begin to play when this attribute is set. The default is false. We will add auto rotate. It enables the auto rotation of the model. We will add camera controls. Camera controls enables controls via mouse touch when it's flat view. At last, run the application. So I will run it on my physical device. I will show it on the screen. So I have implement Viking object and a Viking ship. You can rotate it. You can zoom in and out. So this is the application after you write code and run. You can download 3D free objects from the sites Free 3D, Sketchfab, Polypizza, NASA 3D resources. I used Polypizza and Sketchfab for the presentation. So what are differences between the Cube package, the 3D model viewer? The Cube package has MTL, object and PNG files. So we have to download these files. The model viewer, you have only download the GLB files for the model viewer. The Cube package supports the platforms Android, iOS, Linux, Mac OS, and Windows. And the 3D model viewer only supports Android. The Cube package doesn't support new safety, but the model viewer supports new safety. So in this presentation, I have explained how you can add 3D objects in your Flutter project. You can modify the codes, and if you want to test, you can get it from my GitHub. You can maybe add a list, or you can add Google fonts, or you can change the background color or the app bar color. Thank you so much for listening to me. I wish everybody a good day.
All right. Thank you, Cobra. It was interesting to see Viking ship over there for sure. And hopefully other people will go and create Viking ships right now and shipping to us. Okay. So the next talk is gonna be very exciting. How many of you are a big fan of zombies? Or maybe played a zombie game, or maybe watched a zombie movie, or maybe you want to create zombies in Flutter. So the next talk is about Flutter versus Zombies by Simon Lightfoot. So he's also one of the organizers of Flutter Vikings, a man behind the Flutter community and a lot of things in Flutter that you see. Okay, wait. I have someone from control room. Oh, I need to mention Flutter Whisperer as well. Yeah, definitely. He is also Flutter Whisperer. So let's have him on a stage. Welcome, Simon Lightfoot.
Hello. Oh, that's embarrassing. So, welcome everyone. I am going to take control of the stream for a few minutes. Like usual, I swear I had plenty of time to prepare my slides, and now I'm running literally last minute towards this live presentation. But you know, we're here now, so let's get started. So, this is me, and this is my talk, Flutter versus Zombies. So I'll walk you through step by step, and we'll have some demos. We'll have a few other things. Hopefully I'm coming through okay. I'm going to carry on. So the talk, what we're going to keep in this talk. So this is the agenda, and I've got a very limited amount of time. So I'm going to try and race through this, and hopefully I keep all of you sort of engaged. So first of all, what are we talking about? Rendering 3D in Flutter. So like the last talk was talking about 3D, that was talking about using the packages. We're going to be talking about how those packages work essentially, and also specifically how you might create 3D games in Flutter and then recreating games. In this case, recreating Resident Evil 1 from the PlayStation, the original PlayStation game. So Resident Evil on the PlayStation 1. So this game really holds like kind of a special place for me. It sounds a bit ridiculous, but like 3D, for my first real experience of 3D was the PlayStation. And when I remember playing the game specifically going, how are they getting these really good graphics? Now, we look at the graphics now and it looks terrible. However, back then, These were absolutely brilliant graphics, right? Like, you couldn't get any better. You had some arcade things, but you know, like, it was really good. So it was one of those games where, like, not very often did you get a game that felt like a cinematic, like, adventure, and it also kind of sort of captured a new genre, which was, you know, action horror or adventure horror, if you will, the idea of getting scared. So we're going to take on a little journey here and see how we might go and take what the original game was and do it in Flutter. So half of this kind of problem, taking some other system and using that and using the essentially, I'm not using any of the original code. I'm not using any of that stuff. That would be wrong. I'm recreating it from scratch. And to recreate something from scratch, you need to understand the original hardware. Now, we're not building an emulator, right? We are recreating the experience in Flutter. So a little bit of information about this sort of diagram you see in front of you. The CPU on the original PlayStation is a 32-bit MIPS one RISC processor. That means it can run, and it runs a whopping 34 megahertz. I mean, you know, that was hugely impressive at the time, but you know, compared to today's standard, it's nothing. Which, in theory, should mean that we can get all of the performance of the original PlayStation on quite a few modern devices, including desktop, probably web, and most definitely mobile. The actual processor had 32 general purpose registers and only 2 multiplication and division registers. Okay. And it had 2 megabytes of system RAM and 1 megabyte of video RAM. The two things are separated. We'll talk about a bit more in a bit. And some of the key points about, like, understanding how to approach this is also talking about the fact that, you know, things like in the PlayStation, the CD-ROM is a 2-speed CD-ROM drive. And as you can see here, with an 8-bit bus, a byte at a time down the bus, it could reach a maximum 300 kilobytes a second. I mean, I'll be honest with you, that's nothing, right? Like, you know, it also kind of is interesting then, because if you need to load data, you need to have your data arranged in such a way that you can load it in chunks quite reasonably quickly. And a lot of games took advantage of ordering their data on the disk so that they could access it quicker, including Resident Evil 1 to a certain degree. So our point here is we're going to concentrate on these 3 points. That is the geometry transformation engine, that's the GTE, the motion decoder, and Sony's GPU. So the motion decoder, the GTE unit, the geometry transformation engine, was used to offload expensive computational tasks. Used in 3D to the separate chip. So it's a separate coprocessor. This is hardware acceleration, right? So the CPU can continue running the software, doing the logic of the game, whilst letting all the 3D transformations and all the work happen on a separate chip. Interesting enough, it used fixed point math. So we had no pesky floating point math here. Even the processor didn't have, it had support for one, but they never added one. And this also means that the PlayStation has some interesting 3D quirks. If you've ever played it, or you're going to go back and play after this talk, you'll kind of start realizing that there's some jiggery happening on, not just on the textures, but also on the geometry. And that's caused by the fixed point math. Certainly also by the way the developer ranged their fixed point. I won't go into that right now. Right. Then we've got the motion decoder unit. So it's also called a macro block decoder. That is actually used. The macro data structure is very similar to JPEG. So it uses discrete cosine transformations on a YUV color space. That's brightness and then red to green, green to blue space. It basically meant that with less information, it's very similar. The reason why we still use that today, right? So this is very similar to JPEG, MPEG 1 and MPEG 2, okay? Each of the blocks, the macro blocks, are 8x8 cells of 24 bits each. They can be 16-bit as well. And in fact, the Resident Evil game uses 16-bit version of these. And the throughput which is kind of interesting about this. The throughput can do 9,000 macro blocks a second. That means that the original PlayStation can stream full screen 320 by 240 full motion video at 30 FPS, which is really impressive for its day. I mean, this is the quintessential 32-bit. Like at the time before this, 16-bit was the popular thing. 2D, fast, scrolling platformers and stuff. 3D was just a massive thing, and to get full motion video, that was just phenomenal. So the GPU. The GPU is obviously rendering for rendering polygons, lines, and so on for 3D graphics. All rotated scale 2D graphics. I'll go into that in a bit. And it also uses two 16-bit data buses. And so graphic modes like Resident Evil 1. I've obviously done a lot of research. Again, it's clear when you're trying to work on something like this, do your research. It has if you use 16 bits per pixel, then you get the most throughput from the graphics. And then all three of these chips, if you look on the diagram, is connected to the bus interface unit, which is also connected to a DMA controller. And basically, this allows the CPU to, again, continue doing its computation. DMA stands for direct memory access. And basically, it allows for example, the motion decoder to deliver its result directly to the GPU and therefore to the video memory. Okay, so it basically allows us to offload tasks, again, freeing up the CPU to do the game, to run the game logic. Before this kind of thing, before DMA, you would have, you worked on TVs, I won't go into it, but basically when it drawed the pixels to the screen, you would have a little bit of time, extra time. It's called overscan, and it would give you just enough time to run your game code. So, what can I say? Anyway, and all of this information and this diagram came from Rodrigo Copti. I can't probably not pronounce his name right. And he did a wonderful job breaking this all down. And there's a link at the bottom there. It will be in the slides afterwards and in the description of the YouTube video when it's published. And you can go read up more about this. And it's really interesting, very helpful. Part 2. I'm trying to get through this. 8 minutes. Right. Okay, I've got to speed up. So, original PlayStation 1 game. We're going to play this just so you can see what we're talking about, because you get a good perspective then. So let's see if this works. Hopefully we're going to see this. Fingers crossed, everyone. Aha, good. Whoops. So I don't know if any of you remember this. This is the typical. I'm hoping you can hear the sound coming back from my speakers. So apologies if there's echoing or anything terrible like that. So I've got a controller. We're going to load the game up. I own an original copy of this, and I have a PlayStation 2 to play it on. So we're actually going to show this in a minute. This is an original graphic from the game, and you have these two cards. Interesting enough, they have the same left part of the graphic. That'll be key to a little bit of explanation in a bit. So kind of keep an eye on that. We'll play as Chris. I'm going to skip. I will just show the beginning of the full motion video as what we're talking about, used by the motion codec. But I'm going to skip it because we don't need to know the background. So this is a full motion video. This is decoded 8x8 graphic cells called macro blocks, and it's been directly dumped to the graphics card. I'm going to skip it from this point. I'll also show you this font actually. So it's the same pixel data with different palettes to do different colors. It's quite interesting. Anyway, so this is the original game. Whilst this is going,
what happened.
I'm going to turn it down a bit. Whilst it's happening, I'll just tell you that the word is always quite funny as a kid, because the acting was terrible, and it's because it's originally made by Japanese Sony in Japan, and they had it dubbed, and they didn't know how bad it was. So they would have done the timing, having better sort of use, but this was Sony's first foray into the sort of English market for games at all, and then into the English market. So I'll forgive him the bad acting. So interestingly, what you're seeing here, and what amazed me at the time, was all these lovely backgrounds. Now, what you're actually seeing here, and I'll talk about this in just a second when he comes into the room. I'll talk a bit more about these doors. There's actually a point to these doors, which is kind of interesting. So here we are. We're in the game. This is the first time you get control of a character. And as you can see, it can move around in 3D. Now, what's interesting here is what you're seeing is a 2D picture with a 3D render on top. Okay? Try and help that into your mind. So the entire background here is not three-dimensional, right? The entire game scene is 2D, and the only 3D thing here is the main character. Then what happens is there's some information in the room, that's the room data of the game, which defines the perspective of the camera, the direction of the camera, the perspective of the floor, where the walls are. And then that information allows the game to know if I hit a wall or a column, I get pushed around it. But he's in front right now. And then if we move behind, we're like, hang on a minute, this is 2D. How are we getting the 3D going behind like this? What's actually happening here is there's a 2D sprite of the column painted on top to hide the player, essentially. So it's still 2D. And it's all a trick. So it's all an illusion. And most games are like this. Most games have it. The game here, same here. The table and in this case, the chairs are all 2D sprites rendered in on top with transparency, basically. And if we see here, the camera change when I walk between areas. The game actually lays out areas on the floor, which are called camera switches or regions, camera zones. I won't go into the differences right now. And then what that does is it means that when you walk into a certain area, so it knows in space, we'll go into this in a bit, in space where the character is, and when it moves into that, collides with that area, moves into that area, it will change the camera to the one specified in the zone. So this allows us to walk around changing camera viewpoint. So I'll carry on because I want to get through a couple more little things. It's very hard to tell, and there's a little twinkle on this clock. It's because this clock is a 3D model painted on top of the 2D backgrounds because it moves. So obviously with 2D backgrounds, you can't alter them. They're just fixed. So anything in the game that's 3D needs to move is on top. Now, this is really hard to tell in the original game. I can tell you right now, you could never tell. That's why the little sparkle was there. Now, in this emulator, we're going to whack it up to 4K. And now what this is doing is rendering all the 3D objects in 4K. Now, if you look here, the main character is in a higher resolution. This is because it's vectors, right? So it's painting the original background is 2D. Now you can tell it's 2D because it's a different resolution to the foreground. So this is kind of revealing the tricks of the game. So we're going to carry on here. I'm going to leave in the high resolution just for the hell of it right now. And I want to explain. So we move up to a door. There's an area in front of the door again. So if I press the action button, the game knows I'm in front of this door and to transition player to the next room. The transition here, the doors, are actually used because of that CD-ROM load time to load the next data for the next area. It gives the PlayStation just enough time to load and decode all of the backgrounds for the next area and load any objects and such like. So we're going to stop this in a minute here. I just want to show you the scariest bit of the original game was this full motion graphic of a zombie chewing a corpse. Uh-oh, we're in trouble. So this is when you really sort of start feeling the game here. And I'm gonna just try and defend myself here if I can remember the buttons. Oh no, I missed him. Now if I'm not careful, I would die. But anyway, we're not playing the game. We're gonna I'm afraid you can go play. If you have the game yourself, go purchase the game and you can play it. I'm just gonna go through, see if we can get up. I just want to just explain this little concept here. We have a little bit more time on this, and then I've got a lot to get through. So Oh no, the others have disappeared. What do I do? I'm on my own. Obviously. Blah, blah. Come on. Get through. Come on. Someone just dropped a gun. That was like 3 pixels in the original game. And now you can tell it's actually a 3D gun model. So I'm not going to... Yeah, I'll grab it. So as you can see, so interesting enough, this might seem higher resolution, this screen, not just the 3D model, but the actual pixel data for the screen. And that's probably because it was quite often for games to switch graphics mode. That is like 320 by 240 to 512 by 400 or something. Anyway, let's, I'll shut up now and just carry on here. I'll see if I can just show something off here. Again, as loading the next bit. Obviously, this was also used not necessarily for loading, but just for transitions, right? So there's a few times here where that, oh, we don't need to, so the character walks up the stairs. I'm going to quickly dive. So this is the top of the other room. So there's a key point here, and that is it to the game. This, I'm not going to deal with the zombie now. This, let me pause it. Can I pause it? No, not without dying, probably. I know, let's die. Let's die. So this is, to be clear, that room. It looks like the same room to us, but to the game, it's a completely different room. It's just it looks like a different level because it's rendered that way, but it's still just a flat room. Just looks like it's up higher, right, to the 2D graphics. So just to clarify that point. Anyway, oh, I went outside. I didn't mean to do that. Oh, come on. Right, come on. I'm going to die, and then we can get on. Hopefully I haven't spent too long on this to get through the rest of the slides. Right, let's die. Okay, so in there, come on. There we go. So it fades out to white. I just want to show you this because it's kind of interesting. Fades out to white. And then you see this pattern is like a glowing pattern from the outside edge. And then you see you died on top, wavy like that. Okay, well, that will make sense in a bit. So that's it. It resets. We're dead. There's save points. There's other things. We're not going to go into the actual game. That's enough for now. So hopefully that was fun for everyone. Let's get back to the slides. If I can find the slides, there is. There we go. So now you know what we're dealing with, right? So rendering in 3D. So I need to explain to you the basics of 3D because, I mean, we did kind of cover it. We did kind of cover it in the previous, a little bit, in the previous talk. But I want to cover it in a bit more detail. Also, explain what the GPU does and what projections are. So let's see if I can I'm going to take myself off the screen here just so you guys get the full slides because I think I might have covered every bit of area of the screen. So 3D basics. So we talk, you might have heard the term vectors or vertices, and both are pretty much interchangeable. A group of vectors are vertices, or sometimes an individual vector is also called a vertex. They're used to define meshes and directions and all sort of calculations in 3D, which makes them kind of essential to understand. So I kind of want to explain, sorry, this group, this graph. So a vector is a line between 2 points. A vector also has a length, which is known as its magnitude, as shown here. So this this is a vector of 9, 6, or 9x 6y. So it's also always from an origin, not always from an origin point, but in this case, it's from an origin point of 0, 0. So with a 2D vector, you can represent any point on a 2D plane. This is literally how we position the widgets on Flutter and all the kind of standard stuff that we know of. Okay, that's the same with most 2D systems, right? They all use these kind of positions, right? key point, Flutter and other platforms that are normally GUI platforms set the origin at the top left. Whereas it's common for 3D, specifically OpenGL and others, to have the origin point at the bottom left. So just in case you're trying this yourself, you might wonder why things aren't positioned right, and it might be that you've got your coordinate mixed up for your origin. So 3D vectors, they work exactly the same as 2D vectors, what we just spoke about. They have an X and a Y that represent a plane, and Y is the up direction, except we've added another dimension, and that's the Z dimension. So if you've ever wanted to try and like kind of get this in your head, we work with the left hand. We're going to work with the left hand rule, and that's what, if you hold your hand up in front of you, and have your index finger pointing upwards and your thumb pointing out, perform this L shape, that tells you your plane. And then if you use your middle finger and point it away from you, your thumb is going to represent the X, your index finger the Y, and your middle finger the Z. This also gives you the order X, Y, Z, right? So now if you consider the model on the right in the image, each of the yellow dots represents a vertex or vector, and altogether these are called vertices. And each vector is going to have an X, Y, Z value from the origin point of the model. And that's like the center point. Now, again, the origin does not have to be inside the model. It can be completely different place altogether, right? It's just where you define those coordinates from, giving them a anchor point. So, as I was saying, each one is a vertex. Each one is a three-dimensional point, and to draw these three-dimensional points, we need to know, we need to define a face that is, in this case, a triangle. So we link three edges together, and as you can see here, we've got the vertex edges turn to faces, which are triangles, and then conceptually we join them together into polygons and surfaces to form our last 3D shapes. And just to be clear, this is exactly what the PlayStation GPU and the Flutter do. They literally draw triangles, and they are 2D triangles. Even the PlayStation, all the 3D you just saw were 2D triangles. We'll talk a bit more about that. So the data in meshes is normally represented by a list of indexes or indices at 3 per face. So as you can see here on the face list, there's 3 vector indexes. So V0, 4, 5 represent what one of the vectors from the list on the right, the vertex list, is going to be used for that triangle. They're also presented, in this case, 0, 4, 5, in a, sorry, also in the picture on the right, 0, 1, 2, in a clockwise fashion. And this is so that the triangle is facing towards the camera. If they were drawn in a counterclockwise rotation, they'll be facing away from the camera. Now that does depend on the rendering system you're using, so on and such like. But you'll probably see the terms CW and CCW used around the internet, which stands for clockwise and counterclockwise. So just kind of giving you some basics here. The data represented on those tables actually for this cube, which also has 2 center points at the top and bottom. So it actually has 10 vertices here in the table, and that accounts for 16 faces. So 16 triangles that make up the total. I should have had credit here, thanks to Wikipedia, for the picture. Right. Slides aren't changing. Okay. Sorry, everyone. Yeah, no, it's working again now. All right. Okay. We're going to continue on. Hopefully I haven't missed any slides. Apologies. So section 3, yeah, no, we're still on section 3. Okay, rendering. Trying to check my time. What does the GPU do? So to be clear, and this is one of those things that is really, really confusing for some, and that is what you see in front of you right now with my face on it and the presentation. That is a bitmap. In the GPU, it is a flat bitmap, just like a picture that you would download from the internet, right? It's a series of an XY plane of pixels. And each pixel is represented by a red, green, blue value. And with those, as you can see here with the primary colors, you can represent all the colors of the rainbow. We won't go into what that is right now. Most of these are 32-bit, which also means they include an alpha. That's mainly for textures so that you can alpha between different layers. However, in the case of a frame buffer, there is no transparency to your monitor, so alpha is ignored. Normally, it can be 24-bit, so you exclude the alpha channel. Sometimes it's 32-bit and it's called RGBX, X being excluded, ignored. It just skips a byte. And that can actually be more performant, skipping 32 bits at a time, rather than trying to do 24 bits for one pixel, 24 bits for the next, because they cross boundaries, 32-bit boundaries. Another problem entirely, won't go there. So both the PlayStation, to be clear, both the PlayStation and Flutter only render 2D polygons. Right, moving on. So on the PlayStation, it relies on the geometry transformation engine, the coprocessor, to perform the vertex transformations. That is like the movement of those, the computational change of those three-dimensional points. We'll go into that in just a second. But in modern 3D hardware, that's done in your 3D graphics accelerator, your graphics card, and that's done in the pipeline that you see here on the screen. So this is the Flutter. This is essentially the same as the Flutter pipeline from the GPU that will be used on your graphics chip in your phone, and also the one on your computer that you're seeing, hopefully, me on. However, in the case of the PlayStation, it has a different pipeline. I'm not going to represent that because we're not talking about the old system. We're trying to talk about Flutter. So, and as you can see here, there's two bolded concepts, a vertex shader and a fragment shader. Shaders, you might have heard of this concept. These are the things, these are computational bits of scripting that run on the graphics card, on the GPU itself. And a vertex shader moves vertexes around, and then it then gets rendered into or rasterized into its into fragments, right? And those fragments are processed through a fragment shader. Each pixel is run through the fragment shader, and then it's tested for blending and then written to the frame buffer, which again is just pixels on the pixels. Once the frame buffer is complete, that is sent out to the monitor or to the television. That's as simply as it works. I did mention this just quickly. I just want to say that, yeah, each triangle is scanned line by line into a series of pixels into the frame buffer, right? And the color values are retrieved from the texture using UV coordinates is one name from it, also called texture coordinates in Flutter. So we're getting close. So much to talk about. Right, I'm going to try and get through this. Right, projection. Projecting your 3D world. So projection is literally where 3D ends and 2D begins. And it sounds counterintuitive, but you're basically, the idea is to use matrix math to flatten or project your 3D coordinates, that is your entire world or your scene, onto a 2D plane. That is how you get the position of where it should be on your screen. That's as simple as it gets. So the GTE, that's the graphics transformation engine, is the thing in the PlayStation that did that. However, and in Flutterland, we do that in dark code using a library I'll talk about later on if we get there. I'm trying to fasten this up. And then, yeah, once all those triangles are flattened, we use their original Z coordinates to determine the painting order. And we use a painter's algorithm. You can go look this up. It's called painter's algorithm, which is basically just drawing the furthest things away first, during the things that are then closer afterwards. So you're drawing from back to front. There is also a system where we don't want to render triangles that are facing away from the camera, so we don't waste time painting them because they're never seen. That's called backface culling. And there's also rotation, quaternions, and a relation to gimbal lock. There's so much to talk about in 3D. I just want to cover these basics, right? And hopefully the idea is that this is all done by my library for you. So how does this all help us in Flutter making 3D games? Okay. So luckily, the Dart team, Google, have made a library called Vector Math, and that supports 2D, 3D, and 4D vectors and matrix types. So two-dimensional, as we talked about, X and Y. Three-dimensional, X, Y, and Z. Four-dimensional is X, Y, Z, and W. I'm not going to cover that right now. It is used in computing 3D graphics. This also can be used for colors. So as we said earlier, a vector 3 is 3 values. Well, there you go, red, green, and blue. And then if you have alpha, well, then you've got 4 values. So it's red, green, blue, alpha. That's a 4D vector. And then quaternions are used for rotating. You can rotate using sine and cosine, but then there's a point at which they cross, and it's called gimbal lock. And then you'll get like a weird rotation happen. You might see this in games. Oh, I've been extended for 15 minutes. So all of this and collision detection, all this other fun thing has been done for me and for you by the Flutter team. So thank you very much. This is all by Dart and Google. This is also used in Flutter. However, you do need to specify it as a direct dependency, not a transitive dependency. And that's just good programming. And then on the canvas, so the standard canvas, you can use a custom painter. In fact, that's what I use in my examples. You can also use custom render objects, another topic. I'm sure there's other talks on that. And you can call this function, it's called draw vertices. And basically what we're doing is, as you can see on the right, the vertices is an object which holds a set of positions in offsets. Now, it is X and Y, the 2D coordinates. That's the 2D triangles. And that list contains in order, well, actually, so it can be unordered, all those vertexes that have been projected to the 2D surface. And then we also contain the texture coordinates, again, ordered exactly the same as the positions, and the colors of each one of those points ordered exactly the same. We also have a list of indices. As I mentioned earlier, I don't know if you remember that, but the indices are the indexes into those lists above. So if we specify an index of 0, 1, 2, we expect to have a triangle in clockwise rotation inside the positions buffer of 3 values of x, y coordinates for each one, and then the texture coordinates for each one. However, again, as it says here, they can be nullable, so you don't have to specify the texture coordinates or the colors, and you can just render the positions. Now, on the left-hand side, you'll notice that it says there's a blend mode and paint. That is what's used to render all of the triangles on the screen. The paint can also have what's called an image shader, and that's how you specify the texture. Again, you don't have to concern yourself with this. I want to explain how it works so you know. But again, the code that I'm going to be releasing later on in the week will have this all in place for you. And I want to be clear, I am not the first to use these functions, and there's plenty of others before me. I kind of wanted to cover, and I didn't get a chance to do a slide for this, some notable names that I remember. There was what's called, if I find it, Sunset Reflections Clock. I can't remember his name. I was going to put it on the slide, so if I get time, I'll go bring it up. But a long time ago, before the Flutter Clock Challenge, I was actually using the draw vertices with some of the others in the community to fiddle around with 3D and wireframes and things, never doing anything major. Then in the Flutter Clock Challenge, when I was looking at all the entries, someone did a Sunset Reflections Clock. It looks, and I'll be obvious, I'm just going to be frank about this, it looks unimpressive because you see it and it's just some pictures. It looks like an image. But what the chap, I forget his name, was doing was actually doing this, projecting and rendering 3D to make his clock up. And he actually did the calculations for lighting and all sorts. So it's very, very impressive. And then further than that, G Skinner, that is... G Skinner did I think it was called one of its Flutter vignettes. I forget the name of it. They did one that also contains some 3D using exactly the same techniques as well. So moving on. Okay, so we've talked about graphics, and we talked about the graphics pipeline. What is a game engine then, right? Like, that's what the GPU does. What is a game engine? So I haven't got any slides on this, but I will walk through this in a demo, hopefully. Can I take you? Oh, actually, I'll leave it to the end. So if I got time, we can go through it. But I'll just walk you through this now. So in most game engines, I mean, we'll just talk Unreal, Unity, and my one, which is called Zombie, contain a concept of a scene, which has a set of entities or game objects. These have a transformation attached to them. That is a position in 3D space, a rotation, and a scale. And then you have cameras, which essentially are the same thing, an entity in the scene, but they also contain information about the projection. That is how you're going to render the graphics. I will show you, we'll get to some demo stuff. I'll show you some code in a minute. So reverse engineering Resident Evil 1. So again, the original concept was the original game. Understanding that technique of 2D, 3D, and going, well, I have the ability to render these polygons. I have the ability to draw these backgrounds. Why don't we try and recreate Resident Evil 1 as a great example for the engine? That includes reverse engineering. So this took more time than I care to admit. And I did a lot of research. I stepped on the shoulders of others here and completely went online, saw what other people were doing. A lot of it was Resident Evil 2. There's not much on Resident Evil 1. And what there is on Resident Evil 1 no longer exists online. A lot of it is in the Wayback Machine. So it's pretty tough. Anyway, I think I found some new concepts that weren't in any of the reverse engineering documents that I found. So I wanted to show you some of the images that I've extracted from the game. So as you, I don't know if you remember from the demo, but we had that Resident Evil title. So it had a video in the background, the title came out, and then a red Resident Evil zoomed out from the camera into the scene in the same position. And that is the graphic you see there. They just colorize it red. You also, when we noticed when we picked the game card, we actually see these game cards on the right. Now, interestingly, what we've got here is actually the same graphics data. It's palletized data. That means it's an index per pixel with a palette, and the palettes are 16 colors. And what it does is it uses 16 colors for one section of the image, and another 16 colors for another section, another 16 colors for a further section. This means we're actually using 48 color palette for one image. Now, the PlayStation only supported 16 or 256. So by using 3 16s, they could reduce the overall data storage. So they could load it quicker. And also the usage of the GPU frame buffer for storing the palettes. The actual palettes, by the way, are stored in the frame buffer just off screen. And then on the left-hand side here, you'll see there's an image that says you died. And that's what happened when we died. And then underneath that is a square there with a pattern. That is actually the background that fades in and fades out when you die. But what's interesting is only 1/4, because they would, again, store only 1/4 in graphics memory. And then they would draw it in 2 triangles in a quad and flip it around in the 4 quadrants of the screen so they could save memory. And these are all techniques that are common practice in lots of games. And then in the middle at the bottom here, we see the game map. I didn't pick up the map, so you never saw this. But there's a game map, and it highlights the different rooms. And as that center bottom one is the main stairs, the main room, and then so on. And then the blue bit here is actually a bit of unused sprite data, and that's how they represented it when they were lining up the graphics in the 8x8 cells. So here we are on to demo time. So recreating Resident Evil 1 in Flutter. So let's see how far we can get with this. Let's close the original now. See what code we have here. So some in the community might recognize this. I want to use this for demonstration purposes. And I started doing this 3D stuff a long time ago, doing some Pac-Man stuff. I won't go into that now. But what you see here on the left is a rendering of a 3D model from the game. And it is done in Flutter. And you can see some Flutter code here where we do some matrices and then it draws vertices. You know, there's no magic here. But what we want to do is if I turn on a line here and hot restart or hot reload, there you go. Now you see it rotating. Now it looks 3D. And when I say looks 3D, it's because that's it. what you're seeing is 2D triangles. And it's also the reason why, if you look around the shoulders, you'll see it kind of glitches a little bit. That's called Z fighting, and it's because the Z index, the centroid, that is the center of a triangle, we calculate the depth, is the same place for the two triangles, even though one is in front of the other. This is actually solved in modern graphics hardware by what's called a Z buffer, and Flutter doesn't give us a Z buffer. Hopefully, we can do proper 3D in the future in Flutter. This is all rendered with Flutter's Dart and the Dart language. There is options around Flutter that other people in the community are experimenting with, and that is bringing the full 3D pipeline of like OpenGL or something to Flutter. And in doing that, that actually gives you a texture. That's a two-dimensional viewport into your 3D. But this is truly 3D in Flutter, if you will. And I'm going to turn on another rotation, and this is going to hopefully blow your mind, because if I now rotate the projection, this is what you see. And what you're seeing is a 2D plane of the 3D graphic rotating. It's what it's not doing. It's not scaling. It's not squishing, right? You're seeing the perspective of like my hand here. You're seeing it go around like this, right? And that just shows you that it's actually 2D triangles, right? We're projecting 2D triangles, but we're rotating the surface that we're projecting onto. Okay. So, okay, that's enough of demo one. Hopefully, we can explore a little bit. So, I'm gonna hopefully run another demo here, and maybe I have broken it. We'll find out, won't we? I think that's going to start in the wrong place, but we'll find out. Come on. Whilst that's building, I'll just show you. So I actually wrote the discrete cosine transformation stuff for the backgrounds of the game. So I'll minimize that for a second. So what I'm going to show you here, hopefully if I can make the view larger, these are all of the backgrounds that I decoded from the original game raw data files. And this is exactly what the game would do. So there's actually some, I didn't get to show some of the work that I did extracting. So I'm going to quickly just show you guys. I did show this on the Hub Day Q&A, but whilst I was writing this decoder, this is the kind of thing that you start with, right? Code is never, ever like just magically finished the first time you do it, right? Like it takes some effort, and something gets in my focus. Anyway, so here you'll see again the 8x8 block cells. You can definitely see them in here, and the X, by the way, is my debugging, and me definitely not getting the colors right, and eventually going, okay, well, there's one UV plane, there's another UV plane, highly compressed. Maybe I could work on my compressor a bit more, trying to merge them together, slowly getting there, and then realizing, oh, I've got my pixel rendering out of order for each 8x8 cell because it looks like crap. Then sort of doing that in black and white, just so I get rid of the color from it so I can understand what's going wrong. Eventually ending up with what I shared on Twitter not too long ago, which is this image. And this is the final. If I can zoom in a bit, if I can find a good place. I did want to also mention that other people have done this. You can upscale them. So if we compare this is the original graphic, right? If you look at the pixels on the door, and we look at the light. Now, if we upscale it using AI, we kind of get this. So hopefully that will be what we end with. So we get like an even better graphical version of the game. Let's jump back over to these. So yeah, so as you saw, that was this top left one. And if we zoom in, my decoder is not finished. So if you look over here on the right, you'll see some colors off. And let's say around the door here, hopefully this comes through. You'll see like there's blocks of color that are off by the door, right? And it's still work in progress, but looks pretty good. And I'm happy with it for the time being. So yeah, what we got here is all those things, including the game scenes that we saw earlier, including this one. So we now take these scenes and we can draw them in Flutter. which means we end up with some things like I'm going to show you now. So I'm going to hopefully show this off a bit. So what you're, if I'm going to restart this. So this is hopefully that's not right. Okay, that's camera 0, right? Now, what I've done here is I've taken the original 2D background, painted it in Flutter, and then we have a two-dimensional data about the collision. That is the areas of the floor that you can't walk into as a player. And I'm projecting them upwards, and it's actually extruding those shapes upwards. They have floor heights. I won't go into that right now. And that's how we kind of see in this 3-dimensional view. But if I now change to a different camera in the scene, there's a different viewport of the same thing. Next camera in the scene. These are all the original camera viewpoints of the game. Yeah. 0, sorry, is this one. That's the starting. Sorry, I got the numbers wrong there. 0, that's the starting one. So you can see there looking down. And then we have 3, 4, 5, and I think there's a 6th one. Yeah, so these are all what you saw earlier. Now, again, if I now move the camera, there's the 3D scene, right? So I'll show you this more out off in a minute, but just to show you that it is 3D, that's actually happening. It's also, I'm demonstrating this with vector colors for the things and the points. This is all debugging right now, and I can just turn them off, right? They're not required to be there. And we can texture all of these surfaces, no problem. Again, there's no need in this game to texture them. I'm going to use this for debugging when I get the player in there. I'm afraid I didn't get there in time for the talk. But I'm going to show some of the stuff with the player as well. So let's see how far we can go with this. Do I have time? Let me see if I can switch here. Nope. We're going to see if we can actively switch this and see what happens. I'll also show you another room in a minute. So here's another demonstration, and this is me putting multiple objects in my scene, including in this case rendered objects, and this is me moving around with the camera. So I can move around, I can project. We're seeing all the things from the scene. That kind of makes sense. So I've got a couple of bugs that I know exactly how to fix. There's no time to fix them, and that is when certain triangles go behind the camera. Sometimes some of the debug vertices, only the debug ones, are projected incorrectly. And then interestingly, there's a bug in Flutter, which I haven't filed yet, which is when there's no more triangles, we end up painting all of the triangles. No more triangles in the index list. It treats a blank list the same as null. And in doing so, it tries to paint all of the triangles. And in this case, they're all reversed because they're behind the camera. I won't go into the matrix stuff right now. So if I come back out. So this is, again, it's working, right? And I can fix that myself by repacking the vertices. I also have these rendered, you know, they all will work nice and speedily. What else do I want to show? Okay, so something else. So as I spoke about, oh, do I have I run out of time?
I am the God who has extended your life. However, even my power has its limits. Your time has come.
Okay, thank you very much. Well, anyway, there we go. So that was the demo. I think that was everything. I just want to just check one thing here. That was it. I want to cut. So can I just bring up one slide, and then I'll let everyone go, because this was the entire purpose of this was to hopefully show this. So Flutter now has a thing called Fragment Program, which is a fragment shader, which lets you do all sorts of fancy effects. and will also project us onwards with 3D a bit further. I won't go into that right now. However, this does exist. It's a class in Flutter. You can use it. There's new features in master on this, and it's actively being worked on. And in fact, one of the creators of Flame, Joachim, has made this article very recently. In fact, it was published yesterday, and he's tweeted it. And I'll again post this link in the chat in just a minute. And that also talks about using these new shaders to do fancy textured things. Anyway, that was it. That was the last thing. So the future of Flutter is looking good. There you go.
Alrighty. So
I guess I'll see you later.
you're still getting hearts down there. So yeah, you must have done something right.
Well, hopefully everyone enjoyed that. And I had so much to cover. And I've cut out so much. So, you know.
Yeah. Alrighty. Well, thank you again, Simon.
See you later.
Yeah. This is what happens when he and I are both pushing buttons at the same time. Alrighty. Well, hey, you folks have no idea how much I heard about all that last week. No idea at all. But, hey, we wanted to touch on one other thing real quick before continuing, and that is, well, Flutter community in general. So, a lot of you do know, some of you may not know, is that Flutter community offers a whole lot to the, well, Flutter community. And first of all, we do have the Flutter Community Medium publication, and it has over 500,000 minutes read every 30 days. We also have a Slack, which, if you can believe it, at the time of that picture, it was over 15,000 members. Right now, I think we're pushing 17,000. So we also have the Flutter Community GitHub, which is where old packages come to not die, because they end up getting dropped off and we find new maintainers for them so that these packages can live on. And of course, you won't have to deal with breaking changes. Moving on, Flutter Community does a lot of different things with events, such as Hack 19, Hack 20. We get you speakers for your GDGs and your other small events. We get you speakers for your larger events. Okay. We also provide speakers for things like Flutter Europe, the Flutter Global Summit 1 and 2. Right after Flutter Interact, we were all in New York, or at least a good number of us, and 12 misfits from the Flutter community's organizers all ended up together on one stage at the same time. You want to talk about a bunch of people all trying to grab a microphone. Then we also do a number of things with the Flutter team, including the 30 Days of Flutter. And, of course, we do Flutter Vikings. Then there's the Flutteristas Conference, the only 4-day conference I have seen to this date. Also, we get you Googlers, such as Kevin Moore and Miriam and Chris Sells. And there's the 30 Days of Flutter again, repeat slide. There was also the Flutter Apprentice Book Club, which just ended recently, and we are now in the middle of the Flutter Puzzle Hack, which got delayed from today because of Flutter Vikings. We will be resuming that next week. Also, of course, there are some videos with ugly people like that, and we do have a Patreon, if you don't mind helping us out there. Yeah, there are a whole lot of people working on things. There are some expenses. They're not real bad. Not real bad. But it would also be nice to be able to compensate some of the people for all of their hard work that they put in on this, because a number of people have been working for quite a few years. So let's see. We still have a couple of more minutes before Kamal is due on, and she is going to talk about common mistakes that you make when creating a Flutter app. I believe there might be a Viking around here somewhere that will probably come out and talk for the last couple of minutes. Is he creeping around here someplace? I think he's trying to talk, but he's not on the stream. Aha!
You're talking to me?
No, I'm talking about you.
Yeah, sure. Okay, Scott, thanks. Great. Well, we're gonna have now Kamal's talk, but let me, before doing like Kamal's talk, let's talk about our sponsors. A big shout out to all of our sponsors. So I'm gonna quickly name them again: Google, Invertase, Stream, CodeMagic, Superlist, Rebel App Studio, the AdSign Company, Very Good Venture, Software Dev Angels, Bouvet in Norway, and Microsoft, as well as Manning Publication. So please go to the sponsors area, virtual area. Some of our sponsors are already presenting there, so they are waiting to talk to you, to meet you. Give them some love in the virtual spaces. Meanwhile, you can also enjoy our other virtual spaces where you have virtual audience, you have virtual phrase, you have other communities. I'm not sure if you have noticed that you also have a dance room in the community area, Freya community area. You have a dance area. You can go there. There are some music already playing. You can just go there and dance for a couple of maybe minutes. Also, one more thing, do not forget to test out our photo booth. And take your picture, add some Vikings props to it, share it on social media, and do not forget to use hashtag Flutter Vikings and ping our handlers @Flutter Vikings. So with that said, I think I will hand it over back. From now on, Scott will be your host, your MC, until the end of the event. And I will be back end of the event, hopefully, and maybe sometimes in between. And from now, I will hand over to Scott to introduce our next speaker. Scott, stage is yours.
Thank you. And yes, I will be guiding the ship. They actually let me have the controls. But coming up, we have Kamal Shri talking about common mistakes in Flutter. And if you don't know, Kamal runs a little show of her own called What's Up Coders. You definitely need to check it out. And with that, let's bring on Kamal.
Hello everyone, welcome to my session, Common Mistakes to Avoid While Developing a Flutter App. I'm Kamal. I'm a Google developer expert, a YouTuber, and a developer advocate. So today's topic is not going to be like the usual topic where I talk about a Flutter concept or I give a demonstrations on that particular topic or a use case exchange. It's more on how to understand the mistakes that we make while developing a Flutter app, or a kind of a checklist that we need to follow while developing a better app, or what are the mistakes that have kind of turned out to be the best practices. So we're going to follow that, and I'm going to share my experience as to what kind of mistakes I made and how I came with a better solution while developing apps. If you're not making mistakes, then you're not doing anything. I'm a kind of a firm believer of making mistakes and learning from it. So when I say mistake, it does not mean that we have made a mistake in order to kind of quit it. No, we are making so that we come up with a learning curve for ourselves and also building up a best practice for others. Now, why are we doing all this is to make sure that we give a good quality code and a performant application, right? And always you should not feel that you stick to best practices and move, but also you share your mistake and see how you kind of overcame it. So we're going to see all those details today. So let's say we start with an app. Now the first thing that comes to your mind is an idea. Well, never an idea is going to be a wrong idea, right? An idea is an idea unless you make it working. So I'm talking about the idea process. So when I have the idea, the first thing that comes to my mind is the design, the UI, UX, the translations happens, right? So as a developer, I think our focus should be very minimal on the design aspects and more focus on the functionality aspects. Because our job is not to get the design, because I see a lot of developers kind of stuck with the design. They really don't know what to do next. What are the kind of intricating features that we have to concentrate while designing process? Well, as a developer, that's not my job. So how do we kind of overcome this? Well, definitely thanks to the advanced tool that makes a job easy so that we can concentrate on more functionality part rather than the designs. Definitely, I would like to introduce you to one of the best tools called Flutter Flow, which I have tried and worked out amazingly. And seriously, it's a tool to be tried. It's a low-code builder for native mobile application. You can use a simple drag and drop interface to build this app. If you want to build an app, it's 10 times faster than the traditional development, whether connecting to the database, API, integrate, or deploy. Definitely, there are a lot of tools in the market. Say, for example, we have an Adobe XD and there's a plugin integrated. So all you have to do is set it up and you're good to go. But this tool has been more kind of easy as a developer. It's not more of a design based, or it's not more of a drag and drop based. It's between something where a developer will be more adaptive and more efficient in using it. So in my upcoming slides, I'm going to show you how easy it is used and how a developer can benefit and look from a developer's perspective and not from the design perspective. So if you look at the UI layout or the dashboard of the Flutter Flow, the first thing is you get to select the pages, the components. So the terms that you see here are all in terms of the Flutter development. So what are the terminologies that you use? The same is used here to make it easy for a developer to understand. Now, say for example, you are an entrepreneur, you're more on a sales team and you're more of a product manager. Definitely you would not be thinking about learning the code, learning the syntax and doing it. But at the same time, you must have learned a few things about Flutter, right? So what you do is these kind of tools makes your job easy. So I know what is a component, but I'm not here to write a component part. I need something that can make my job easy. So that is the kind of the inspiration they have behind building this Flutter Flow. Then there's this UI builder, there's this widget tree. So as a Flutter developer, I know what's a widget tree. So the same is being kind of represented visually here. And then also we have Firestore collection, API calls, project media and assets. So it all talks the Flutter language here, and custom functions and setting and integration. And it's very easy to set up. All you have to do is create an account and you have free trials, free components to create. You can get your hands dirty. Also, we have a set of good, awesome category of templates readily available. If I have to build this, I'm sure it's going to take more than a day for me in Flutter. Because if I'm new to Flutter, I'll have to learn the concept. I have to find which widget does this. If it is not, I have to create a custom widget. So you can think the complicated or the kind of complexity involved while doing this for me. So the same thing, if I want to kind of change the color, change the blocks, drag and drop, I can do it easily without worrying about the code or how it's going to break my code. So it's that easy. So please do try out this. It's easy to use and very efficient. You have an idea, you want to kickstart, you want to get this up running, try it out. It makes your job faster when you go for the traditional approach. And this is a little more about the UI builder, where you have a canvas area to display the mobile device screen, where you can add elements, dragging, dropping, as I told you, and you can also modify the canvas size, choosing the list of different preset device sizes. And also we have a property panel. Say for example, we have a component, we want to align center. Hardly I can remember what are the properties attached to a particular widget. I'll have to get into the internal docs, find it out. But here on the left corner, here on the right corner, they kind of display all the details of the properties, where it's all click, select, drag and drop kind of features, whether it could be like actions like on tap, on submit, or adding animations or padding, alignment, or even label text. It makes it so easy. And the best part about all of this is I'll get the entire code. So there's an option to view the code, and the code is available for each screen. And if I take the code, paste it in my IDE, I can get the same app running on my emulator. So that's the best part about Flutter Flow. So if you haven't tried out, give it a try. Next, moving on to the resources. So when you start learning Flutter, it's always that people are kind of overwhelmed with the resources. They say, most of the time I've been approached by people saying, Kamal, you know what, I've learned, I've watched this video, I have watched this particular tech talk, or I have followed these authors' blogs, but still I'm kind of confused. I don't know where to start. It's like, I know, but I don't know how to do it. So this all happens that if you are overwhelmed with too many resources. So I would suggest that if you're an aspiring developer who wish to learn Flutter, or if you're someone who have already started but still kind of scattered and not on the right path, I would suggest always start with the official docs. It kind of gives you a baseline. It gives you a foundation to learn a concept, because that's the official document, because people are the ones who have built this Flutter for us. Now, understand the technical aspects of it. Now, once you get the technical aspects, and if you want to explore and see how it could be built in a better way with different approaches, or if you want to explore furthermore, that's when I would suggest you to get into the YouTube or Medium or Stack Overflow or Reddit or anything as such. But to get your basics right, always follow the official docs. So for Flutter Dev, we have the Flutter Dev. For the Dart Dev, we have the Dart Dev website. Community, we have the Medium. You can follow these articles. And for the Flutter docs, also we have the internal technical docs available. And then we have the GitHub. I think GitHub is one major resource, because Flutter being the open source and where you have all the libraries or projects or packages, in fact, the SDK available, I suggest that go through the GitHub, see the issues, see the closed issues, and also you can see what are the kind of commits done, how this library was built, what was the intention of it, read the README, the wiki sections, the releases. So these are the things that as a developer you should follow and not avoid, because if you don't follow this rigorously, then you tend to make these kind of common mistakes while developing Flutter apps, because you're not updated with any latest. So moving on to the next one, I'm sure most of you must have missed few targets. Well, here, the targets that I'm referring to is the releases, where I'm sure most of you do not follow the Flutter releases or the Dart releases. We have every few months releases happening in Flutter with all the feature requested by developers like you and me, and even the Dart release, feature request, new updates. So I think as a Flutter developer, it's not only about fixing bugs, it's also about finding out what was yesterday, what got fixed today, and what are the new features coming up in the next few months, and what is in the pipeline. So the same thing that you could actually implement in your project and see how you can solve your existing issues and also keep your app prepped for the future releases. And when it comes to the old style school, do you still follow the old style when you're following a tech or a product or something? Definitely not. Every time it gets upgraded with new models and you use the latest one, right? Similarly, even in Flutter, as a Flutter developer, you have to keep yourself updated with the new releases, what really got fixed from the old release when compared to the current one, and what is expected for the new releases. So you can see the complete history of it and all the details. So just to give you the roadmap of the Flutter releases, we had Flutter 2.0, then Flutter 2.2, and then 2.5. And last year, December, we had 2.8, and also we had Dart 2.15. I'm sure there are so many developers who still do not know that there was a release in Dart as well. So please keep up to date with these kind of updates, because these are the common mistakes that you make as a Flutter developer, and you need to understand them. So if you look at the Flutter 2.8, so the update that we had was more on performance improvement, new Firebase feature, desktop status, tooling updates, and many more. So the first and the foremost was the release of the Google Mobile SDK for Flutter in general availability. We had 5 supports, add format supports, which integrates both add mob and add manager support. But if you're more of publishing apps, you will understand this. And also it includes the beta of the new mediation feature to help you optimize ad performance. We also had Flutter Fire plugins from graduating slowly from the beta to the stable mode. We had Dartpad updates for several Firebase services, which was really an interesting part where we had Firebase support inside Dartpad, where I don't have to do any setup and I'm good to go connected with my Firebase. And we also had plugin moving from stable to stable state for Android, iOS, which includes analytics, performance monitoring, remote config. And there was also another major updates, which were the Flutter stable releases for Windows, Mac, and Linux. And the best part about it is in the Dartpad, we had a channel where always it used to be the latest stable version. But now you have a drop down called channel, and you can actually select the latest beta channel or the previous stable channel or the new channel. So you have an option to do this. I know it's a very simple update, but trust me, if you are someone who is working in and out with Dartpad and using it, you would find that interesting. So if you want to find more details about it, you have it on Flutter 2.8. You can find more details on the official documentation. Moving on, we also had Dart 2.15, where we had the compressed pointers, diagnostic message, isolate, secrets, leaks, retraction. So compressed pointers was like result in a significant memory reduction. See, if you're a Dart developer and you work too much on Dart, or you're more a technical person who likes to deep dive into more technical aspects of it, you would find these interesting. And there was like 10% reduction of Dart heap size. And also, if you're a package publisher and you accidentally kind of pushed a secret key like the cloud or the CI credentials, then we have something to detect it. So they're very simple but yet effective. And also they've added a package to retract a package version that has already been published. Sometimes it happens, right? Mistakes happen. We kind of publish a faulty package version. So if you are a package publisher, you will understand. And so you have an option to retract it also. And they also started redesigning and re-implementing how isolate work by introducing a new concept called isolate groups. And so if you're more working on isolates and you want to know about it, you can definitely go check out about isolate groups. Actually, isolates makes individual isolate in the group more cheaper. So find out more about it on Dart 2.15. So another update was in Dart, you can create a function object which points to a function on another object by using the function name. So to cite you with a simple example, I have a class with a string, and then I have a method called greeting, which prints the message, and there's a sub message, and there's a text. So if you look at the line 10, I have an object 1 of the class, and then I have an object 2, which is like the object 1 calling the function. And then when I print, this is what I get. So if you are someone learning and doing it in a different way, we have a better way to do things here. Coming to the enum part, now you can get the string value of each enum value using .name. So you can see that we had create, interact, engage, and Windows, we're having a new update coming up. So stay tuned for more updates. And I can get the string value of each enum just by using .name. So starting with Dart 2.15, now you don't need to download DevTools exclusively. No further installations is required. It is a part of 2.5. So definitely it's a good news for us that we can use it exclusively here and no need of extra installations. So checklist is something that I say it varies from person to person. Now, when I build an app, I have a different checklist. Checklist is something that I always keep as like a blueprint before I start building a Flutter app. So now these are the few checklists that I follow rigorously. Maybe it's different, or you would like to add something, or you would like to delete something. It's totally up to you. All right, now, so these are the few of the checklists that I follow when I'm building apps. So the first one that I would like to focus is the theme. I still find people using theme inline, whether it's in a text widget or a button. They don't use it as a theme file. They don't use color widgets. They don't use color constants. So it's always good to maintain a different file when you're working on this. Widget structure. Still people add all of the functionality in main.dart file. No, you will have to split the widget into different widgets. All right, so moving on to the architecture part, it's very important to understand that you have to separate the logic from the UI, irrespective of what state management that you are following, because it is easy to build. If the team grows, they know where the logic is and where the UI is, and if you want to change the backend, it is very easy to do it. And then moving on to the linting rules, a tool that analyzes your source code to flag any kind of programming error, bugs, stylistic errors, or suspicious construct. It supports verifying a good quality code. I always suggest to use const on widgets so that you can cache the part of the widget tree to prevent unnecessary rebuilds. It's very important. Also avoid relative imports like lib. Instead use package imports and try to avoid relative imports. Use a README and documentation because I still see people do not add README. They follow the counter app README itself and add some screenshots, tell us what your app exactly does, and a few links, few wiki links and documentation. It's very important. These are the common mistakes that people do while building Flutter projects. Try to avoid them. Use private variables, naming convention, follow naming conventions while you are building a Flutter app. Moving on to this, it's very important, and I really like this part of this best practices that I follow, that is knowing how your app looks and performs on other devices. So it's important to use, I think this device preview is one of my favorite plugin where I use it to test and preview any device, whatever that I'm building on, because I cannot get all real-time devices to test it. So it changes the device orientation. It keeps the application state, plugin state, customizable plugins. And also I can change the language, dark mode, text scaling factor. So it's a very handy plugin. Do give it a try and see how it is efficient when you're trying to build an app which kind of satisfies different device views. So definitely do try it out. Next, moving on to the packages, I'm sure every project would have tons of package to be used, and it's a very efficient way to get good, amazing, good-looking apps. But at the same time, do not overload your app with a lot of packages, because I see there are a lot of people who are using packages for even toast and snack bar, which I don't think is an efficient way to do it. I think it's always good to validate any third-party package before being used in your application, because sometimes it might break the build or not be in sync with the current version of Flutter. So it's especially required when you are kind of upgrading the Flutter version, and make sure you check all your plugins and third-party packages after upgrade. And I also see that a lot of people use package and they forget to remove it if they're not using it anymore on your pub spec. So always have a quick check of your pubspec.yaml file to see if you're using unnecessary package or you're referring assets or any other fonts which is not required. You can remove them to reduce the load on your app. Then moving on, we have something called as a debug console, which is also a very minute detail that people try to avoid not using it, where a lot of details are kind of captured here. So if you come to the debug console, we have a lot of details, like if you're getting rebuilt a lot of times, if your widget, it kind of gives you an error here. So have a look into it. You would find a lot of interesting facts about this debug console. So something not to be avoided. And coming to the testing part, I would say it's a very important thing, but still 80% of the developers do not follow writing test cases. Now, to determine if your feature or the app that you've built is within a system are performing as expected, to confirm that the system satisfies all the related standard, how do you do it? As per the guidelines or customer requirements, we need to know that, right? So testing is the only way to find it out. So if you see, we have unit test, we have widget test, we have integration test, where if I want to just test the logic of it under a variety of conditions, go for unit test. If I want to test a particular UI part, whether it is able to receive and respond to a particular interaction, go for a widget test. Integration test, where it's like the complete app or the large part of an app that you want to verify the performance, do it. Try to do all kinds of tests when you are working on Flutter apps, because it's something that you will have to use day in and day out. And it's a very good practice and something not to be avoided. So we have seen a lot of things not to avoid and what are the things we have to inculcate while we are developing Flutter apps. But how do we do it at a larger extent? So I think we can solve this problem, which I have followed, and come up with some best practices, or some of the mistakes that I have made and learned is by talking to experts, talking to developers, expressing the concern that you have, how you can solve them, getting different views, being a part of the community, whether it is to share a knowledge or find out what could be the alternative solution, be a part of the community. Try to get it open source so that you can get different views on your problems or solutions, or a different perspective on what you're building. Make mistakes. Unless you make mistake, you will not know if this could be the next best practice. So try to follow these approaches and you would be able to avoid those common mistakes and use the best practices to build a better app. And these are the couple of references that I followed, and these are the official docs, and you should be good to go with it. And you can reach me on all of these channels if you have any questions related to Flutter, or any questions that you've been stuck and you don't know how to progress, or anything related to today's session. You can reach me on all of these mediums. That's it. Thank you so much for listening to my session, and I'm sure you would have got a pinch of how to avoid the common mistakes or what to follow in order to make your app as the better app and a good quality app. Thank you.
Well, hey, that was a great talk by Kamal. Yeah, a number of those mistakes I have made myself in the past. But you know what? I know what you're thinking. Okay. I have taken classes. I know how to read your mind. What you're thinking is, where can I get a dash? Okay. Everybody's thinking, where can I get a dash? So just a little bit of history here. The mother of dashes is actually Shams. She is the one who came up with the whole idea of Dash, and she is the one who created Dash. However, Dash has an adoption agent. Okay, this is a person who reviews all of the applications for a Dash and decides which homes are good homes for a Dash. Okay, so if you ever see this person right here, okay, going around right here, look for her. You might find her standing in the back of a truck in New York City, say, like that, with lots of dashes. Okay, she is their adoption agent. Her name is Nilay. But you cannot buy a dash. You cannot do it. You have to prove to Nilay that you will give a dash a safe home. Okay, and you will be good to your dash. So, see. Not only is my dash clean, even still has the little tag. So, and the most important thing is keep dash away from the dog. Trust me on this. Keep your dash away from the dog. That said, let's see here. How much time have we got? We've still got a couple of more minutes here. So there are a couple things, a couple conversations that have been going on around the world of Flutter, and a couple of things that I did want to point out. And the first one is context. Context matters. Okay, it's really important, because without context in a conversation, how do you know what someone's talking about? Right? If they say it was fast, well, fast for what? Fast for a person, fast for a car, fast for a horse, fast for a rocket ship. Without the context, you don't know what's going on. Okay. And when you are building widgets, context matters. If you use text and you say test text, all right, fine. What font is it going to render in? What color is that font going to be? What size is that font going to be? You didn't specify anything. So if you didn't specify anything, where are you going to find, where is the render layer going to find the information? You know, where's your widget going to get the information? Well, it's going to get it out of the context. It's going to go look at your text theme .of context. One of the funny things, when you see this word of all over the place, if you're a beginner to Flutter, just change it for the word in. So text theme .in context. What was that? I thought I heard a noise. Wait. So I believe we have another talk coming up. Who do we have coming up here? Let's see. After Kamal, I'm looking. I'm still looking. Nope, that was Simon. Simon had half a day. Lightning Talks. Lightning Talks. So we are going to be looking at, what did we say? The nature of Flutter. And that's going to be our first Lightning Talk. So let's let that take it away, and I will catch you all later.
Hello everyone. So I'm Abhishek Doshi, and I hope that you all are safe and keeping your relatives and surroundings pretty safe. So today's topic, or you can say today's talk, is on trees that are available in Flutter. The talk heading is Nature of Flutter. Who has the best trees? So now let's move forward. First of all, who am I? So basically, I am a Google developer expert for Dart and Flutter. I am also Google mentor, mentoring individuals as well as startups who wish to migrate to Flutter or who want to learn Flutter. As an professional, I am senior Flutter engineer at Somnia Software. I have been working in Flutter since almost 3 years now, and I also write tech articles in Flutter. I am also the organizer of Flutter Valsad and co-organizer of Flutter India. So you can say that my entire life revolves around Flutter. So first of all, before we jump to trees of Flutter, first of all, let's see what exactly is state. So every widget has its own properties, and that properties can be considered as the state. So basically, in technical terms, state is an object that can be manipulated throughout the lifetime or life cycle of the widget. And using the state, we can get information about the widget and even rebuild the widget. That's the reason we use set state. So what is the role of state then, and how is it useful? So we can consider that there are three main usefulness of state. One is information about widget. State is the information that can be read synchronously when the widget is built. It basically holds the properties of the widget. Second is it can rebuild the UI whenever we need. So basically state is the object that is responsible for rebuilding your UI. That's the reason we have init state, create state, set state. So basically when we want to rebuild our UI, we call set state. And the third is gives control over life cycle. So basically state can change during the lifetime of the widget, and you can say a warning, if you don't utilize it properly, it can have adverse effects on your app. Even your app can crash, you can have memory leaks, you can have unwanted states, etc. So then, which trees are responsible for rendering in Flutter, or you can say which trees are there in Flutter? So there are basically three main trees: widget tree, element tree, and render object tree. Widget tree, if we say in simpler terms, it holds the widget. Element tree contains information whether the widget is stateless or stateful element, and the render object tree contains the properties and paint protocols of the widget. So let's go with the first one, that is widget tree. So basically widget tree is a tree that is created whenever you create your design of the screen. So let's suppose you have a container and inside that you have a row as its child, and inside the row you have three columns as its children, and inside each column you have an icon and container. So the widget tree for the same is available on the screen, you can see. So basically what happens is, let's say whatever root widget that you have on your screen will be the root of your widget tree, and the way you create the tree, the way you create your widgets on the screen, based on that your widget tree is created. So technically widget tree is a tree that will be created based on how you design your screen and how you are adding widgets to your screen. So you can consider the widget tree as the most simple tree in Flutter. So I hope widget tree was pretty clear. Now, whenever we create a widget tree, the Flutter framework creates another tree called element tree. So an element tree just contains the information that whether the widget that you have provided is stateful element or a stateless element. We all know what is the difference between a stateful and stateless. Basically, stateful has state properties, stateless doesn't have state properties. So an element tree represents the use of a widget to configure a specific location in the tree. So you can also say that element tree is responsible for implementing or configuring the specific location of a widget in the tree. This element will depict whether the widget is a stateless element or a stateful element. The element can change if the parent widget rebuilds and creates a new widget for this location. So let's say, for example, you have a column. So basically column is a stateless widget. Okay. So besides the entry of the column, inside the element tree, there would be stateless element. Same way we have icon, text as a stateless element. Now if you have a user defined class, so let's suppose that my home page, which is my home page extends stateful widget, so it becomes a stateful element. So in the same way, in the element tree there would be an entry for my home page which will be called as a stateful element. And the third one, which is the most important one, is the render object tree. Now render objects tree basically holds only the paint properties like child position, basic layout, x and y coordinates of the widget in the tree, in the screen, paint protocols, etc. However, it doesn't define how many children a parent will have or where the child will be positioned in the Cartesian system. Basically, it holds the x and y properties, but it doesn't define where the child will be positioned. So, you can say that render object tree contains the basic details of the widgets, which is responsible for the painting of the widget. So basically render object is an object that is created for each element that is present in the element tree. Now the render object tree is responsible, as I said, it is responsible for painting the widget on the screen. And the widget tree or the Flutter framework always considers the render object tree to define or to repaint the widgets that we have on the screen. So let's suppose you call set state in your screen. Okay. So Flutter framework would first check the widget tree, then it would check the element tree, and then it will check the render object tree to redefine or repaint that particular widget on the screen. Now, because of this, some of the widgets like stateful widget or stateless widget, few of them are very costly to rebuild, few of them are very not that much costly to rebuild based on the availability of the trees that we have. So just to summarize, you can say that render object tree is responsible for defining or painting the widgets on the screen. So here's the summary of all the three trees. That is, widget tree contains all the widgets that you use in Flutter and holds the configuration of a UI. Element tree represents the use of a widget to configure a specific location in the tree and contains a piece of UI, stateful element or a stateless element. And third, that is the most important one, render object tree holds render tree holds the properties of the widget along with paint protocols and is responsible for painting what you view on the screen. So here's the summary, or here's the verdict you can say. Render object tree is responsible for painting, element tree is responsible for holding which element the particular widget is, and the widget tree is responsible for all the configurations of the UI part. So I hope this was clear and I hope you learned something new today. And if you have any questions, feel free to ask. And yeah, I hope you learned something new and all the best for your Flutter journey. I would really be willing to help you. So feel free to connect with me on Instagram, Twitter, or LinkedIn. And I have the same user ID, that is Abhishek Doshi 26. And if you wish to read my articles, feel free to go to abhishekdoshi26.medium.com. I have been publishing many articles recently on Flutter, and one of the articles does contain this trees part as well. So if you feel that this session was not that much easy to grasp, you can definitely read the article. It has much more explanation, it has much more example, and in much simpler ways. So yeah, feel free to connect with me on Instagram, Twitter, or LinkedIn, or GitHub as well, and feel free to read my articles too. Thank you so much for joining today, and I hope you learned a lot today and you would be able to grasp knowledge about these trees. And if you are able to grasp it, it would be really helpful to understand how Flutter framework works. Thank you so much.
Hey, the day isn't complete unless I do that once. Yes, I see all the reminders in chat. Thank you very much. But there are a lot of different things we all learn as beginning Flutter developers. And the tree is one of them. Some people have called it a cake. Some people call it trees. In any event, it's important to know. And another interesting thing that's important to know, and I think will in part be pointed out by this next talk, is the use of constants. Now, constants, in short, really help the performance of your app. Okay, now I'm not going to go into a big, long talk about them. I'm going to talk more about what you can do to make sure you use them. And in essence, you might have noticed if you're using containers all over the place, you can't make them constant. They don't have a constant constructor, which means you can't take advantage of the benefits of constants. So, but what you can do is you can break down the container into its component parts and use those component parts individually. What I mean by this is you don't want to use a container if all you need is empty space. So you use a sized box. You don't want to use a container if all you want is a colored box, because you can make a sized box and put a colored box in it. Those can be constant. Okay, again, bumps your performance. If you use a container, make it a size and make it a color, that's not constant. It's not going to perform as well. So really dig into it. Open up the source code. Read. Okay. Learn what's what. And every time you can do anything as a constant, you're going to want to do that. So let's see here. Those are some interesting emojis going up there. All right. Our next speaker is coming up right now, and it is Adita, and she's going to be talking about Flutter Lints. So.
Hi, I'm Aditya Thakur, and in this lightning talk, we'll look at Flutter Lints and how can you use them to your advantage to make your projects better. We'll get started by what is linting and a linter, how can you use it, and what are the recommended set of rules by the Google Flutter team, and how can you migrate your existing projects to the recommended set of rules. Linting is the automated checking of your source code for programmatic and stylistic errors. This is done by a linter or a lint tool, which is basically a static code analyzer. Now, the Google Flutter team recommends using the Flutter Lints package. It has all the recommended lints for Flutter apps, packages, and plugins to encourage good coding practices. All new Flutter projects created using the Flutter create command are already set up to use these recommended set of lints. So if you'll run Flutter create new app command and open this newly created project in a code editor of your choice, for example VS Code, you would notice all new projects created using the Flutter create command already come with Flutter Lints as a dev dependency, and also they have an analysis option.yaml file which includes these Flutter lint, all the recommended lints for Flutter apps packages to encourage these good practices. Projects created before that can be easily migrated. To migrate your old projects, the first step that you have to do is flutter pub add with the dev option Flutter Lints. This would add Flutter Lints as a dev dependency, and after you do that, you can create a new file in the project directory. Call this analysis_options.yaml. After creating an analysis option.yaml, the first step that you have to do is include flutter.yaml from the Flutter Lints package. After you save this, it might detect certain problems in your existing project that you might have to fix before moving on. So const keyword is missing here. I'll do that. Similarly, you can also customize the lint rules applied to this project here. So let us say you want everyone on your team to use only single quotes when writing strings, unless there is a single quote used in the string itself. So what you can do is you can type in linter and specify the rules, which in our case would be to prefer single quotes. Underscore quotes. And we can set this to true. Now, if someone on your team uses a double quotes for strings that do not contain any single quotes, you'll get a warning. You'll get this here. It would be a warning, and it would tell you like only use double quotes if there is a string that contains single quote. Otherwise, please prefer single quotes. Customize your static analysis. Let us say you want to exclude certain files, certain generated files. You can exclude them. You don't want static analysis to be done for certain files. You can type in analyzer, exclude, and specify the files that you want to exclude. You can also change the severity of certain rules. Each analyzer error code or each lint rule has a default severity, but you can also change the severity of individual rules. There are three modes you can specify. One is info, one is warning, and one is error. So for invalid assignment, it would give you a warning, and for a missing return, it would give you a complete error. Info would provide an informational message that does not cause analysis to fail. A warning doesn't cause analysis to fail unless the analyzer is configured to treat warnings as errors. And an error would cause the analysis to fail. Example, an invalid assignment. Going back to our previous example, where you prefer only double quotes if there is a string containing single quotes, otherwise have to use single quotes. What you can do is, instead of having it as a warning, you can specify it as an error. Now, if you'll save this file, you'll see that this particular warning becomes an error, and it is also shown in our main.dart file. Now, anyone from your team working on this project would have to ensure that strings that do not contain a single quote are only written in single quotes, right? And instead, and if you want, you can also exclude particular files. So if I'll come back to my YAML, I can do something like exclude lib and specify main.dart here. If I'll save this file, this error should go away because this particular file was excluded from the analysis. To check out all the different rules available to you, there is this web page you can visit, and it has all these rules mentioned here. You can check them out and use them according to your will. You can view all the supported lint rules and explanation of each. And there is also the documentation available for customizing your static analysis on the dart.dev guide to language under analysis option. The Flutter Community Plus plugins use the Pedantic package, which is now deprecated, and I got to contribute to it to migrate it to the Flutter Lints, and this talk was based on my experience. So if we'll go a bit back in time, the Flutter Community Plus plugins were dependent on Pedantic package for static analysis, and I got to work on it. And since the packages already had an analysis option.yaml, the first step was adding the dev dependency, which was Flutter Lints, and also updating the analysis option to include, to change this from Pedantic to now Flutter Lints, and exclude certain files that were generated, set up some rules for that. Also, one of the things that I noticed was one of the rules of the Flutter Lints package was to avoid print in production, and that is why we had to use we had to import Dart developer as developer and log all these changes instead of having print statements to do so. I hope this helps you not only move your projects, if any, to the new set of recommended lint rules, but also leverage them to your advantage when writing code. Thank you so much. That is all from me.
Well, hey, there you go. There's some actionable information right there. And the linter is one of the most important things. It's what keeps your code decent. And a good linter set, a good set of linter rules can really help make you a better coder. And I do see a couple questions about them. There are different sets of linter rules out there. You can take a look at Flutter Lints, which is the official package. You can take a look at Very Good Analysis. You can take a look at the linter rules list and make your own. Now, with that, we have that pesky Viking floating around here somewhere. And I don't know. Can't seem to get rid of this guy.
You can't get rid of me. I am the Viking. No, just kidding. I actually thought that I can come back and shout out to our program committee. you see that we had a lot of great talks today, and we will have also tomorrow. These talks are selected by our program committee. Let's have a shout out to them, Yon, Lara, Miguel, Alina, and Rihanna. Thank you very much for helping us to select these amazing talks. And also, one more time, I want to shout out to our sponsors. So you have a virtual space with our sponsors. They are actually sitting there right now. You can go there, talk to them face to face. By the way, if you leave main stage, you will not lose the video. There will be a small media player in your browser where you can move it around and you can go to different places. So you can actually leave the main stage without losing any talks. So you can do that.
The
For
stage
now,
will drop into picture-in-picture.
Exactly. For now, maybe you can go to virtual Odin, like Mevo Woods or somewhere. People are there. They're trying to play some games, take some pictures. So that's nice. So Scott, I will leave the stage to you for 5 minutes. So you have, I think, plenty of things to share with other folks, right?
No, we've got a few. And as Majid just said, the sponsors are there. You know, they help make this whole thing possible. So take a few minutes to go and talk to them. And if for no other reason than they're lonely, I mean, they're sitting there abandoned, lonely. They need someone to talk to. And some of them are really nice, and they give you lots of great swag. And if you notice, this is a Yeti. So thank you to Stream. I love my mug. I take it with me everywhere. Everyone sees the logo wherever I go. So let's see. What should we talk about? I've got a couple of minutes to kill here. Let's see. Some people put something in chat. Let's talk about something. Yes, Flutter projects are coming with Flutter Lints by default. That is the recommended one by the Flutter team. Desktop. Desktop is not my personal specialty, but there have been a lot of interesting rumblings, and I'm sitting back waiting to hear, same as the rest of you. So we'll see what happens. How's that? Let's see. We've also, as was mentioned, if you didn't know, this conference was originally supposed to be hybrid. We were supposed to have all the speakers in person and some attendees in person. And unfortunately, COVID did still wreck that for us. However, we are still looking at having another split conference that is hybrid and hopefully getting together in person at the end of the summer. And Anna did just point out, take a look at the Twitter wall, you know, because you can definitely have a lot of fun with that as well. Let's see. Go ahead. Also, don't forget about taking selfies with the Viking. So that right there, you can get the little hat going on, you know, post it to Twitter. Don't worry. Nobody's going to make fun of you. Okay. Dog. Remember, keep the dash away from the dog. So let's see here. Yes, you can definitely set things up so that it will set everything up on your save. Take care of that. We're running out of Dart.js avenues. No comment. So we also do have the photo booths. Don't forget those. See, and this is what happens when you just try to fill in time. Does anybody want to see the dog? No, I'm kidding. Let's see what else has been going on in the world of Flutter. Well, also don't forget that coming up, we have the puzzle hack. Okay, we're going back to next week for the puzzle hack. And we're really interested to see what you all come up with. There have been a lot of interesting conversations about what people could do with that. It could be anything from a clock that's constantly changing. Imagine trying to do a puzzle and getting everything put together, but the picture's changing. And okay, I believe there is something going on about a selfie with that pesky Viking, and maybe posting that to social media.
Yeah, actually, you know what happened? People are saying, can I have a selfie with you, like the Viking, the real Viking? And I said, why not? So I'm going to give people 2 minutes. I'll stand here. I'll take some figures and make your phones ready. And you can take a selfie with me, post it on social media, and also make sure you tag Flutter Vikings and with hashtag Flutter Vikings. Scott, can we go for 2 minutes?
Sure.
Okay, let's go for it.
We can do that. Also, let me see here. Jeffrey, I did just take a look at your gist, and that looks good to me. That should be able to be constant without any problem. Yeah.
1 minute for selfie, Scott.
Yep. 1 minute for the selfie.
Let's go for it.
Ahead.
Maybe with Axe. There you go, Scott.
Very cool. Very cool. And one other real quick point. James says, hurry up and take my money to have a virtual Flutter community training class, intermediate advanced developer. We actually have talked about trying to do something like that. We realize there's a need. We want to fill it. The problem is everybody we know who is qualified to fill it is too busy to do something like that, honestly. Doing something like that takes a tremendous amount of work. I had put together a beginner's seminar. It took months. It takes months to develop things like that, and especially on an advanced level. Wow. And I mean, Simon's working 14-hour days. There are new contracts coming in. People can't find enough developers as it is. So, if you can come up with an 8th or a 9th day in the week, we might have a better chance. Or find some way we can go on 2 hours of sleep instead of the 3 we're getting right now. All right. So the next speaker coming up is Gordon Hayes, and he's going to talk about tips, tricks, and tools for performance. Gordon?
I'll be giving you some tips, some tricks, and some tools regarding performance. You've probably heard this line before. Flutter is fast by default and you don't need to worry about performance. This is true for the most part, and it is important for me to note that you should not be pre-optimizing your application when not needed, but understanding what can cause your app to be slow, and more importantly, how Flutter's rendering works underneath the widgets you use will level you up as a Flutter dev. A quick intro. My name is Gordon. I work at Stream as a Flutter developer advocate, and I also have a YouTube channel called Fun with Flutter that, you guessed it, covers Flutter topics. I hope you learn a few things from this talk because I've wasted so much time in the past not using the correct tool for the job. So don't leave. I know this looks boring, but I promise that this talk will get a lot more interesting, and I'm actually going to go over the fundamentals quite fast. So first, let's take a look at the different phases that are responsible for rendering. we can see that we have the build, layout, and paint phase. And then finally, all of this creates a display list that will then be rasterized by the GPU. So the GPU will display this as an image that can be rendered to the screen. The build phase is what we as Flutter developers are responsible for. This is the rendering phase that we control the most, as this is where our widgets get rebuilt and the subsequent elements for those widgets get inflated, and from those widgets we also create the relevant render objects. Then we head into the layout and the paint phase, and the framework or the render objects, they manage this, and we generally do not need to worry about laying out and painting. You have the option to create your own render objects, of course, or you can always manage custom painting through a custom painter. So let's break these phases into the well-known Flutter trees. There are 3 trees: the widget, element, and render tree. And we will use a simple example to illustrate how these 3 trees work together. We have a widget called myWidget that returns a red container. And as you can see, Flutter builds out our tree. The interesting bit at this point is that there is another widget added automatically called a colored box. In the element tree, you will note that we have a component element and a render object element. And then finally, we have a render colored box in the render tree, the only thing in our render tree at the moment. Flutter created everything to the left to finally have this one render object. This is the core of the rendering library. This class implements the basic layout and painting protocols. You can think of elements as the glue between our widgets and the render objects. They keep track of parent and child relationships, and they also manage the state of our widgets. They determine when a render object should be updated or recreated. This is another way that we can represent the tree. You can see the stateless widgets and the stateless elements. Okay, so really interesting, but why should we care? Let's go back to our example. We'll change my widget to now be a stateful widget instead, and then add a gesture detector. When clicked, it calls the method changeColor, which sets the state and changes the color from red to blue. The darker nodes are those that were added or changed. As you can see, the trees are now starting to grow, and it's already getting complicated. The question now though is, what happens when we tap the gesture detector? How does Flutter efficiently change the color of the container without doing unnecessary work? Well, this is where the whole concept of these different trees come into play. The widget tree is designed to be torn down and recreated a lot. Widgets are meant to be lightweight blueprints used by the elements and the render objects. While widgets can be recreated a lot, the associated elements and render objects are reused as much as possible. To put it more simply, widgets are immutable and render objects are mutable. Something that is extremely important to take note of is the fact that Flutter can determine what element and render object it can and can't reuse by checking to make sure that the type of the widget has not changed. For example, if we rebuild the widget tree and all we change in the tree is my widget with some other widget, for example, a widget called exact same different name, then that will cause a Flutter to recreate all of the elements and render objects for that part of the tree, even though all of the widgets lower in the tree are still the exact same. Okay, we did it. We got through the theory. Now let's actually get to the fun part and explore the tools and examples. And to begin, we will explore the build phase a bit more. And by a bit, I mean a lot. To explore that, let's take a look at a tool that allows us to track widget rebuilds. The Track Widget Rebuilds option in IntelliJ and Android Studio allows you to do as the name says. As you can see, when we call setState, it rebuilds my widget and all of the widgets in that build method. This tool is particularly helpful when you're doing animations or working with lists or anything more complicated than a simple example like this. 10 out of 10 recommended tool. Actually, all of the tools are 10 out of 10, so we can get that out of the way. Next up is the profiling timeline in DevTools. We can use the timeline in DevTools to identify unnecessary rebuilds. But that's not what this is truly useful for. The timeline is meant to identify frames in your application that are expensive to compute. But if you enable enhanced tracking and track widget builds, then you will see all of the widget build methods that were invoked for each frame. Important to note that the time it takes to complete a frame is important. If it takes too long, then that will cause jank in your application. The red frames you can see at the top left indicate jank in the timeline. If you're a gamer, this will be more familiar to you. It means that the application drops frames and causes a stutter. If you drop too many and it becomes noticeable, people will complain. Flutter aims for 60 frames per second, and that is considered good for mobile. Your eyes won't be able to noticeably pick up a delay between frames. Normally Flutter does 60 frames per second without issues, except when it doesn't. If we go back to our previous example of the different rendering phases, we can actually take note which is the UI thread and which is the raster thread. You'll note that these match up nicely with what we see on the timeline. The general rule is that if the UI thread is slow, then you made a boo-boo somewhere in your widgets or state handling. This is the code that you wrote and code executed by Flutter's framework on your app's behalf. The UI thread creates a layer tree, which is basically a series of painting commands, and sends the layer tree to the raster thread to be then rendered on the device. If the raster thread takes the raster thread then takes the layer tree and displays it by talking to the GPU. If the raster thread is slow, then it can unfortunately mean a lot of different things. Most likely you still made a boo-boo somewhere, or you're trying to do something too graphically complex. Flutter uses Skia for its graphical rendering. We'll take a deeper look at this later on. You can easily see an overview of your app's performance by enabling the performance overlay. For this overlay to work, you need a material app widget in the tree. This will show you a real-time view on the device of how long each frame takes, so you can use your application and identify areas that are causing jank. While we are talking about different threads, it's worth mentioning isolates. Isolates are like threads or processes, but each isolate has its own memory and a single thread running an event loop. Unfortunately, we don't have the time to delve deeper into this topic, but if you're doing any long-running operation in your Dart code, then it could be a good candidate for isolates. Dart has also recently released something called isolate groups that enable you to spawn multiple isolates that live in the same group. Isolate groups enable performance optimization, such as code sharing code. I recommend this video on the topic if you're interested to learn more. There are also 3 different Flutter build modes that you should take note of. Each has their own use. The architecture between debug and a profile or release mode build is completely different. Dart does a lot of optimizations for a release and a profile build. For example, compiling ahead of time instead of just in time, tree shaking, null safety, and removing unneeded code and checks. Release mode should be the fastest, as most of the tracing is also then removed. If you want to go beyond just seeing what widgets get rebuilt and repainted, and you want to analyze how long the build time of each frame and widget is, then you will need to run in profile mode. You can also you can only run profile mode on a real device. Okay, we've explored quite a bit. Now the real question is, how do we reduce widget build cost? The first thing you should take note, should always do, is make use of constant widgets whenever possible. A const variable is a compile time constant, which means a single const object will be created and reused no matter how many times the constant expressions are evaluated. For widgets, this also means that Flutter won't unnecessarily rebuild widgets marked as constant. Flutter will be smart about determining that the widget's build will not have changed, so it can actually skip rebuilding it. To get this compile time optimization, we will actually need to build for profile or for release mode. This doesn't just apply for widgets though, but for any object. In this example, we have a for loop iterating from 0 to 100, and we're creating an object called const object and const object not. One is constant and the other is not. As you can see, if we inspect our memory, we have a single instance of the const object and 100 of const object not. So always prefer const. when it makes sense, you can also use static for non-constant objects when the class can't be constant, but you only need a single instance between all of your objects. Both of these classes are not constant, and we create 100 instances of the const object not class. Inside that class, we create a static final of const object another not, and inside the constructor, we print that static object. This will still create 100 const object not instances, but only a single const object another not. Sorry about the naming. You can also be clever in the way that you do your execution. If it's not necessary to compute something, then don't. So let's take a look at a simple example. Here we can see we have a simple condition and two expensive operations. If the condition is true, only then will we call the first expensive operation, and only if that is also true will we call the second. If the first condition was false, we will never call the expensive operations, and as a result, we saved on our compute costs. We can also sometimes increase the readability by using the late keyword. This example is exactly the same as before, but take note that operation 1 and operation 2 will only call the expensive operations once we try to access them, because of the late keyword. This is referred to as lazy computation. A big shout out to Remy for inspiring this example. Definitely follow Remy on Twitter. I have learned a lot from him. Back to widgets. The next important thing to reduce our widget build cost is to prefer small widgets. The main benefit is that it reduces the widgets that need to be to rebuild when calling setState. It also makes testing easier. Here we have the good old counter example. When you press the floating action button, it calls setState, which causes all of the widgets in my homepage to rebuild, except for those that are constant. So this is maybe even an example that we can break it down into smaller widgets. Can you think of a better way to do this though? To avoid all of these widgets rebuilding unnecessarily? You guessed it, the answer is state management. The state management frameworks we have are amazing, and all of them have their own ways to reduce widget rebuilds in your application. But let's not argue over our favorite state management solution. We'll keep it simple. Back to the counter example, let's unnecessarily optimize this like the developers we are. As you can see, we're using a plain old value notifier and value listenable builder. Now only the floating action button and the text will rebuild when the button is pressed. There are many other ways we could have done this as well. Was that necessary? Definitely not. We basically overcomplicated and overthought something that didn't need to happen. But the principles remain, and it's always important to keep your widget rebuilds in mind, and it also doesn't hurt to have the extra performance. Next up, what should you prefer, creating widgets or creating helper methods? I'll give you some time to look at the code and to give your opinion in the comments. Just quickly looking at the code though, it seems like using helper methods would be the faster approach. So what do you think? But there's actually no competition. We've indirectly touched on the point why you should prefer dedicated widgets. The main reason is that when we call setState or rebuild a particular widget, we want to contain that to only rebuild what is needed. This becomes really hard to do with helper methods. Our builds become really big as a result of using them. If you want more info, this is a great video on the topic. Okay, last thing about widgets. We've covered quite a bit regarding them, but this is the last thing and probably the most important. Don't do expensive work inside your build. It's the fundamental thing you should probably take from this talk. We've seen and talked about the fact that widgets are just blueprints for render objects and that Flutter recreates them a lot, so keep them small and keep them lightweight. In this example, we are removing the call to really expensive operation from outside the build to inside the state class. We can be smart about taking expensive work out from the build and putting them in our states instead. And Flutter can recreate the widgets as much as it wants without recomputing the expensive operations. Doing this in stateful widgets sometimes gets hard to manage. So this leads us back to state management. Yeah, you guessed it. So you should abstract complicated logic out from your widgets to your state management of choice, and be sure to reuse as much logic and not to redo any work when not necessary. Now let's move on to another area of the rendering phase that we can help control, the paint phase. As we've talked about before, a widget's painting is managed by the associated render object. You normally do not have to think about this step at all, but you should consider it from a performance perspective. Let's take a look at a practical example. We have our normal My widget that we've used before, but now it's sitting in a stack on top of a custom paint that paints something called Expensive Painter. As you can see, it's a rather complex painting, and intuitively you might think that Flutter paints that Expensive Painter once, and only repaints My widget when it updates. Actually, no, it does not. In this video, you'll see that even though only the My widget is being updated, the entire stack is being repainted. And the reason for that is because Flutter actually repaints everything on screen, each frame, unless you tell it not to. You can also see that both the UI and raster threads are working really hard. Note that this is on a profile release on a real device. We can easily solve this by introducing a repaint boundary. This widget creates a separate display list for its child, which can improve performance if the subtree repaints at different times than the surrounding parts of the tree. A render object will repaint whenever any render object that shares the same layer is marked as being dirty and needing paint. With the repaint boundary, now you'll see that in our paint phase, we are only repainting the colored box and not the Expensive Painter. Also, after a couple frames, the engine decides that it's worth it to cache the image, and subsequent raster thread frames complete faster. The dark red bar in the third frame actually indicates shader compilation time. So, repaint boundary everything, right? Not really. A repaint boundary basically instructs Flutter to cache the image, and raster cache entries are expensive to construct and takes up a lot of GPU memory, so only cache images when necessary. You can also see some metrics on your repaint boundary. In this example, it says that it's an outstandingly useful repaint boundary. You can also see which images are being cached by enabling the checkerboard raster cache images flag. Run the app and look for images rendered with a randomly colored checkerboard, indicating that the image is being cached. The checkerboard images should remain constant. You don't want to see any flickering, which would indicate that the image is being recached. I made a video about this if you want to explore the topic deeper. Highlight repaints, a fantastic tool to easily observe repaints in your application. This will basically show you the different repaint boundaries in your app, and it's awesome. Fun fact, Flutter automatically adds repaint boundaries to items in a list. When you highlight the repaints, you can see the different repaint boundaries. If you were to add something to the bottom of the list, none of these render objects will repaint. Using this tool helps us at Stream to observe weird behavior in Stream Chat Flutter, where if the list is in reverse order and new items are added to the top, then everything repaints. The elements and render objects are recreated, which means you also lose access to the state. There's a way you can help Flutter to determine the new position of items in a list so that it doesn't need to repaint and recreate the widget. As you can see here, the colors stay consistent. We made a video all about this on our Stream Developer channel that you can watch. Let's jump back to our well-known container example. Take a look at the following code. What do you think will be the output? What color do you expect? I will give you a few seconds to type it in the comment section. Okay, the answer is red. So correct to those that got it. Congratulations. Let's actually delve deeper into what is happening at the Skia painting level. To illustrate the painting instructions that we send to Skia, we will run our application in profile mode and then use the Flutter screenshot command to capture a Skia screenshot. Then we'll go to the Skia debugger and load the file the previous command generated. At debugger Skia, I'll load the Skia file and then we will inspect the instructions. This is what happens in the raster thread layer where Skia runs. As you can see, we create our red container with draw rect instruction. Now back to our example, we'll change it slightly. We'll add another container, this time a blue one above the red container. And again, tell us in the comments what will the color be. Correct, it's still red. But if we take a look at the painting instructions in Skia, you can see that we still go through the process of painting the blue rectangle. Flutter and Skia is unfortunately not that smart to optimize that out on your behalf. Something to keep in mind when you do more complex painting. There may be times when it makes sense to not render something when it's something else, or when something else obscures it, given that that something is complex to render. Back to the code. Let's make it a bit more complicated and add an opacity with 0.5 between the two containers. And again, what will the color be? You have 2 seconds. Correct, it's 8B6094 in hex. Congratulations to those that got it correct. I promise there is a point to this. If we look at the Skia debugger, there are quite a few more instructions. Most notably is this call to save layer. This bad boy is something we should pay attention to. Calling save layer allocates an off-screen buffer drawing content to the off-screen buffer might trigger render target switches that are particularly slow in all the GPUs. Basically, that means you should try to avoid it when necessary, or when you can. There are a few things that could cause a call to save layer, and generally some rules you need to think about. Use opacity only when necessary, and clipping can cause save layer when you use the anti-alias with save layer clip call. Other type of clipping is not as expensive as opacity, but it is still costly. So you're telling me I can't use opacity and clipping? No, don't worry. There's 100% of the time, 80% of the time, a way around it. Back to our example, let's modify it. We remove the opacity widget and instead set the color, the opacity and the color. And as you can see, now the call to save layer has been removed and order has been restored. Let's take a bit more practical approach and look at a real-world example. I made a demo application using the StreamChat SDK and Rive to create a sample chat app that allows you to send animated stickers. If you're interested, we created a code lab showing you how to create this app. Checkerboard off-screen layer. This is a switch that you can enable in your application to check whether your app is using save layer. Once the switch is enabled, run your app and look for any images that are outlined with a flickering box. The box flickers from frame to frame if a new frame is being rendered. Now in this video, we will turn on checkerboard off-screen layer to true and we navigate in the app. You will see randomly colored checkerboards whenever we do more complicated effects. This is a nice switch to turn on to identify areas in your application that are calling save layer and may prompt you to do a further investigation. However, just because it's showing doesn't necessarily mean it's bad. Just be mindful about it. If all of this is not enough, you can also enable the trace Skia flag when you run in profile mode. This will give you even more info. An interesting tool is the more debugging options that you can only run in debug mode. This allows you to disable certain effects in your application so that you can see if it has an impact on performance. I believe this is a fairly new tool. Another awesome tool in DevTools is the highlight oversized images. This tool will revert images that are too big and that are using too much memory for the size they're taking up on screen. These images that I'm using in this example should be replaced with smaller images. And as we're reaching the slide, I'm noticing that we are running out of time. So I'm just quickly going to go over these slides, just skim through them. The main point that I'm trying to make though is that don't be too scared. You can still use Flutter normally. Just be mindful, and there's always a better way to do something. So definitely read the documentation and beware of some of the gotchas, the widgets that could cause a lot of computation time. And you can always cache widgets. Animated Builder is a good example. And yeah, like I said, don't be too careful. Take a look at this slide later on. And then, yeah, if you want to take a look at anything Philip has made, he has made awesome blog posts and videos on this topic as well. Any questions, please feel free to ask.
Twice in one day. Cool. I'm just getting ahead of things. At least this way I won't have to do it again tomorrow. But hey, I wanted to take a minute to talk about a few of the things that you can be doing right now between the talks. Don't do this while people are talking. I guess you could, but let's see. There are a lot of activities and prizes. If you head on over to Valhalla and go down to the activities and prizes right here. Whoops. There we go. Right there. You can see there are plenty of things to do and a lot of different sponsored activities. We've got different prizes and gifts. Okay, there's a Dash action book, stickers. There's cash from the company. Okay, I need to check on that. Forget I said anything, people. I'm going to go check on that one myself. There are headphones from Stream. A lot of other things. If you draw a dash, you can win a dash. So code quality, the judging will be code quality, best drawing, etc., etc. Make sure to take a good look at that. Write a Flutter article and you can win a book, and that's sponsored by Invertas. So Invertas actually is behind a whole lot of the things in Flutter that you don't know they're doing. Okay, so the people from Invertas are very, very active, doing all kinds of stuff, but it's the kind of thing where they build some of the tools and some of the things behind the scenes that make what you use work. So definitely check them out. We've also got the Google Developers Library. Okay, and submit your projects or your articles. So you can get out there and get people seeing your work. And then the Arrive mobile app from the company, they want you to rewrite it. Now, the company is a really interesting case. They are making privacy really private. And the short version is you don't give out your private information to other people. You just give them your @sign and you get their information. And every time they try to access any of your personal information, it goes through the @sign. And what happens is the server looks and says, does this person still have permission? And if you decide to revoke somebody's permission, no, and then they can't access your personal data anymore, which is pretty cool because a lot of times you give that stuff out and there's no getting it back. Well, with @sign, there is a way to get it back. So be sure to check all them out. Apparently there's a lot of money going on here, 7,000 US. I've been busy working. But hey, Flutter Vikings, you can build Flutter Vikings. This is sponsored by Stream. Same people who got me my shiny mug. And there is a code lab here for you to complete. Then let's see here. What is this? At the last step, replace the example sticker pack with your stickers and then record a short video. Then there are quizzes by both Robert and Andrea. So you definitely want to check those out because Robert and Andrea are two of the best educators in Flutter. And you're not going to want to miss anything that they're putting out. And then, of course, social media contests, taking selfies, and all kinds of other various things there. So we just got the notice that the next talk is going to be coming up here in just a moment. And another thing very quickly about the next speaker here, Anna has been involved in Flutter for quite a while, about as long as I can remember. And she is one of the best out there. And you may have known her as Anna Domash, but we all want to say congratulations because she is now Anna Lishenko. So congratulations, Anna. I hope you're very happy, having a wonderful time. And let's see, with that, let's see what Anna has to say because she's going to talk some trash.
Hi, I'm Anna Lyushchenko, mobile development expert, BDD in Flutter from Ukraine, and I'm here to talk about Dart garbage collector. The garbage collector, or GC, serves as an automatic memory manager. The garbage collector manages the allocation and release of memory for an application. For developers, this means that you don't have to write code to perform memory management tasks. Automatic memory management can eliminate common problems such as forgetting to free an object and causing a memory leak, or attempting to access memory for an object that has already been freed. The garbage collector provides the following benefits: frees developers from having to manually release memory, allocates objects on the managed heap efficiently, reclaims objects that are no longer being used, frees their memory and keeps it available for future locations, and provides memory safety by making sure no two objects will have to fight for the same memory slot. Like most modern languages, Dart has a generational GC, which is based on the empirical observation that the most recently created objects are also those most likely to become unreachable quickly. So all new objects are getting allocated together in one group, one generation. Then there is an assumption that the longer an object has been on the heap, the longer it will probably stay there. So objects that have survived one or more garbage collections are then moved to a group with older objects, another generation. Dart runtime environment uses a memory pool called heap for objects allocations. Roughly speaking, the heap consists of the first or new generation or new space, young space or nursery, and second or old generation or old space. When the application starts, it naturally starts allocating new objects. If an object is less than 256 kilobytes, the heap tries to allocate it in the new generation. The new generation follows the Cheney's algorithm and is said to consist of two semispaces. Only one half is used at any time, one being active, the other inactive. New objects are located in the active half, and once that's filled, live objects are copied from active or from semispace to inactive or to semispace, ignoring dead objects. The inactive half then becomes active and the process repeats. In fact, if we check Dart VM implementation, and I spent quite a lot of time recently digging into the source code, most of the time there is only one active semispace. New objects are allocated here in the simplest way, called the bump pointer allocation. Basically, objects are located in a contiguous space in memory next to the previously located objects. The bump pointer points at the beginning of the available space. When the next object is written, the bump pointer is incremented to point to a space immediately after that object. This approach makes the allocation process very fast. However, it does not allow to deallocate individual objects or reclaim the memory region for a no longer in use object. The default value for the initial size of the new generation semispace is 1 or 2 megabytes depending on the device architecture. The thing is, some parts of the Dart virtual machine behavior are configured with flags. CLI lets you set any VM flag if passed before the Dart source file. But you would have to be writing an embedder to do this. It's impossible to change it in the runtime because virtual machine is already initialized. The initial size of the new generation semispace is configured through this flag. Imagine now that during an attempt to allocate a new object, there is no space available in a semispace. The first thing the new generation will try is to acquire a new page. The thing is, generation space is not really contiguous. It consists of chunks of 512 kilobytes called pages. Each page has a pointer to the next page, so they form a linked list. So, the new generation will try to acquire a new page, link it to the last existing page, and allocate a new object in it. If it could not allocate a new page because it has either reached the maximum size or we are out of memory, the next thing it will try is to run a garbage collection in the new generation and attempt allocating an object once again. If the allocation in the new generation still fails, even after garbage collection is complete, the heap will attempt to allocate an object directly in the old generation. This is only one of the scenarios when the garbage collection can be run in the new generation, and we'll see later what are other reasons for that. For simplicity, I will return to a visual representation of a single contiguous space and add more objects to make it more fun. We are now looking at a parallel Stop the World semi-space scavenger. It is called Stop the World or blocking because no mutations on the heap's objects graph are allowed while the GC runs. At this point, a new semi-space is created. The currently active semi-space is now called the From semi-space, and the new one is the To semi-space, to which we are going to copy a live objects. So, how live objects are detected? To understand that, I need to tell you about GC roots. These are static fields, local variables, method parameters, basically everything on the stack, and a thing called handles. The Dart virtual machine does not know which objects in foreign languages contain pointers into the Dart heap, including the virtual machine's own runtime implemented in C++. Foreign languages reference Dart objects indirectly through handles, which can be thought of as pointers to pointers. This way, when GC moves the object during the collection phase, it only needs to update pointers in handles. And let's also look into what is a three-color marking garbage collector. Three sets are created. The white set, or condemned set, is the set of objects that are candidates for recycling. The black set is a set of objects that are reachable from the roots and have no outgoing references to objects in the white space. Objects in the black set are not candidates for collection. The gray set contains objects reachable from the roots, but yet to be scanned for references to white objects. They cannot be garbage collected and will end up in the black set after being scanned. In main algorithm, initially the black set starts as empty, the gray set is a set of objects which are directly referenced from roots, and the white set includes all other objects. Every object in memory is at all times in exactly one of three sets. The algorithm proceeds as follows. Pick an object from the gray set and move it to the black set. Move each white object its references to the gray set. This ensures that neither this object nor any object it references can be garbage collected. Repeat the last two steps until the gray set is empty. When the gray set is empty, the scan is complete. The black objects are reachable from the roots, while the white objects are not and can be garbage collected. Chinese algorithm, on which the Dart VM new generation is based, implements such a three-color marking algorithm. Imagine this is our semi-space state just before the GC run. Objects 1 and 8 are members of the root set. Objects 3 and 4 are accessible from object 1, object 6 from object 3, and objects 10 and 12 are referenced by object 8. At this point, all objects in the From semi-space are members of white set. The first members of the gray set are root set members. They are copied into the To semi-space. Once an object is copied, the source object in the From semi-space contains the forwarding pointer to the new location. The To semi-space is meant to contain members of the black set and gray set. It contains two pointers. The scanning pointer points to the end of the black set, so objects below it belong to the black set. And the free space pointer points to the end of the gray set and the next free space. This means objects between the scanning pointer and the free space pointer are members of the gray set still to be scanned. The first member of the gray set is object number 1. It references objects 3 and 4, so they are copied into the 2 semispace and forwarding pointers are installed. The algorithm moves any white objects to the gray set by copying them into the 2 space. Objects 3 and 4 are now part of the gray set. We have completed scanning the first object, which means it can be moved to the black set by simply moving a scanning pointer over it. The process repeats. The next item in the gray set is object number 8. It has a reference to objects 10 and 12. So they are now copied to the 2 semispace. And pointers are updated. Next, we look at object number 3. It has a reference to an object 6, so it again is copied to the 2 semispace. Next movements of the scanning pointer do not produce any new references to scan. When the scanning pointer reaches the free space pointer, the gray set is empty and the algorithm ends. By this time, all live objects are copied from semispace to semispace, and the from semispace can be safely deleted. The garbage collector also logs collection stats and updates the estimate of scavenger speed. In fact, in this case, when the new generation garbage collection was triggered because an object failed to allocate, after it is complete, either full garbage collection or one of its phases can also be triggered in the old generation. But more about old generation later. Now we have a brand new active semispace with a few survivors already taking space. These are all candidates for promotion to the old generation on the next garbage collection run. The application continues to allocate small objects in the new generation until we again reach the point where a garbage collector decides to run a collection. It again detects all live objects. If the expected garbage percentage is under a certain value, it means we had too many survivors during the last collection. This value is defined with this flag, the default value for which is 90%. As a reaction, the new 2 semispace grows compared to the previous size by this flag value. The default is 2. The maximum semispace size is regulated by this flag, the default value for which is 8 or 16 megabytes, depending on the device architecture. We already know what happens with the new survivors that should be copied to the 2 semispace. But objects which survived this and the previous collection should be copied into the old generation. A question is, how exactly a garbage collector will know how many collections an object has survived? Well, that's easy. After the previous collection has been completed, when the semispace contained only the survived objects, it has installed a special pointer at the end of this list. So, every object under this pointer is a survivor and should be promoted. The last thing I'd like to mention about the new generation is why the scavenger is called parallel. By default, there might be several worker threads competing with each other to do the job of moving an object from semispace to the 2 semispace, or promoting the object from the new generation to the old generation. The number is defined with this flag, and by default there are 2 of them. By now we have already discussed several scenarios when objects get into the old generation. The most common cause is by surviving 2 or more garbage collections in the young generation. Each scavenger worker has its own local free list, from which they take space when promoting objects from the new generation to the old generation. Free list is basically a list of chunks of free available memory. If a chunk is quite big, this scavenger uses the same bump pointer allocation algorithm for individual allocations. So, if the object is under 64 kilobytes, the scavenger will try to allocate it via free list. If this attempt fails, it will try to grow the old generation by 1 page. Surprise, surprise! Old generation also consists of linked pages of 512 kilobytes. A new page will be added to a free list, and it will repeat an attempt to allocate an object. For objects larger than 64 kilobytes, it will immediately try to acquire a new large page and allocate an object there. The old generation has an additional linked list of large pages dedicated to large objects. This way, the old generation may grow up to a value of this flag, the default for which is 1.5 or 30 gigabytes, depending on the device architecture. The virtual machine limit is slightly below operating system limit to increase the likelihood of falling gracefully with a Dart out of memory exception instead of SIG abort. If there is still not enough contiguous space in a free list to accommodate an object, it will try to wait for any running phases of garbage collector and repeat the attempt. If allocation fails again, it will run the garbage collection in both generations and repeat an attempt once again. Then it also may try to force grow the old generation and also try to aggressively collect the garbage before finally giving up. If during this evacuation phase an object failed to be promoted, it will be instead copied to the 2 semi-space together with other newcomers. Once the GC decided to run a collection in this generation, the first step is the same: decide which objects to keep and which to erase, which is done at the marking phase. All heap objects have a single word header, which encodes the object's class, size, and some status flags. It also contains a bit called the mark bit. At the start of a collection cycle, all objects have their bit cleared. We are now again looking at the tree-color marking algorithm. Similar to the young generation, the algorithm starts at the roots, which is in our case objects 1 and 8. If a root object is an old generation object and its mark bit is clear, the mark bit is set and the target is added to the marking stack or the gray set. The collector then removes and visits objects in the marking stack, marking more old objects and adding them into the marking stack, until the marking stack is empty. At this point, all reachable objects have their mark bits set, and all unreachable objects have their mark bits clear. The marking phase is non-blocking for most of its time, which means memory mutations are allowed. If a new object gets allocated in the old generation during the marking phase, it is immediately marked as belonging to the black set with the marking bit set. The new generation objects do not participate in the marking phase, and pointers to the new generation objects are ignored. Instead, all objects in the new generation are treated as part of the roots set. The GC visits the new gen objects as roots at the end of the marking phase and sets more marking bits. Treating new gen objects as roots has an advantage of making collections of the 2 generations more independent. In particular, the marker never needs to dereference any memory in the new generation. You see, garbage collections in the new and old generations can happen simultaneously. So, this approach helps avoiding data race issues and the need to pause or synchronize with garbage collection in the first generation. It has, however, the disadvantage that no single collection will collect all garbage. An unreachable old generation object that is referenced by an unreachable new generation object will not be collected until GC collects the new generation object first. and unreachable objects that have a generation crossing cycle will not be collected until the whole subgraph is promoted into the old generation. Normally, this is not an issue because new generation garbage collections run much more frequently than in old generation. Now that all objects are marked, there are two possible scenarios. The lightweight is called sweep and the hardcore is called compact. During the sweeping phase, the GC walks through a list of all generation pages and looks at objects marking bit on every page. If GC meets a marked object, it just clears its marking bit and leaves it as is. It, however, adds all the unmarked objects to the free list. If it appears that all objects on some page are inaccessible, the page is deallocated and is released to the operating system. In addition, some large pages can be truncated. As you can see, the old generation may not only grow, but also shrink in size. The sweeping phase allows refreshing free lists with known slots of available memory. But as you can imagine, over time the heap becomes fragmented and requires compacting. For that, Dart VM garbage collector also implements a sliding compactor algorithm. In this algorithm, each page is divided into blocks, and each surviving object is related to a block where its header belongs. It will calculate the size of surviving objects in a block and find free space to allocate all these objects together. It keeps cursor pointing to the next free and next live chunks and repeatedly moves the next live chunk to the next free chunk, one block at a time. So during compaction, all live objects in the same block will slide such that they all end up on the same page, and all gaps within the block will be closed. Free space at the end of a page that is too small for the new block is added to the free list. All empty pages will be freed. We already know what objects might get allocated directly in the old generation if at the time of allocation the new generation was full. In addition, objects that are bigger than 256 kilobytes also end up straight in the old generation. We saw that GC has mechanisms to run garbage collection at times where it could not allocate new objects. But in fact, it is much smarter than just sitting and waiting for this situation to occur. There is a notify idle callback that notifies virtual machines that the embedder expects to be idle until deadline. Flutter, for instance, calls this between frames with the amount of deadline left until the next frame. Can you imagine? With Flutter aiming to provide at least 60 frames per second, frames need to render approximately every 16 milliseconds. The virtual machine may use this time to perform garbage collection or other tasks to avoid delays during the execution of Dart code in the future. This gives the garbage collector a window of opportunity to run its collection phases without impacting the performance. Let's see what happens during these calls. This is rough pseudocode. First, GC decides if it wants to collect garbage in the new generation. And it may want to do it for two reasons. Either the new generation is getting full, or it makes sense to run the idle garbage collection in the old generation because it only has a couple of free pages left. And because, as we saw previously, the entire new generation is treated as roots while collecting the old generation, it is beneficial to minimize its size. So, if the answer is no to both cases, no scavenge will happen. But if the answer is yes, it will happen only if it is estimated to complete before the deadline. But how does it know how much time it will take to run a collection? Well, during each GC run, it collects stats about the speed and the total size of objects it collects in a microsecond. For the initial run, it takes a conservative value of 40 words per microsecond. After the first scavenge, it will instead use a value based on the device's actual speed. Typically, the new generation garbage collection takes tens of milliseconds. Next, the algorithm checks if it still has time for collection in the old generation, starting from the most expensive one, Mark and Compact. The decision is made based on the usage ratio and fragmentation state of the heap, and also if there is enough time to complete this process before the deadline. As I said, this is rough pseudocode, because in fact more checks are involved, like no concurrent sweeper is running. The Mark Compact is preferred over other old generation garbage collection techniques if there is enough time, since it removes fragmentation and frees up most memory. But it is roughly twice as costly as Mark Sweep. Overall, old generation runs can take hundreds of milliseconds. Otherwise, the algorithm checks if the heap is in a good shape. If the old generation has grown significantly since the last time we checked, there is a probability that the next scavenge promotion will grow it even more. So, even though the following GC may exceed the ideal deadline, it performs Mark and Sweep on old generation. And finally, if there is still work to do because the available space in old generation is less than 5% or than the size of the new space, start a concurrent marking phase or complete the work that has been started previously. The next old space allocation will trigger this work anyway, so we try to pay at least some of that cost with idle time. Fascinating, isn't it? This will not trigger a collection if the heap seems to be at an appropriate size, even if there is substantial garbage that could be collected to free memory. There is another callback, Dart notify low memory, which Flutter calls when the operating system sends a low memory warning. It is a fairly expensive call that aggressively compacts all memory. Oh, I believe after learning about all this stuff, you might have some questions. Can I force GC to run? No. Can I disable GC? No. Can I do at least something about GC? No. The takeaway I want you to have is that Dart has an automatic memory management system that is your friend. It is smart enough to deal with tons of small objects a Flutter app may allocate, handle garbage, resolve circular dependencies, cross-generational references, and does it in a very delicate way, trying to avoid blocking apps as much as possible. Today we have covered a lot, but not everything. There are interesting details in each of these areas, like special large old generation pages, special treatment for images, isolates, and more. I hope there will be more interest in the community about this topic, and we'll see more talks about Dart Virtual Machine Garbage Collector.
Wow. You know, for several years, there have been 3 people who are at the very, very top of Flutter and Dart whenever anybody thinks of it. Gunther Zobacher in Dart, and then Remy Rousselet and Simon Lightfoot in Flutter. Well, move over, guys, because it looks like Anna's here to stay. I don't know about the rest of you, but about 25% of the way into her talk, 1/4 into the talk, I started to feel really stupid. And I'm going to be watching that talk several times. So people are making a different comment. GitHub is in fact down. There's a 500 error at the moment. It's nothing to do with Flutter Vikings. It's all of GitHub. So all we can do is burn incense and pray to the goddess and hope that it comes back sometime soon. Or just take a break, from work because you can't push anything and that's your excuse. You tell the boss you just go home early. With that, we have our next talk coming up with Mr. Craig Lebenz from the Flutter team. And he is going to be talking about managing state in a Flutter game. Craig, take it away.
Welcome everyone to Managing Game State in Flutter, Part 1. My name is Craig Lebenz, and I'm a developer relations engineer at Google, and I work on Flutter. And today we're here to talk about making games. And if I have one central thesis today, it's that app developers are game developers. And you might be thinking, really? Well, Flutter app developers are 2D game developers because Flutter uses Skia, a 2D rendering engine. Now, this is a 2D game, kind of. So am I saying that Firaxis should use Flutter to build Civilization 7? I am not. But for relatively simple 2D games, then I think our Flutter skills translate perfectly. And to dive into this a little bit more, let's think about what is a Flutter app in its simplest form. If you were to break down Flutter into the most simple pseudocode possible, I think it would basically look like this. There's a loop, and first it renders all of your widgets, and then it waits for you to call setState. And that await word there is important, because it means that Flutter is willing to kind of slow down when nothing is happening, and our users' battery lives thank us. So that's a Flutter app. Now, what's a game? Well, a game's simplest pseudocode looks pretty simple, or pretty similar. It's got a loop, and first it renders the state, and then it updates the state, processes any user inputs, allows all of the NPCs and any enemies on the screen to move or shoot or whatever. And a key difference, though, is that this game loop always wants to go at max velocity because games generally assume something is happening, always. There's always a need to re-render. Even in Pong, one of the simplest games ever, that ball is always moving. So the assumption in game development is that more frames is always better. So is the difference just that in Flutter, your app is willing to slow down and save battery, but a game is actually just trying to max out the GPU? Maybe, but I think the difference is that we think of games as just being fun. Using a spreadsheet app or like a booking app or an e-commerce app, they're not fun in the way that Flappy Bird was fun. And I think that's actually basically the only difference between a certain type of game and the Flutter apps that we're used to building. I think once you start using a framework like Flutter or Unity or Unreal Engine, then all of the skills that we've acquired building normal apps translate perfectly to games. So yeah, I think app developers are game developers, which brings us to the question of what game are we building today? Well, Puff and I brainstormed a game that fit within the following constraints. One, we needed it to be easily multiplayer-ified. Two, it needed to have minimal server-side logic while still being server-side authoritative. And then three, we have to be able to build it in 1 hour. So what we dreamed up was this kind of multiplayer maze game. And all connected players to the game will be controlling the same game piece. So we've got a little bit of intended chaos. Good luck coordinating as you try to escape the maze. But let's now think about our to-dos. What do we need to get done to actually deliver this game to Puff so that he can make it a multiplayer game? Well, first, we need to choose our technology. Obviously, it'll be Flutter-based. Then we need to actually write some code to instantiate our game state. Next, we need to position the board on the screen. And there's actually some subtle complexity there. Then, in that space that we've positioned, we need to render the actual maze. Then we're going to need to make our game dynamic by listening to keyboard events. Once we start receiving those keyboard events, we can then update the position of the player indicator. Move the player around the maze. But not everyone will have a keyboard. People on a phone won't want to use virtual keyboard. So we're also going to add voice commands. So you can just shout at your phone or computer and say up, up, left, 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 and escape the maze that way. And then we are going to pass the baton to Puff. So let's get into it. First, choose a technology. Now, the only real question here is, should we use Flame? If you're unfamiliar, Flame is a 2D game engine written in and for Flutter. And I checked out Flame. It's kind of always been on a list of things that I wanted to spend some time learning. But after studying it a little bit, it has a proper game loop. It has a ton of useful mechanics of collision detection for different sprites. But we're just walking out of a maze. So I actually thought that our game is too simple for Flame. But if I was making anything interesting, Flappy Bird on up, then I would use Flame. But we're just going to use widgets. We're just going to be totally vanilla Flutter. Okay, one down. Now it's time to start instantiating our game state. And the first question that I think we have to ask ourselves is whether or not game state management is intrinsically different from like normal state management. But to answer that question, let's look at some state management and kind of see what it does. So I think that there are 3 core jobs that any good state management solution has to do. And the first one is to establish the initial state. You got to know, what is the first screen that I need to run? What is the level before the player has done anything? Then we need to expose some methods for other code to update the state. And lastly, we need to expose a way for the state management, or the state management has to have a way to re-render after one of those state updates. In Flutter, obviously, that always routes through setState, which is what tells the framework to re-render the widgets. So here's some pseudocode that uses RiverPod, which I don't think many of us would think of as a state management solution for games, but maybe. Let's see if we can spot where each of the 3 core responsibilities of a state management solution are fulfilled. So step 1, this is pretty straightforward. The initialization happens in the constructor. We expected that. Now step 2, all those methods to update the state, well, they happen anywhere you just have a method. So that one's actually also kind of a freebie. And then in RiverPod, to re-update, you reassign the state variable. This is kind of a magic variable. It gets set in that constructor supercall. And anytime you reassign to that variable, then RiverPod says, oh, wait, time to redraw the app. So RiverPod does the 3 things, and we're going to see if these 3 things are enough to make a game. Now, quickly though, tucked up in the upper right, we see a reference to this maze state class. And I want to quickly peek at that because it's pretty core to what we're going to be building. So here's the maze state class skeleton, and you can see that I'm using freezed because freezed helps me generate a lot of very useful boilerplate and allows me to just think about which attributes my maze state class has. And those attributes are, first, the player location. We have to know where they are. The coordinates class you see there, by the way, that is, it has 2 attributes. They're both integers, x and y. That's all the class is. So we need to know the coordinates of the player location. We also need to know the coordinates of the target location. How do we win? What square is the victory condition? By the way, the x and y in coordinates, those are like game board locations, not pixels. They're just pure game logic. No display considerations yet. So we need to know where the player is and how do you win. We also need 2 integers for the size of our maze. How many rows, how many columns? We've committed ourselves to a rectangular shape. How many players are connected? We know that Puff is going to turn this into an MMO. before long. So we'll get our state ready to start rendering some of the things that he'll care about. The last command as well. This one's interesting because one day you're not going to be playing the game by yourself. So the last command might not have been your command. So we want to render that as well. The number of moves in total. This is pretty standard to keep score. Then a start time so that we can have a high drama countdown and say 3, 2, 1, go! And everyone will issue the same command and the player will dart across the maze. And lastly, arguably most importantly, we need the list of coordinates that represents the wall locations. Where can you not walk? Where will you bump into things? Now in the middle, we've got this move command class kind of sneaking by. So I want to peek at that one as well. And the move command class for us is actually just kind of a fancy enum. You can really think of it that way. But the fanciness comes from freezed, again, because freezed offers us this map method, and it's extremely high value. And just kind of keep that in the back of your mind. We're going to come back to that map method. Okay, so our maze state class is looking ready. And we can zoom all the way back out to our manager. But that maze state.initial method didn't seem to exist. We were just looking at the class. There was no initial method. So the first question, as we turn this pseudocode into real code, is, remember that wall locations variable, that list of coordinates. The first question in getting the initial state of our game is just answering the question, how are we going to get that information into memory in our application? And to store the level, to store the nature of a level, the state of a level in the beginning, for simple kind of grid-based games, I like to use just a plain text representation. Every character, means a certain thing. There's only a certain set of valid characters. And your code can very easily consume this list of strings. And critically, it's very easy to visualize and edit ourselves. And we have a very easy turnaround from kind of the primitive definition of a level to seeing it rendered in our app. So this is a plain text representation of a level, of a maze in our game. So we go back to the maze manager and we can replace that old fake initial method with a real method, and it's called parse maze. So what this method does is sets up a couple variables that are the things that we care about, and then it loops over the maze and fills up those variables. So now we know where all the walls are, we know the player location and the target location. And that code is actually very trivial, but takes up a lot of space. So I've just kind of omitted it here. It's all on GitHub. The next step that we have to do is actually return that initial state. That's contractually required of us by Riverpod, and pretty much every state management solution has settled on this requirement. Block, all the other ones. You owe your manager class, or it's called a block in block. Here we're using a state notifier. You always owe that an initial state value right away. So we return that here, and that's that. Now there's one more piece of Riverpod specific maneuvering that we're doing here. We create this provider object, and our widgets can use this to access the maze manager. And it's safe to put it here away from the build context because there's nothing that we're doing here that actually needs the build context, because we have no display information here. So we don't need to know the size of the operating system or any of those things. This is just kind of pure ivory tower game state that we're working on. Okay, so we've now instantiated that game state, and it's time to position the game board. And we had to instantiate the game state first because that told us how big the board is, and critically, its shape. So if the aspect ratios of the surrounding window and our maze are the same, then laying it out is pretty straightforward. Right here, the red box represents where the maze will go, and how we would position it, we give it a little padding, makes total sense. But what if this same maze is rendered on a phone with a totally different aspect ratio? Then we have some questions to answer. And what if it's in a browser and it starts in this shape, but then the user just picks up the corner and drags it, and the aspect ratio changes on us on the fly. We don't want to maintain our old layout because it would be really small in this one, in this aspect ratio. So the rules that I came up with for this involve, we're going to ultimately use a stack to render our maze in the middle here, but we're going to have a 10% buffer on the most constrained side. And we don't know what side that is. We're going to have to calculate it. It might change on the fly. We're going to have a 10% buffer on the most constrained side, which creates an unknown amount of padding on the other side. And again, we have to calculate which side is which. So how do we handle this? Well, if you've made some fun layouts in Flutter before, you've probably used the layout builder. So we're going to wrap the whole thing in a layout builder. And here's some pseudocode for what that kind of looks like. We can see we've got that padding widget there at the bottom, but the maze padding variable is key. That's what we have to figure out. So let's look at those calculations. Now we can see here that we're getting the max ideal width and height of each individual square. And it's each individual square because we're dividing by the number of columns and rows. So here we say, hey, game board, each square, how big would you be if you had to fit in 80% of the screen real estate? And that padding on constrained side variable, by the way, that's basically our 10%. And just allow it to be configurable. So we find out how big each square would be in either dimension, and then we just take the minimum of that for the most constrained side, and that's how big each square will be in the game. And this variable is all important. We are going to use this again and again as we lay out our game. The square size variable, we have to know this. Moving on, we can use that variable with the game size to calculate the actual dimensions of the maze. And then we combine that with the constraints provided by the layout builder, and we finally arrive at our maze padding. So returning to the previous code, we have our maze padding now, and we can position everything in the middle. And I've got a video here that shows us how this behaves. So let's play the video. And as we're dragging the window around, we see that the maze is trying to be as big as it can while always honoring a 10% buffer in the most constrained dimension, whichever one that is. Now, you might be wondering, is there a widget for this? And the answer is kind of. It takes a few widgets. So if we imagine starting with an aspect ratio widget and using the dimensions of our board, then we could ensure that we would render something that was the correct shape. So this red square is going to allow every square in the board to have the same height and width, which is what we want. But of course, it's too big. So we've lost our 10% padding. We're not centered. Everything else is broken. So we'll wrap that aspect ratio in a fractionally sized box. And here we say, hey, if height is the most constrained factor, then you get 80% of the height. If width is the most constrained factor, then you get 80% of the width. Okay, that's pretty cool. And that 80%, by the way, that is, again, I was just shortening the 10%, so it would fit on the slide. But you still use the variable. Okay, so this gives us the correct size and shape, but the wrong position. We're not centered. Of course, centering things is the easiest task a Flutter developer will ever do. We wrap our thing in a center widget, and we're right back where we started. This is a perfectly positioned game board. Now, we might have thought that was easier, but we critically must still have that square size variable. So we actually can't skip all of those calculations anyway. So either way forward. Now, this layout structure that we just went through felt different, right? But it was the same old widgets. So kind of game layouts, they can feel very different than kind of normal app layouts, but same old widgets. Okay, it's actually time to render the maze now. So we said we're going to put everything in a stack, and this is going to show our entire game. Everything that was the red square is going to be this stack. So first thing that we want to do is create a list of widgets for our horizontal bars. and our vertical bars. And these are just simple containers. You can see here, horizontal bars, they're going to stretch right to left across the screen. So they're 1 pixel tall. And then the vertical bars are going to stretch top to bottom across the game board. And so they're 1 pixel wide. And we take those just plain widgets and we throw them in a column and a row, respectively, in our stack. And suddenly we're rendering a grid. And this is starting to look useful. This could be a game. But we don't have a player indicator yet. So let's add that. This code will nicely draw just a simple circle. So if we start in the middle, we see this container. This is actually what draws the circle. It has a sufficient border radius and a fill color. So that's a circle. But we're in a stack. So we know that we're going to want to use a position widget to put it somewhere. But it would actually kind of be nice if the player kind of moves to the next square instead of teleporting. So we use an animated positioned widget to cheaply achieve that effect. And lastly, we need to position it correctly. And we can see here we use square size to translate game coordinates into pixel coordinates for the screen. So we go back to our stack, we add that, and now we're rendering the player indicator at coordinates 3, 1 currently. We're 0 indexed because naturally. Okay, now we need walls. So our maze state had that list of coordinates, the wall locations, and we can see now that we're just kind of like building this all up with vanilla widgets. So we're going to loop over the maze state.wall locations, and we're going to build a list of just containers is what we've got in the middle there. And again, we use that magic square size variable that we all importantly calculated to translate the location of each wall into where it should be in the stack. We return to the stack when we kind of plop that list of positioned containers, the wall blocks variable, right into our stack. And oh man, starting to look like a game. All right, next. We need to start listening to keyboard events because right now this is an extremely static maze. Okay, there's 2 different ways that we can do this, and we're ultimately going to do it in both ways. The first way here, we're starting work on what I like to call a non-UI widget. And this widget has functionality in our app other than impacting the layout. So visually, there will be no change when we add this widget. But it's called the Move Command Keyboard Listener. So you can kind of imagine what it's going to do. And one of the most important things it does is accept this function in the middle, the send command function. And this needs to ultimately route all the way back to our maze manager, which is actually keeping up with the game state. So we hope that any move commands we shove into this method will find their way back to that. But let's move on to the state class for this stateful widget, because that's where the good parts are. All right, in our knit and dispose, we see that we're registering a handler with this hardware keyboard thing. And if you've not heard of it, Flutter provides this to give you access to every single keyboard event that the Flutter engine receives. And this is independent of whether there's an input that might have focus or any other shenanigans going on. You will get every key press. So we register, and then later we dispose this onKey event method. So what does onKey event do? Well, first thing is it discards all key up events so that when the user presses a key, we only process it once. Turns out that's important. Then we check against all of the different arrow keys. We're only showing one here, but we check against each arrow key, and if it's up, down, left, or right, then we send the associated command through that method that we were passed. And then the build method, the last part of this widget, I promised you a non-UI widget, so this does nothing. It just passes through its child. Now, you might be wondering, what does the use of one of these non-UI widgets look like? Well, kind of just like any other widget. We can see here at the top, it's our Move Command Keyboard Listener. And the usefulness of these is that it scopes certain behavior to a page. And so we just wrap it around the scaffold where we want to be listening to keyboard events thusly, and we are only doing it on that page. we've got a scaffold with our maze there in the middle. And then this send command that we owe to the move command keyboard listener, that parameter, we use RiverPod's magic ref object to go grab the notifier and then access its method, and we're passing it through as a tear off. Okay, so our UI is now reporting events, but still no one is listening because that send method doesn't actually exist yet. So let's write it. So we're back in the maze manager class, and we need something that gets these move command methods. So the first thing that this does, if we remember, the move command class was generated by Freeze, and I was very excited about that because I said it gives us this map method. And what that does is take a callback for each type that the thing could be. Remember, I described it as a kind of fancy enum. So enums have a certain amount of flavors. Well, our move command has a certain amount of flavors, up, down, left, right. And the map method says, I don't know which one I am. I'm just a move command. So give me a callback for each one that I could be, and I'll call the correct one. Now, and this is exciting because these are required parameters. So maybe one day we're going to add a back command, and it just undoes the previous one. It'd be very easy to forget to go to all the places where we have code like this and add a handler for that back command. But Freeze will add a required parameter. So we'll get a linting error if we don't. It'll make it impossible for us to add a new flavor to our enum, but forget to handle it. So what does this ultimately do? It translates the player's current location, kind of through the move command into their next location, where the player is going. Of course, unless they're trying to move out of bounds. Also, unless they're trying to move into a wall. If either of those things are happening, then we discard the player's move. But if neither of those things are happening, then we lean into RiverPod's, if you reassign the state variable, I will update contract by reassigning the state variable so it will update. And we just have the new player location, that animated positioned widget, that's going to move the player there instead of teleporting it. And, then we've got some other scorekeeping to do as the number of moves have gone up and all that. So we've got another video here. You can probably imagine what this looks like. It's the maze, but as I press arrow keys, the character starts to move around. All right. So next up, we just need to listen to voice commands because again, that keyboard input pattern is not going to work for our mobile users. So, okay, we want speech to text. There's a package for that. Amazing. And it routes whatever audio it hears to the device's native speech recognition capacities, or capabilities. That's the word I wanted. So it's just going right to your browser or your phone. It's not like a Google ML thing or a bunch of Dart code or craziness like that. So before we talked about using this non-UI widget. Well, the other way that you can do this is to just have a dedicated class in your provider, in your state management apparatus. If this is in fact a non-UI thing, and speech, listening to speech, that's not really going to impact our UI directly. So we're going to use a dedicated RiverPod class. It's another state notifier. We've got speech state. We can imagine how that looks. The first thing that this does is instantiate the main helper class from the speech to text class. And then we also are going to require the send method, the same thing that our keyboard listener required, because it still has to route all the way back to the main maze manager. And then we need a way to turn the thing on. And ultimately, that gets us into on-speech result, which is some pseudocode. This line right here is really the pseudocode because it's kind of non-trivial to make sense and unravel the data that you get back from the speech-to-text library, but it's all on GitHub. Then we update our UI so that users can see what text is the plugin thinks it's hearing. And ultimately, we check those words for left, right, up, and down, and we send commands. And that puts us at a functioning maze escape game. And we just use normal state management, normal widgets, but we reapplied all of our kind of common Flutter knowledge to making not a typical app, but a game. And it's ready to be taken into the 21st century, the age of the internet, by Puff. So, Puff, take it away.
Yes. A, that was a great talk by Craig. B, no, I'm not Puff. I kind of pushed him aside because I wanted to get more time in the camera. But no, in all seriousness, I think Puff is pretty close to being ready. Are you ready, Puff? Puff is ready. Okay, so I'm not going to talk anymore. Isn't that new? Puff, take it away.
Thank you, Scott. I will not be pushed to the side. Hey, everyone, welcome. That was quite some setup that Craig did there, right? So he built a game, and we are going to apparently make it multiplayer, and we're going to do that using Flutter, of course, and Firebase. So this is going to be fun. Let me see if I can find my slides. There we are. Right. Oh, by the way, I'm Frank or Puff, and I'm a Firebase engineer at Google. That's what I always tell people. But let's get back to the important things. Because Craig built a fun local game, right? That's where you can escape a maze. And then he said that we were going to all work together to turn it into a multiplayer game. That's going to be interesting. We're not just going to turn it into any multiplayer game. We're going to turn it into a cooperative multiplayer game. So we're all going to be working together and see the same avatar walking through the maze live in near real time. And we're going to help him escape the maze. And that's a good thing, because by the time we are going to do that, he's going to have been stuck in there for probably the better part of 50 minutes by then. So let's get started. How are we going to do all this? Well, we're going to do this with 6 easy steps today. So let's first start with the first one, which is what is Firebase? And Firebase is a suite of 18 products that we have that you can talk to directly from within your Flutter application code. So these are cloud-hosted services that you can access directly from on the device or in the browser. And that's a bit different from what you're probably used to, because normally we probably all start with a 3-tier architecture, right? And you have some backend services, let's say a database. And then you have the devices that are accessing the database, and you write a server-side API for that, right? You write some code that takes the request from each device and then calls the database for it. Yeah. With Firebase, that's not how it works. With Firebase, we've taken the server away, and we provide you with client-side SDKs so that you can talk directly to these services from your Flutter app without having to write any server-side code. And that's going to be fun, and that's what we're going to do today. As I said, we have 18 services, but today we're only going to use one. We're going to use the real-time database. Now, I can see you wondering, what is a real-time database? So the Firebase real-time database is a cloud-hosted NoSQL database. We're really just storing a JSON tree in the cloud. So we have a tree of values. And here you see an example of what we could have for, let's say, a shopping list app. So we have a node called grocery items under the root. And under there, we have 3 items: milk, eggs, and kill. And now what we can do is we can build an app that reads this data and then displays it in the application. And since this is a cloud-hosted database, that means that everyone is looking at the same data. So we're seeing the same shopping list. And if you were to add something to the shopping list, everyone would see that. Well, that depends. It actually takes some work. And this is where the fact that Firebase is a real-time database comes in. Because with most databases, what you would do if you want to show the shopping list, right, is you run a query and fire a request to the server and say, hey, can I get the shopping list items? Then you display them. You'd wait for 2 seconds, and you'd request this, like, hey, are there any updates to the shopping list? And that's a traditional request response model, and you're polling the server. Firebase is actually different. When you first request the shopping list items from the server, we keep an open connection from the server to the client. And that means that when there's any change to the shopping list, we actually send that data to the client straight away. That's what you see in this animation. The yellow line is a client making a change that is then broadcast out to all other connected clients within milliseconds. That is really great, because if we look at our app, this is the data model that I want to use for that. So we have a position node, and under that we have X and a Y value. And right now, the avatar is positioned at position 4, 2. And if we then change the X to 5, we can see that not only does the database change, but the avatar is also moved. Now, this is just a bit of slide magic at the moment, but we're going to make this work. But the important thing to realize here is that in Flutter, you're used to a reactive UI, right? When you change the state, the UI magically re-renders. When we expand that to, or extend that to Firebase, we actually react straight to the database changes. So when the database changes, the database tells us about it, our application code, and then we update the state, which updates the UI. A lot of words. How about we make this work? The first step we need to do is we need to add Firebase to our app. Okay, so this is the Firebase console. And the Firebase console is where you manage all of your Firebase projects. And as you can see, I have quite a few of them. A project in Firebase is just a collection of all those backend services for a single app or for a suite of apps. So if we make our Maze game available, where you also make an admin app, they are part of the same project. So we already created a project here called FF Multimaze. We're going to open that, and then you see the dashboard for our project. Now, on the left, you see lots of products, but we're only going to be looking at the real-time database here. But there's more here. You can also see that at the top, it says that we have 2 apps. Because Firebase, just like Flutter, is a cross-platform platform. So it allows you to run your apps natively on iOS and Android or on the web, which really matches nicely with Flutter, right? You can see here that we have an app also for macOS, which is what I use for testing. But it says we have 2 apps. So if we check that, you see that the second app is the web app. And that's the one that we're going to be using in probably 10 to 15 minutes to all help the avatar escape from the maze. So if we click on the web app, we get a set of instructions on how to configure, the app in our application code. So this is a JavaScript code because it's a web app. So we're supposed to take this and add this to the JavaScript code. But we're Flutter developers. We want to just write Flutter codes. Well, there's a good thing for that. And yes, I indeed forgot to update the slide, or actually I didn't get to it. But there's a Flutterfire command line interface. So we can run a local command, and it will connect to the Firebase projects, and it will generate Dart code for us. This is the Dart code that it generates. Now, this is the first code slide. At the top of the slide, you see that we're in a file called firebase_options.dart. And any code slide will show the file name there. You see that we have 2 blocks of, it's not really code in here, right? This is configuration data. And you see all kinds of values in here that allow our web app and our macOS app to connect to the Firebase project on the server. You might be wondering, why am I showing you these values, right? Why am I not blurring them out? Because there's API keys in here. But this is configuration data. These are not secrets. These are literally the values that our Flutter codes needs to find the Firebase project on the server. So these are not secrets. These are not authentication. That's why I'm freely sharing them with you. Now, we're going to be using this first slide here, which shows the web configuration. And we need to use that in our application code. So we're going to switch over to the main.dart. We have 2 bits that we need to do in there. First up, we import Firebase core, the package, and then we also import the Firebase options file that you just saw. Then in the main method, we call firebase.initializeApp. We pass it the options that we just saw. Now this uses the current platform, but for most of us, that's going to be the web configuration. So this initializes this Flutter application so that it can find the Firebase project. You see that I use an await here. This is an await that calls to the underlying native SDK. So it finishes in nanoseconds, which is why I'm doing this in my main method and not in a future builder, but you could also do that if you want. Okay, that's all we needed to add Flutter, to add Firebase to our Flutter. Next up, we need to start showing the number of players. Okay, remember Craig showed this, and you see that we have a counter here. And as players are added, the counter goes up, and as players disconnect, the counter goes down. That's something we need to build. So let's first have a look at the database model for this. So this is the database model, similar to the grocery items, but here you see that the node is called connections. This is already the handy part of having a NoSQL database here, right? We can just add a new root node, connections. Now, under that connections, you see that we have 3 keys with like random sort of strings. That's 1 for each player that is connected. So we have 3 players connected here. And then the value of each of these is true. Honestly, the value doesn't matter here. We're not using it, but you can't have a key without a value. So by convention, we use true there. So we are storing a list of players here. We'll see how to read those values in a moment. If we switch to the Firebase console, we click the real-time database tab, and this is what the real-time database looks like. So you see that we have the same list of connections here, except that somehow it's now 4 connections, and the strings are slightly longer. If you look at the bottom here, it might be slightly tricky to see, but you can see that actually this database is in Europe. And I did that because I expect that most of us are going to be connecting from Europe. I am not, so my latency is slightly higher. But if I expect most players to be connecting from the US time zones or from Asia, I could also create a database there and get the best latency for the majority of my players. Okay, here at the top, you also see that we have the URL of the database itself. So most of the URL was also present in the options that we saw, in the configuration options. But this is actually a URL for the data that we see here. So this is the URL for the connections node, because every bit of data that exists in the database has its own unique URL. So you can address every value in here. Okay. Now, as players are being added and connected, this is what we're going to see in the Firebase console. So the green nodes happen when a player has just connected, and the red node is when a player is just disconnected. Okay, so we need to start wiring that up in our app so that we can actually see this. You can see side by side now that as a green node appears, the active players goes up, and as a node turns red, the active players goes down. So this is actually quite magical, right? The database updates, and we show it in the UI straight away. Let's see how we write the code. So we're now in mazemanager.dart, and this is where the code that manages our maze lives. And remember, this class gets created when the app starts, and then it exists for the entire lifetime. So we're first going to connect to the Firebase database here. So we created a Firebase database object. And this takes the configuration data that we saw earlier and uses that to find our database on the server. Next up, we go into the init method. We're going to listen to a special value in our database. So you can see that we create a reference to info/connected. This value indicates whether we are connected from our Flutter app to the cloud-hosted database. And this is a stream of values, right? It's true when we are connected, it's false when we are not connected. When we're starting the class, right, it's probably going to be false initially, and then it's going to become true at some point. So it's a stream of values, and we listen to that stream so that we get an update every time the value changes. Now, in here, we're going to take the value of the snapshot, and we're going to determine whether we are connected. And if we are connected, we generate a new node under the connections, like you saw in the screenshots earlier with the push method. This is a unique ID for our connection. And then we just write true, just like you saw before. So this now indicates that, hey, I am here. We are writing a node to the database. We got, and actually we probably should have added sign-in at some point, but since we really want to help the avatar escape from the maze, we're going to focus on some other things now. So if we look at the database, this is what we have now. We create one of these keys when a client connects, and we write true to it. Now we want to listen to this connections node so that we can show the player count. Remember in Firebase, right? You listen to a path in the database, and then you get an event every time the value at the path changes. So when somebody connects or disconnects, we automatically update the UI. Well, in code, that looks like this. We're still in the init method, and we're adding another connection to the database. In this case, we're creating a connection to the connections node. And we're again listening to the onValue stream. Remember, when this code runs and when the app starts, that gets us the current value of the connections node. And then after that, if it changes, we get the updated value. Okay. We count the number of child nodes that exists under the connections node. Remember, we had like a child node for each connection in there. So we determine the number of child nodes, and then we set that to the current state. And if we set it to current state, that updates UI. So I think the cycle should be complete then. Okay. Now you see the database and the app side by side, but now you know how we actually made it work. And you can see, right, the green nodes we can now explain, because this is actually when our info connected, right, fires true, and we say, right, we write our node to the database. But how do we handle disconnecting, right? And you might think, oh, that's easy, right, because I know web browsers. So we're going to do an on-unload on the web page, right? And then right before we unload, we remove it. But yeah, what if we're not in a web page? Or, you know, what if the web page, the browser, or maybe even the computer crashes and there's no time to run an on-unload? How do we ensure that we still remove the node? Or what if we're playing this on a tram and we go into a tunnel and the connection drops? Right? There's many cases where our code won't have a chance to respond anymore once a connection is about to drop. We only find out after the fact, and we can't update the database anymore. Well, Firebase has a special feature for that, and it's called an on-disconnect handler. So when we notice for the first time that we are connected to the code and to the database, and we write our own note in there, we also tell the database that, look, when I get disconnected, remove this node. And the database will execute this on its own when it notices that the client is gone. So this is a bit like a delayed write instruction, right? Where we tell the database now, when we have a connection, what to do when the connection disappears. Okay, that's all the code we need for this feature. We now show the number of active players, and we are writing and reading this and responding to it live. That's quite a bit of code, and we still have more work to do. Let's move on to the next feature, which is actually storing the game state in the database. Because so far we've been introducing new state, right? Because when we got the game at the start of the talk, we had only a single player because we were playing on our own. But now let's see how we can take the existing game state for the player position and synchronize that with the database too. If you remember, all the state management or all the state manipulation that the player does is in the send method, and that takes a move command. And Greg explains us how he did that. This move command can be either up, down, left, or right, depending on what key or what command you gave. Okay. Based on that command, we then determine the new location. This is code we already had, right? And then we update the state to show the new location. Okay, well, we're going to change that because we actually want to store the location in the database. So you see that we have a new node here called position, and we have 4 properties under there. We have the player location X and Y values. We have the number of moves and the last move in there. So what we're going to do is we're going to write the position to the database and no longer update the local state. So we're first going to disable the code that updates the local states. And instead, we're going to write to the database. Now you see that we have differently names for the properties here, but the values are the same. Okay. Notice how we're not calling copy state anymore, right? So the database is now our single point of the definition of the application state. And that is fun if we then look at the app and start playing with it. Because you might not notice, but on the left here, I'm pressing the keyboard, I'm yelling commands. And nothing is happening to the avatar because we're not updating the local state anymore. But you can see that the database is being updated on the right. That's fun to see if you're a geek like me, but it's not really a great game. So let's start reading the state back from the database. As you might expect by now, we are back in our init method for that. We're going to add yet another listener to the database. So now we're going to listen to the position node in the database. Again, this is a stream of values, a stream of snapshots. So we listen to the on value stream there. And again, once the app starts, we get the current value, the current position. And then every time it changes, we get the updated position. So first up, we're going to decode the values that we get from the database so that we can get at the individual properties. Then we take those properties and we put them back into the state. And this code probably looks familiar, right? Because this is the code we just removed from the move method. So we, instead of updating the local UI straight away, we actually now write the local state to the database and then respond to when the database tells us about this change. So we just move this code around. Okay. So instead of updating the local state and the database, we only update the database and then we react to the change in the database. Now you can see now that actually both are updating at almost the same time. And if you look very, very carefully, you might notice that there is a timing difference. Sometimes the local UI updates before the database actually updates. You may wonder why that is. Well, the Firebase SDK is an optimist. It assumes that the write operation will succeed, so it immediately fires the local event. And that gives us a very snappy UI, right? It updates as soon as you press the button, without us having to write a separate copy state code for that. It also leads to fun consequences, because sometimes the write might not succeed. And we'll see that in a moment when we start validating the moves on the server, because we need to talk about the problem here. The game as we have it now is not secure, right? And this is important that we fix it before we all start writing to the database. Because if we play the game now as it is, there's no way for us to bump into walls or move off the map. No matter how hard I try that, the avatar behaves correctly. And yeah, that makes sense, right? Because there's this code that we wrote for that. And the code rejects any moves that would move us out of bounds or into a wall. And that is really good because we don't want to write that invalid state to the database. Or do we? What happens if we disable the validation code, but leave the writing to the database? Oh, let's have a look. Okay, so we're at the bottom right, and oh, that's interesting. We're going straight to the wall and taking the shortest path to the exit. Not only that, we could also move off the map, and who knows, the app might crash because of that. Or, we could have a malicious hacker, right, who takes the configuration data that I so freely showed earlier, and then writes their own code. And instead of moving to the exit step by step, just teleports from the starting point to the finish in one step. We want to fix this. When all you have is a local single-player game, there's nothing at stake, right? The chances of somebody doing something like this are small. And even if they do, they're only doing it to themselves. After all, folks are just playing for their own fun. But when you add multiple players to a game, they become competitive, right? They don't just want to play, they actually want to win from everyone else. And normally you would catch those types of cheats in the server, but remember, I took the server away. So we need to fix this in another way. And luckily, Firebase has a solution for that. Because for every access to the database, we have a set of rules that you define that determine whether that access is allowed. So these security rules sit in front of all access to the database. Let's go back to the Firebase console for a moment and check our database. So you see the position node here, but there's also a tab called Rules. And if we click on that, we see the security rules as they apply to our database. Now, these are just the default rules, and they are shown here. And I always tell people that you should treat rules as if they are part of your source code of your application. So let's copy these default rules into a source slide. These are the default rules for test mode. And the rules name there is like fixed, but this part is specific for our app. And it's the default that says anyone can read or write the entire database until the end of February. Yeah, that's not great, right? Because this is almost the same as saying in your Dart code, it's like, hey, if you enter a SQL statement, I will execute it against the database. You would not do that in your Dart code. So you should not allow it in your database rules also. In fact, you should make sure that your database rules only allow what the code of your application needs and nothing more. Let's see how we're going to do that. So we're going to focus on the position here. There's a few more nodes in the database. We are going to focus on position. And we want to make sure, right, we have 4 properties in here. Last move, moves, X and Y. We're going to validate these. The first thing I want to do is make sure that these 4 properties always exist, because honestly, the code depends on it. The first thing here is we take away the read and write permissions on the root. Nobody can read or write the root anymore because it's not needed. My code doesn't read the root from the database, so my rules don't allow it. Next up, we write a rule that's specific for the position node in the database. We say in there that you can read and write them. This is already more secure, right? Because nobody can now go write their own code and just wipe my database. But we also want to validate that those 4 children are there. So we write a rule and that says new data. New data is a built-in variable that we use to validate it. And we say that if you write new data, it must have these 4 child nodes. This ensures that nobody can delete any of these properties. That is great, but we also want to make sure that the values that they write are valid. So we're going to write more rules for that. We're only going to focus on the X and Y for now, but we can do more validation here. This is probably the most complex rule we're going to look at, actually. So you can see that we have sub-rules for X and Y. They're the same, by the way. So we now have, at the root rules, then we have position, and under position, we have X and Y, just like we have in the data model. We say that we validate that the new data and the data are between -1 and 1. Right? So we take the new data, as you're trying to write it to the database, we compare that to the old value of the X, we subtract them to each other. So that gives us a delta value. That needs to be between -1 and 1. So this captures the teleport cheaters, because now you cannot jump to the exit in one go anymore. You must move there 1 step at a time. So you can now only move from the avatar position to all the blocks within the red square. And this is already a lot better, but we could do a lot more, right? For example, we also know the actual command that somebody gave. So we could validate that if you give an up command, that you must increase the Y value. You cannot change the X value. We're not going to do that, but definitely you can do a lot more security. What we do want to do actually is still one problem here, because you can still run into the walls. So let's fix that. This is the definition of the walls in our database. So you can see that we have a array of strings, and each string is like a row of the database, and an asterisk in there indicates that there's a wall. Now our security rules must be able to access this information. So what we're going to do is we're going to take this information and write something to the database for every position where there is a wall. This is what that looks like. So you see that we have a root node maze child node, and under there we have these keys with the value is true, but every key is the X space Y position of a wall in the database. Now it's in the database, and my security rules can access it here. So we're going to go back to the right rule for the position node. You can see that we go back to the root of the database, we check the maze child node. Then we check in there, and we take the X and the Y value that you're trying to write to the database, and we paste them together. We check if there's a node that exists for that. If that node exists, that means there's a wall in the location that you're trying to move to. So we tell you that you can't move there. See the exclamation mark in front of the root? So now you can no longer move into walls. You can only move one spot at a time. Let's see what that looks like. So here you can see that I'm moving around. And you can see that I'm trying to move into the walls, and I'm briefly succeeding, but then I'm put back in front of the wall. And the rejection of being put back in front of the wall is actually done by the security rules we just wrote. But then why do we see the avatar briefly move into the wall, right? That's not what we want. Well, remember, that's because we're cheaters. We disabled the validation code that ran client-side, right? So all we have here now is the database. You might remember, right, that I said that the SDK is an optimist, that it fires the event straight away. So what happens now is if we write the new position to the database, immediately that fires an event, and we update the local state. So we put the avatar into the wall. Then the command is sent to the database, and the database says, yeah, this doesn't fit your security rule, so it rejects the write operation. The SDK hears about that, and it fixes it to the previous position that you had. And this is really what we want, right? Because now, actually, only the cheater sees it. The database never gets updated with the wrong value. In fact, let's have a look at that here. So this is the same as we were doing before, but now you see the database. And you will see that sometimes I make a valid move, and you see it both on the app and on the database. But when I'm moving into the wall, you'll see that nothing is showing up in the database. The invalid position is never written. This is what we want, right? Because nobody else should see this wrong position, because that's me cheating. In fact, let's start a second app. It's a bit crowded here, but at the top there's a second app. I'm still controlling the app on the left here. You can see that I'm moving around, and when I'm moving around, you see that the app at the top slowly updates at times, right? And but it doesn't show the illegal moves. That's what we want, right? Now only the cheating user can see the cheats. Okay, that is great, by the way, but for gameplay, we really would prefer it if honestly, we just validate, right? Because it's a much better experience, because now the local updates are instant, but they're always valid. Okay, important thing about security rules is that I want you to treat security rules as part of your code, as part of your application logic. And I want you to write rules that exactly match your code. So they should allow anything your code does, but nothing more. Okay, that was a lot of work. Are we ready to help our avatar escape? Let's play a game. I want you all to go to multimaze.app. I'm going to leave it up for a brief moment, but we're going to switch over in a bit, because we're going to play this game together. So what we've done is we've deployed the code that you just saw, and that's available on GitHub, and you can now play together. Okay, you have it, multimaze.app. I'm going to turn over here. You can also see it at the top. Oh my. There's 45, 46, 48, 50 players connected here, and we're moving around like crazy. Like, honestly, I've tested it with up to 5 players so far. This is amazing. See, everyone is trying to move around, and we are moving at one step at a time. Oh, did you see that we hit the end exit? When we hit the exit, it counts down, and then we're going to start again. So we're moving again. This is so cool to see people. Oh my, we're ice skating around and we're trying to escape. Oh, that was actually really fast. Did we jump to a wall? Did I miss that? This is so cool to see, folks. Okay, we're doing one more. Now we're stuck into that corner there, right? You can see how hard it is, right? It turns out that collaboration with internet connections is not always the easiest things we can do. Okay, one more. We have exited. Thank you so much, everyone, for playing. It's been a treat to see you all here. If you want to learn more about this, check out the repo that we shared. And I look forward to actually watching the last talk for today. Scott, Who's our next speaker?
Next speaker. We have another speaker?
We don't?
No one tells me anything. No, we've got one more speaker. In fact, we have Anna's husband coming up next. And I think that's what he's going to be known like forever for the rest of his life, because Anna was so great. He's just going to be Anna's husband now. No. Alexander is coming up, and he's going to be talking about BDD in Flutter. So, and thank you, Puff.
Thank you for having me. It's awesome. I'm going to switch over to the chat and see what everyone was saying.
Hello, my name is Alexander Lyushchenko. I'm a senior staff mobile engineer at Tide and GDE in Flutter and Dart. I develop cross-platform mobile apps for almost 10 years. Worked with different companies, tiny startups and big corporations, in teams of any size, and I've noticed different patterns of successful projects. There are tons of different criteria, of course, but good communication and the intention to automate everything from day zero are truly one of the essential ones. Today we will cover both these topics, but before talking about good teams, let's think about what is a good app. I will give you a second or two to answer this question. Why do you like apps you like? Have you found a reason? Well, there might be so many answers to this question. Some of you might think, my favorite app is so fancy, I just love it. While my fellow designers and folks with an extremely developed sense of beauty, you're right, design is important. Though sometimes there might be too much design. The problem was raised by Paul Adams, ex-brand, product and UX design at Facebook, Google, YouTube and others. In his great article, which is called The Dribblization of Design, he states that many UX UI designers are practicing digital art instead of creating good mobile apps. Most of the design on Dribbble looks great on Dribbble only, but not in real life. Well, of course, design is important, but it's not essential. What is essential then? Maybe we love apps without any bugs. Well, of course we do. Here is an app. It shows an empty screen with an image. I don't think it's completely bug-free, but the chances that most of its users will not face any problems are quite high. Again, this app might be a state of art, but that's not a good app or app that user might love. From my perspective of view, a good app, an app that I might like, is an app that solves my problem in the most efficient way. So the app must be an answer or a solution for something. And how to create a solution? You need to make sure that you understand the problem. How can you understand other people's problems? By talking. Just ask them and listen. The problem is that we, developers, do not always have a chance to ask real users about their problems. It's really common that we operate user stories. Any problems with user stories? Well, no, but actually, yeah. Usually they require clarifications. To get required clarifications, we ask for examples to cover edge cases. Spoiler alert for the topic. Examples are extremely good for documenting the app's behavior. User stories are unidirectional. That means that someone creates a user story, moves it to a to-do backlog. Then the developer, that's you, picks that story, reads it, asks for more samples, returns it to a common backlog. It's a slow cycle of endless clarifications. But the most interesting part here is that the user story is not even a story. Let's write a real story instead. For example, Here is a marvelous story about how I bought ice cream. Do you remember my iPhone with Apple Pay? Once I was in the store and I asked for the ice cream and they paid. As a result, I had ice cream. Well, that's a story, huh? While I'm waiting for my polite surprise, let's rewrite the story a bit. I will turn it into a manual on how to buy ice cream. Given you have a device that supports Apple Pay, when you are in the store and you ask for ice cream and you pay, then you'll have ice cream. Gorgeous. But you know, there will be always someone who will ask that many questions. What if my device supports Apple Pay, but I didn't set it up? What if I'm in the store that is not selling ice cream? What if I accidentally asked another visitor? What if I don't have money? What if it's not possible to pay it with Apple Pay in this particular store? What if? What if is the most important question for your product. Listen to people that ask what ifs, because they will make your app much better. Where to find people that will help you with what ifs? Well, usually we call these folks domain experts. These experts are sources of both examples and what ifs. And they are not a group of folks in suits that speak in math. If you develop an app for physicians, ask physicians. If you develop a music app for teenagers, teenagers are your domain experts. Well, you got it. Talk to your users. But there is one more expert that we usually skip. It's you. You have the domain knowledge of your area, so you might be less about examples, but much more about what ifs. Having conversations with domain experts, using examples to gain a shared understanding of the desired behavior and discover unknowns, that is what BDD is. BDD is about human language, not Dart, not math, just plain English or Ukrainian or French. It's about dialogue, a constant flow of examples and what-ifs. Now you may think, all right, I've got it. We just need to talk to our users and write better user stories. Well, yes, but actually no, not really. Let me show you how to translate talks into code. Here we have a good old counter app. I promised you to translate talks into code, so let's start with talks. To document our conversation, I will create a new file. This file will act as documentation that describes some counter's features. Let's call it a counter.feature then. This is a document, and documents usually have some header. What can we put here? Well, that's a feature and that's a counter. Usually I would put more text here, add some description, additional details, and maybe even a link to a Jira task, but for now counter is good. Cool, let's talk. What can we do with the counter? Well, we may open it. That's some use case or scenario for a counter. Let's call this scenario the counter just started. What should happen when the counter just started? Well, the user should see some text and a button. Alright, what can we do with the counter? Let's say that the user can tap on an add icon. That would be another scenario. The counter should increase. Again, given the app is running, when I tap icons add icon, Then I see one text. So we have a really basic documentation now. What's next? Now let's translate talks into code. Our documentation is written in a language called Gherkin. It's an industry standard for behavior-driven development, BDD. Here you might see almost all its syntax. Features should start with keyword feature, scenarios with scenario, and each scenario follows a given when-then pattern. How to convert this into code? There is a package for that. In fact, if you search for BDD on PubDev, you'll find many different packages. You can choose any, the idea will be the same. I like code generation more than regular expressions, that's why I'll use BDD widget test package. It uses code generation, so we need to add build runner to the dev dependencies. And of course, we need to add the package itself. If you are familiar with code generation, you might guess what's next. If not, to run code generation, you should write this command and wait for a couple of seconds. This command will not only run the generation process, but will make it listen to changes inside the project. Look, some code was generated. I'm thrilled to see what's there. Well, that looks almost like our feature file. Look, feature name became a group name, scenarios became tests, and scenario steps became test lines. Notice that the step folder was generated. It holds all steps for all scenarios of our projects. Let's open one. Magic, but how? Why? What's going on? Relax, we just used common steps only. The BDD widget test package is smart enough to save you some time typing and generated these files for you. We will talk about how to create your own steps soon, but before that, let's run tests. Passed. Usually we talk and write specification before doing the actual development. So if you ever wanted to try the test-first approach for the development, here's your chance. Let me show you what that usually looks like. Let's say that we should see the to word instead of a number when the counter shows 2. The same given the app is running step. When I tap icons add icon and I tap icons add icon, then I see 2 text. My code generation is still running, so the moment I save the file, a new test was generated. Let's run tests. I hope one should fail now. Alright, we have a failing test. It's time to fix it. Following test-first practices, I will do this in the most straightforward way. If counter is 2, then show 2, otherwise show counter value. Our tests should pass now. Nice! Let's look at our tests now. The line given the app is running is duplicated in all scenarios. If it was the app's code, we would want to extract it somewhere to avoid code duplication. The same here. I will create a new section in our documentation which is called background. In the background, I may place all lines that will be shared across all scenarios. Now our scenarios look much cleaner. We tend to use human language in our tests, but you would not say I tap icon and I type icon, right? You would say I tap the icon twice. Let's refactor the scenario a bit. I will write it like when I tap icons twice. The code generation is still working, so right after I save the file, I'll have a new step generated. The step is the custom one, so I'll have to implement it myself. The implementation would be similar to iTap icon. In fact, we even may use the iTap icon implementation by just invoking it twice. And of course, I don't need those steps now. Cool, let's run our tests. That's the way you may develop your apps. Talk with the team, with users, create scenarios, validate them, generate tests for your app. All you have to do would be to fix your tests. We like apps without bugs. Is it true that if the app is covered with tests, then it is bug-free? Of course not. Tests prove that only scenarios that are covered with tests are working. But at least you may verify that you have little to no code that is not covered with tests. To validate this, we may run the Flutter test coverage command. This command will generate the coverage report. You may generate an HTML report from it, or if you're using the Coverage Gutters plugin like I do, you may see which lines are covered by tests right in the IDE. As you may see, we have green lines everywhere, which means that all business logic of the app is covered. We were talking about functionality, but what if you want to test the UI itself? Well, there is a package for that. Let me show you. We like apps with good design. What if it's a requirement that the app's primary color is green? The first option might be to look at widget configuration, but we might have a problem here. Let's say that we want to validate that the icon is green. But the color depends on theme. How to validate the color in tests? We may write complex steps that will iterate through the widget tree looking for themes and other configurations, get the required color from there and compare it to the expected one, but that would be really hard to write and, most importantly, to maintain. Instead, we will use golden tests here. There is a package for that which is called Golden Toolkit. I'll have to restart code generation now. So let's create a new scenario. The counter is green. How to validate the color? Let's make a screenshot. Validate it just once manually and then trust our tests to do the validation for us. I'll create a new step. Then the counter screenshot is verified. Now we need to implement this step. Here things will become tricky. If I will just run this test, I will get an exception. That's because the test method name is test widgets, but for golden tests it must be test goldens. So we have to change the name. We can do it like that. Now we have an error. We need to import that name. To do that, I'll write import in the feature file. That's when things became a bit messy. Our documentation gets unnecessary details. It's possible to get rid of them here, all answers are in the documentation, but I am a bit limited in time, so I'd like to focus on other stuff now. To generate screenshots, which we call goldens, I need to run this command. A new file was just generated. It's a screenshot of the app. Oh, look, something is wrong with fonts. And that's fine. We have this problem because the font of the app was not loaded, and so all texts were replaced with black and gray lines. It's so easy to fix this. The solution is in Golden Toolkit documentation. But you know what? I kinda like it as is. This behavior forces me to write proper tests instead of just making tons of screenshots. I want to validate the counter in my tests and not the screenshot of a counter. By the way, we need to make our counter green, right? So let's do this. Now I need to update screenshots one more time. Like that. And now let test framework to validate my screenshot. Most probably your real app needs to communicate with some backend, but our tests are more like unit tests. Using the real backend will just crash the app. So what can you do? Let me show you one trick. Here is an app from Anna Lyushenko. This app shows the space launches list. Well, we are less interested in the app itself today, sorry Anna. Let's look straight at tests. The background section looks familiar, the same with then I see text, and I wait step should be intuitively clear. We just wait here, and we have two given steps. Let's look at the implementation. It is possible to add a network interceptor that will prevent a real API call. You may wonder how it's implemented, so let me show you. This interceptor checks all network requests, catches all requests to that particular URL, and replaces the output. That means that the app will not even know that the network was fake. So all deserialization, mapping from data transfer objects, well, literally everything will be tested with our tests. But this is not for real. The network is mocked, the database is fake. Show me real tests. Okay, here you go. Let's get back to the counter app. If you want to validate everything for real, you need integration tests. I will create a new folder for them. And of course, we'll need to add a new dependency. I will restart a code generation now. By default, code generation ignores integration test folder, so we need to configure the code generation. Oh look, there is an additional trick in the configuration. It says that it is required for sharing steps between widget and integration tests. Let's try to create a feature file in integration tests now. I will just copy-paste our old documentation and maybe remove a few scenarios. A new test was generated. All steps were already implemented, so I can just run tests. That might take a while because now the real app compiles and installs on a real device. Here we would not need interceptors to mock network queries. We will have a real database, real platform-specific features, because these tests will test the real app. Describing features first and then writing the minimum code that covers the feature makes you focus on what is important only. You will not spend hours writing awesome services and repositories if a simple CRUD entity will do. You will not handle situations that cannot affect users' behavior and so they are less important. It's like a Yagni, you aren't gonna need it principle that is bundled in your dev process. The traditional approach with user stories is good for outsourcing companies, when the scope is fixed and everything that is outside of the scope is charged additionally. To create a truly good modern mobile app, you need to talk to domain experts, both end users and the dev team. It's easier to talk when you understand each other. So we talk in examples and document all what-ifs. Then we generate tests for the app from our documentation. If you are experienced in BDD, you might say that that was not BDD at all. And you're right. From my experience, it's easier to start like this, but here are a few recommendations for you if you want to use BDD as a pro. It's really common when all our steps are starting with I. I type something, I enter text, and so on. This is not a problem while all Gherkin scenarios for a project use this point of view. But if in one step you'll have when the user enters something, and in the next step there will be I see the icon, that would be really hard to read. So which point of view is better? There is no definitely correct answer. But if your app has only one role, and you're sure that I and user are always the same person, pick the one you prefer. If your app might have several roles, use a third-person point of view. When the user taps the button, then the administrator sees the icon. Or, if you just like the first person, write an additional given statement, like given I logged in as administrator. In real BDD, we describe the functionality and not actions. So instead of writing when I enter test at test.com text into login edit field, and I enter password into password edit text field, and I tap login button, you write when I log in. Why? To not repeat yourself all the time. At some point, the login process becomes shared knowledge. So let's follow the dry don't repeat yourself principle in the documentation too. Well, this problem should be intuitive clear. If you see when steps after then steps, just split the scenario. Sometimes you may find yourself writing a long scenario. By long, I mean more than 6 lines. Long scenarios are harder to read, so just combine multiple steps into a single step. When the user logs in or when I am on the search screen, without specifying exact steps and parameters. That's all I wanted to show you for today. If you have something to ask, do not hesitate to ping me on Twitter or drop me a direct message. Thanks for watching. Bye.
Well, there we go. Now that was a much needed talk on business-driven development. We don't see enough about that. So, hey, we are coming up to the end of the day. Have we gotten rid of that Viking yet? No?
Hi.
Hey, there you go. Good to see you, Machid. How are you?
I'm very good. How about you, Scott?
Doing good. Doing good. Yep. And actually, we have, well, yeah, we're doing good. Sorry, you can't see something I was about to point to because of the name tag, but that's all right. So let's see here. We're about to wrap up. What were you thinking here before we go?
Well, we have a closing slides. I just want to make sure if Simon is also going to join us quickly.
I think
Just say,
oh no, that's not Simon. Sorry, never mind.
yeah, sorry, mistake. But
Somebody's waiting for me to finish.
This is Simon.
Oh,
So,
no.
yeah, well, we've been in the backstage, I think maybe since our noon or like 8 hours ago. It's just sharp 8 hours that we are live. So, nah, for sure more than that. But I mean, we are live 8 hours. So these are the faces right now behind the backstage, and we should thank Simon and Scott for doing an amazing job today to bring this conference also to
Thank you
live.
for having us.
So thanks to you, Majid. Let's be honest, you've been really the one organizing it.
You all have no idea how many months Majid has been working on this, sweating it, worrying about whether or not it's going to be able to be in person in February. He arranged for this great big venue and all these caterers, and then had to turn around and cancel it because nobody could get visas to Norway. And how much have you slept in the past week? 2 hours?
Well, yeah, a few hours for sure.
Oh, yeah. You'll sleep well tonight.
Yeah, for sure.
But don't sleep
again,
so late that you miss tomorrow.
So we've taken some input of everyone's input today, and we're gonna slightly tweak things for tomorrow, so everyone has a better experience.
Sure.
And we'll hope
Let's
you all
go
have great
through
time.
our slides as well, Simon, very quickly.
Go for
it. First of all, this was all about collaboration, caring, learning, having fun. All of us, Scott, Simon, Flutter community admins, folks in the Flutter community, me, everyone, we're trying to bring a conference that is different, or we tried to bring you a conference that is different. It's fun, engaging, and also you learn a lot today. I hope that you did. Like particularly Simon's talk was very informative, to be honest. Stay tuned for more information. Anyway, so, and shout out to all of our speakers, because without these speakers, the conference doesn't mean anything, like at all. So the conference is great because of their speakers. So we really appreciate their effort behind recording these talks, preparing these talks, and sending us loves and good vibes. Thank you very much. And our sponsors, for sure, without these sponsors, Google, Invertase, Stream, CodeMagic, Superlist, Rebel App Studio, the AdSense Company, Very Good Venture, Software, DevAngels, Huawei, Microsoft, and Manning Publishing, this conference couldn't be live. So thank you, all of our sponsors. And last but not least, do not forget that we have our activities still in this platform. The platform will be actually open until tomorrow. So you can actually enjoy all of our virtual spaces. You can go to different rooms and try to do your networking while we are sleeping. Just make sure don't break the platform, because we need it for tomorrow. So, and well, tomorrow we also announce some of our winners, and some of our activities are ongoing until next week. So hopefully you will read all of the activities, you try to participate, and hopefully we will make announcement about all of our winners next week or weeks after. And I guess that's pretty much it from my side. Do you have any other comments or anything, Simon or Scott?
I think not much, but I think, yeah, everyone should sort of try and communicate together and get themselves one of those virtual rooms. Those virtual rooms are really great to talk to each other. So, yeah.
Yeah. And that's that. How did you do that? Okay. But that's the one thing that's really missing that we don't have compared to in-person conferences, is the ability to just wander around and talk to people and try the virtual rooms. Yes, I know that they're not perfect, but they're better than you think if you haven't used them.
Go play around a pool or do some fishing.
Yeah. And I've got two other things though about the conference in general. Number one, if you've never actually tried to put together a video talk, you have no idea what these people went through. Now live, it's a lot easier for me because if I make a mistake, I just keep going. Okay, I laugh it off and I keep moving. When you're doing a video, you're trying to make it perfect. And I had the experience of someone in GDG contacting me saying, hey, we need an intro for your GDG chapter. And can I have it in 48 hours?
Sorry to interrupt. I'm going to say goodbye because I have to dash. But I'll see you tomorrow.
Thank you. See you tomorrow, Simon.
See you, Simon.
Bye.
So the short version, I had 48 hours to do a 1-minute video. It took 27 tries in an hour to do a 1-minute video. Now imagine what it took these people. Okay, and in particular, Anna, 200 slides and doing that talk. That's just really, reach out to these people on Twitter and say thank you because you have no idea the work they put into this. Another thing that came to mind, and we are talking about it, if you are a beginner and you found yourself lost most of the time, we're aware of it. One of the problems that we run into sometimes is a lot of these other conferences don't have a lot of advanced content. And the content here was so incredible and so advanced. There were times I felt lost. And I've been doing Flutter since September of 2017. So, all right, that's all I have. I think
Very
somebody
good.
else
So
is
actually, you
telling
mentioned
me
a
it's
good
time.
point. We will actually publish all of the videos later in our YouTube channel. So we will provide a link to our Valhalla, rooms, so you will get the on-demand video section, so you can come and watch the videos. We will also publish it on YouTube, so you can watch all the videos later. If you need to rewatch them a couple of times, don't worry about it. We will publish all of these videos quickly, hopefully next week or maybe after conference. So that's it from me, Scott. And you put a lot of words, great, amazing advices and words. Anything else?
It's time for you to go fall down.
Definitely. For sure. So then thank you very much, everyone, for joining us for the last 8 hours. If you have spent time with us, this is amazing. We'll see you tomorrow then.